So where are we on this now? Is it trying to fix itself yet?
Yeah, so it wrote about 1,152 lines of code, and it just popped up a command starting to test it. Excuse me. So we see here all the files on the left-hand side that it created. This is essentially our live diff view that's available. And as we see, it's currently starting to actually test it out.
So this is the part where we just sit here and watch this for 3 minutes and I see nothing. No, what you see.
The good thing is that this is a very fast inference.
Yes.
So 1,100 lines of code.
Did it?
Tasks completed.
Do we know if this works yet?
Well, let's have a look. So it actually wrote some shell commands to test it. And when we check out the output of those, this actually looks pretty good.
Can we verify that?
To run it. Let's go verify it. So of course our agent came back and gave a summary of what it did. But let's just ask how to run this. Okay. So I'm going to go open up. So it says, this is how I can run the Ada version, and this is how I can run the Rust version. Let's run the Rust version. Perfect. Let's have a look in. Ooh, we might be hitting an actual bug.
An actual demo bug?
Let's have a look.
Let's see what happens.
No, just warnings.
Just warnings. Do we have an unwrap in there that we need to take care of? I heard that those things are dangerous.
So right now there's a REPL. Let's hit help, see what we're able to do. So it looks like we have a set of commands. I'm going to be lazy. I'm going to copy paste these queries to create table users. Okay, so far so good. Let's insert a record. Okay, well, let's find out if it actually did its job. So I start from users. Okay, we've got a record here.
That's nice.
Now, I want to actually, you see if I use the up arrow, it doesn't actually allow me to cycle through commands. Let's ask it to add a feature. Allows me to use the up arrow to cycle through. I think you'll understand my intent here.
The one thing we know about ISO is he actually does know how to read and write, but he can't type. So all those errors that you're seeing in there, yeah.
So it looks like the agent's identified a package that we can use. Let's just quickly look here, compare this to version 1. And it looks like it's adding a library called rustyline and changing the files accordingly. It's currently built it, and it looks like the build output is successful. There's some warnings, but I'll skip to clean those up later on. And it's now started to test it. Okay, apparently it works. It wrote itself a little bash script to test the history. It's wrote itself a little final demo script. So let's let it. Okay, so, and it gave us a summary. Well, now, how do I rerun this? I do kind of know that, though. So let's just.
You should know that. That was 30 seconds ago.
Let's build it, and let's run it again. Okay, let's do a help. And, oh yeah, that's the up arrow. It works.
Very nice.
Now, our models aren't just capable coding agents. They're capable in lots of areas of knowledge work. They're also emotionally intelligent. They're fun. They're great to write. Bedtime stories with for the kids. So I'm going to ask it to write me a poem about all these changes. But that's just more for fun.
So as I was saying, this is just an interface into our platform. There's other interfaces into it if you're inside one of those organizations that has adopted poolside. So this is the coding interface into it. But we also have other ways in which you can interact with it, web as well as an agent that you can download on your machine. But yeah, we don't really tout the poem writing or the song writing, though. I did send this to my wife to see, and I have been sending her love letters written by poolside. So I kind of hope that she did not enter this session to know exactly how I've been doing that for the past 6 months. But yeah, so this is kind of poolside. This is what we've been up to. So as I said, Malibu Agent is our second generation. We've got a ton more compute coming online, and that's when we're training our next generation. That is going to be the one that comes out publicly to everybody very early next year. We're going to have it behind our own API. It'll be on Amazon behind the Bedrock API. Anybody in the world who's building out any sort of, on one side, the engineering assistants like the Cursors, Windsurfs, Cognitions, Replets of the world, you can use ours, or if you use building out on any other side of the fence, the Harveys, the writers, the whatever applications of the world, there's going to be a fifth model out there that's going to be at that level that you can consume. But we're dead set on doing this and bringing this out to everybody in the world and kind of advancing that state of the art. We're just going to keep pushing that out. So that's kind of who we are. And you can find out very little more at our website since we don't put much out there. But ISO, anything else you want to say before you try to go make your flight this time, please?
So I would say that it's been a pretty incredible journey for the last 2.5 years of starting entirely from scratch and now building to a place where we see our models have grown up to become increasingly more intelligent. And kind of missing ingredient that we had was compute. And now that's unlocked for us, and with a large number of over 40,000 GB300s coming online, we see how we can start scaling up some of those models to get even further in their level of capabilities, software development, and other types of long horizon knowledge work. What I think is exciting about this conference and this audience is of all the work that's happening of evolving the form factor. Right now, what we looked at was this asynchronous way of operating with agents. But Jason, we have agents running that are doing tasks for hours, and I think in the near future we can see a world where they're able to start doing tasks in days in the coming years. And so I think the interface will continue to change. We're really focused on the fundamentals, building intelligence and being able to scale up and serve it. And it's why we go full vertical. It's why we go from our multi-gigawatt campus in West Texas, where we're building out data centers, to a team building out models. And the interface that you saw today is just our version of an expression. But I think this audience is going to do an incredible job of building lots of better versions of how to express using that intelligence into actually valuable, economically valuable work.
Couldn't have said it better. Can't wait to see what you guys build on this in the future when it's publicly available. And if anyone really does want to build a data center campus, we are hiring for that. It is weird to be putting shovels in ground again, like we did in the 90s and early 2000s, but that's what you got to do to scale intelligence these days. So
I would make one other non-scheduled statement.
Oh, no.
If you're going to be okay with this, Jason. As our models are getting more capable, we'd love to also see who wants to build with them. Right now, the vast majority of companies that are doing additional reinforcement learning and fine-tuning on top of models are doing it on what I would consider right now the best-in-class open-source models, the Qwens and Gimmies and Minimaxes of the world. And we'd like to start figuring out how we can partner with you with our models, anywhere from any checkpoint early on to where we are today, for you to be building closer together with us on top of things. We haven't really figured out the approach to it yet, but I think since we have this audience, it's not a bad place to put it out there. And so definitely reach out to us. We think the world till date was built by intelligence. The world in the future is being built on top of intelligence. And so it'd be a great way to partner.
Well, thanks, ISO. Thanks, everybody here. I know we do have 5 minutes left. I don't know if we're supposed to take questions, but I'm happy to. So if anyone does, but if not, I'm just going to go that way. What was that? Sort of. I mean, I think of him that way. Here's a fun story. Here's how I met ISO. I like to tell this story because ISO's a fun dude. I met ISO because it started with a failed acquisition at GitHub. So back when I joined GitHub in 2017 as a CTO, I wanted to take GitHub from a kind of collaborative code host with open source bent and turn it into an end-to-end software development platform infused by intelligence. And so the products that we launched from 17 on, GitHub Actions, packages, alerts, notifications, eventually code spaces, and then Copilot was the last thing that the office of the CTO did before I left, with Nat Friedman, who did more, and a couple of other folks inside there. But ISO, in 2017, when I joined, he had working code completion before the transform architecture had landed fully. He had on LSTMs. And so I quickly tried to acquire his company, and he just said no. So he just said no to me. But that was a long, drawn-out process talking about what we thought neural networks were going to mean for the world. And so during the process, which was a lengthy one, we became really good friends, and we stayed in close contact over the years. And then 22 rolled around, obviously ChatGPT comes out, Anthropic's out, and we kind of saw the end game at play. And we said, do we jump back in or not? And of course, yes, we jumped back in. But I like to tell a story about how he just kept saying no to me, and I just kept asking him questions, and eventually he said, yes, we should found a company. Because by the way, when I asked him if we should do this, he said, oh, goddamn no. That was his exact words. He's like, no, we should just learn how to patent sail. But here we are. So. Yeah.
It's been a great journey together, Jason. I think the reason we ended up doing this is because of our opinionated view on what it was going to take to build more capable intelligence. And the first 18 months of this company, obsessing and focusing on reinforcement learning combined with LLMs felt like one of the most contrarian opinions in the world. But I think today it's absolutely not. And it's super exciting to see the progress that's continuing to make. Like, in the coming years, we're going to see the world that started in completions and went to chat and is now agentic, increasingly approach more autonomous. And all of it is stemming effectively from a combination of bringing highly capable models that are constantly evolving together with real world problems. And I think what we're starting to see now is we're entering these kind of awkward teenage years ahead of AGI, where everybody in this room who's building out incredible companies and applications is bridging this gap of what it really takes to make intelligence that in its raw form actually be valuable. And we want to be a small, humble part of that. We've got a lot of work still ahead of us. The team is growing. But hopefully what you've seen today is what our customers and enterprises have been having access to and seen for a while, is that we're hard at work at really pushing those capabilities. We also want to make sure we make them available to build together with others.
Well, that's it. Thanks, everybody.
RL has boosted base models, but it's opaque and hard to scale across enterprises. But what if we could apply RL techniques to prompts instead of model weights? Here to show us how is the co-founder and CPO of Arise, Aparna Dinakoran.
Hi, everyone. Thanks so much for coming. Well, today I'm excited. We're going to talk a little bit about prompt learning and how to use that with evals. Any of you guys are spending a lot of time thinking about the frontier coding models? I think there's so much attention on them, but just what's not so obvious is how much time is actually spent on the system prompts for those building these coding agents. So here's actually a look. This is a tweet that went viral about the whole system prompt of Claude that's been leaked. I'm sure they've changed it since then. But you can actually see that Claude, there's Cursor, there's Klein, and just the length of the actual system prompt for each one of these. And I think what's not as obvious is these actually aren't just static. They're repeatedly iterated on. And it's such an important piece of context that actually goes into making these coding agents the most successful agents out there. It's not just us talking about it. Karpathy talks about it a lot. And this was a viral tweet that he posted, which was, there's this paradigm around iterating on these prompts that he's kind of coined it system prompt learning. And what he said is that it almost feels like humans learning, because they take back English feedback and use that to actually iterate on what they should do differently the next time. And I think he wrote something like, it's almost like that movie Memento, where the guy forgets what he learns, and then he starts writing it down and then uses that to actually kind of go through his next day. And so this is a little bit of the concept behind system prompt learning. And what we wanted to do was show you guys a little bit of how that works and then put that to test on two of the most popular coding agents, Claude and Klein, today. So first off, how does prompt learning actually work? So for those of you who are familiar with RL, what I thought we'd do is just do a little analogy, compare how does RL work versus system prompt learning. For RL, if we just took an analogy of a student who's trying to improve their exam scores, they take an exam, somebody grades the exam, you have a scalar reward, which is like, they got a 70%, an 80%, 90%, and then they have to figure out, almost blindly, just with that score, how to actually improve their score on the next exam. And I think this is actually one of the flaws of, RL works, don't get me wrong, amazing in so many concepts and domains, but it can be, a long path to actually figure out what the right solution is. And I think some of the things that we've noticed is that it can be sample inefficient. It takes a lot of data to get what you want. It's time intensive. It's data hungry. You need to have a whole data science team to do this. And it just might be overkill for teams who are trying to build agents because LLMs are already so good. So if you're a team who's actually trying to build an agent, maybe prompt learning is actually might be slightly more of an interesting paradigm for you. So in this scenario, same analogy, you have a student who's taking an exam, there's some exam score, except in this case, what actually gets outputted isn't just the score, they got a 70, they got an 80, but you also get back some kind of English feedback. Why did they get this answer right? What did they mess up on? Here's concepts that they missed on. What do they need to go study? And then they use this information to actually go and prepare on what to do next to get a better score. This is basically the concept that we applied to coding agents. And we ran this kind of test on both Claude as well as Klein. Both of these, as you know, start off with some kind of system prompt, which in Claude Code, this is kind of a snippet of it, and then they both kind of come with something that you can append rules to. So Klein has rules, CloudMD has the CloudMD file, and it starts off empty. You can go in and add whatever is important for your repo. So what we did was actually took, just benchmark both Klein and Claude Code on SweBench. I'm going to kind of run through this entire example with SweBench, but this entire thing we also ran on BBH and a ton of other software engineering data sets. But you can see here, just on vanilla Klein, vanilla Claude Code, nothing added to the CloudMD or the Klein rules, they had about, I think with Klein somewhere on, Claude Sonnet 4.5, it was about 30% of the GitHub issues actually resolved. Claude Code, it was about 40% of the GitHub issues resolved. So we took this as kind of our starting benchmark. And the thesis is could we actually use prompt learning to see if we can improve the system prompt and see if it was able to, with the new system prompt, actually give us a better score on these benchmarks. We didn't do anything on fine tuning. We didn't change the models, anything like that. It was just focused on the system prompt. And so the process that we went through, we took the coding agent, we had it actually write some code, we ran unit tests, and then we then passed that through to some kind of model that was doing the LLM as a judge evals. And I'll show you guys what that looks like. But the LLM as a judge eval actually gave back, why did it fail? Did it fail because of this? Can you give some examples of what were common scenarios that it didn't do good on? And then it actually used those kind of evals to then go back and add it to a meta prompt to come back with kind of the system prompt rules that we're going to append to. So let's talk through kind of the process. So first we had kind of the SweBench data set. SweBench in this scenario was just 150 examples. We did this for both Klein and Claude Code, where we took the original prompt, which had no rules. We gave it kind of the software engineering problem, and then it generated some kind of patch to actually solve that. And then we ran the generated solution through the unit test. Then whatever the unit test came back with, whether it was right or wrong, we then passed this into an LLM as a judge eval. And this is kind of the most important part because this actually generated the explanation for us. So we passed in the problem statement, we passed in what the coding agent solution was, the unit test, and then the actual solution that it came up with. Pass that in, and this that you're looking at in the center here is actually the LLM as a judge eval. And these evals, we're going to talk a bit about this, but eval engineering is a whole kind of concept that we spend a lot of time on, and writing really good evals is, I think, how you get the best kind of insight into what you can do to improve your agents. So in this scenario, what we did was we wrote a good LLM as a judge eval prompt. It outputted whether it failed or passed, and then this is the key part. We actually asked for an explanation. Why did it actually mess up? For specific libraries in the SweBench light test, it was parsing errors, or it was not handling. There's all sorts of actually different categories of errors. But we went through and we kind of looked at the explanation of what went wrong in each scenario. We then passed into a huge meta prompt. This is actually what's helping us iterate on our system prompt. We passed in the original Claude or Klein system prompt. We passed in the original rules, which for us started off empty. And then we passed in, here was the input, here was the LLM as a judge eval, and then here was the actual explanation from that eval. Passed that all into the meta prompt, and then we did kind of a diff comparing the old world. So just remember, the old world had the original Claude system prompt, no rules kind of added or appended to it, and then the new world where it generated this entire rules of what to avoid or what to what it had learned essentially from all those mistakes that it actually made. And then we ran this basically on the entire SweBench Lite again. And what we saw was that on 150 examples, we were able to get Claude Code up by 5%, more GitHub issues resolved, Klein 15%, and this was literally on, I think the key thing is like 150 examples of just training data that was used on the most kind of powerful coding agents that are out there. And so just think about kind of the impact that could have for your agents. Many of you guys in this room might be thinking, okay, well, prompt learning is cool, but how does that compare to GEPA? If you're familiar with DSPy and you've kind of seen, I don't know if it's GEPA or JEPA, I've heard both, but you guys might be asking, well, how is this different? So GEPA, just in case you guys aren't familiar, it's a prompt optimizer from DSPy that is essentially very, very similar to what we're talking about, which is taking English feedback, using that English feedback inside of the actual prompt. And what we did is actually run a side-by-side benchmark against GEPA, where we compared kind of our prompt learning against GEPA. And I think what we saw was that GEPA required many, many loops and rollouts compared to kind of a fraction of that, which was our approach. And I think the key difference here, the underlying approach around using English feedback is the same, but I think the key thing that was really different here was we spent a lot of time actually developing and iterating on the evals. And the eval prompts really mattered to making sure that you gave really good explanations back to the agent. And so evals make all the difference. This was super critical for us to be able to get this to work. And if you guys are curious about learning more, reading more about kind of what we do, check out kind of our blog. We write a lot about evals, prompt optimization, and we're actively hiring. So come check us out. Awesome.
When it comes to AI agents, theory doesn't always compile to production. Here to share hard-won lessons building effective AI coding agents is the creator and head of AI at Klein, Nick Pash.
Wow, it's wild to be on the same stage as so many people I've drawn inspiration from. Let's dive into it. My name's Nick, I'm the head of AI at Klein, and today I'm going to share some lessons we learned along the way. So let's start with the bitter truth. For years, we compensated for weak models by building clever scaffolds around them. All kinds of clever ideas like RAG, indexing systems, search trees, tool calling scaffolds, all this was invented to cope with weaker models. And frontier models simply bulldoze those abstractions now. You don't really need your scaffolding anymore. Your scaffolding just gets in the way of these models. And the question really isn't how fancy is your agent stack. Increasingly, it's how strong is the model driving it. And the lesson here is relentless. A perfect example of what I'm talking about is Gemini 3.0 released this week, and it immediately dominated terminal bench leaderboards with no agentic harness supporting it at all. In this chart, you can see Gemini 3.0 on Terminus scored better than the vast majority of model agent combinations in the world, all out of the box. And what's remarkable is that Terminus is designed to be an unopinionated, generic, stripped-down harness, and it has no graph search, no RAG, no indexing, just here's a terminal, go figure it out, and it crushes. The whole point of Terminus is that it has no clever tool calling, no context engineering features, so the takeaway here is that capability beats scaffolding. If you get out of the model's way, it will perform just fine. So really what I'm driving at, and the key takeaway from this whole talk is if you're building agents, just relax. Cool it with all your clever engineering tricks, stop overthinking it, that's it, that's the lesson. And another point on this, kind of like an aside, is I don't know about you guys, but we're all on Twitter, I'm on Twitter, and at this point, I just think talking about these like clever little context tricks and hacks is a little played out. Like at this point, I'm straight up tired of seeing some of this stuff, and like I get it, it's free engagement, and we all indulge in it a little bit. But personally, I think there's not really much signal there. So if you want the full playbook for building an effective coding agent, like the playbook's right here, it's up on the screen. There's really some novelty talking about it like months ago, but at this point, in my opinion, it's been done to death. And we've been in this, we're model agnostic at Klein. We support all the models. Every 2 weeks, there's a new big model release going out, and we basically come down to the same playbook of supporting each model as it comes out. So I'm sure everyone here knows how to tune an agent from Sonnet 4 to Sonnet 4.5, from Gemini 2.5 to Gemini 3, and GPT-5 to GPT 5.1. I feel like this entire conversation is a little played out. So I'm not really even gonna cover this in depth because the tweaks here are trivial and the gains are marginal. So what I really want to talk about is something that's not actually given a lot of attention, and it's the real bottleneck. And the real bottleneck is that you can build the cleanest agent in the world, but that doesn't improve model capability by even 1%. Models only get better when labs train on something hard. And benchmarks, not agent cleverness, not all your clever engineering techniques, not your clever RAG pipelines, it's benchmarks that determine what frontier models learn to do next. And models didn't magically get better at tool use. They got better because people built RL environments that forced them to practice certain actions. Handling failure modes, retrying, and for example, like agents improve only when the model learns inside the right environment. Every jump in reasoning we've seen came from a benchmark. Every jump in agent reliability came from an RL environment. So the real questions become, what is a benchmark? How do you turn real-world agentic coding data into an RL environment? And what makes a good verifier? How do you detect real difficulty? And how do you train these models to work on the problems that we actually care about as engineers? These are the questions that matter for the next frontier. So what is a benchmark? A benchmark, put simply, it's an environment. So in our case, it's like a Docker container where you let the agent run wild. It's a starting state, which is the snapshot of the code when you started working on a real-world coding task, as well as a starting prompt. And the last thing is a verifier at the end that checks whether an end state is correct or acceptable. So how are RL environments different? Well, here's the thing, they're not really different at all. You might notice this chart is basically the same thing as the previous slide. The only real difference, the only distinction here is how the reward is used. Benchmarks measure models, RL environments improve models. The score doesn't just stop in a leaderboard where you publish the results. The score is actually used to update the weights of the policy model. So how do you transform real-world coding data into useful RL environments for training? At Klein, we created the system called an RL environments factory, looking for a better name there, but that's what we got so far. And the first phase in this pipeline is you get sub-agents and you have them qualify tasks. And these sub-agents, they work in parallel to decide whether or not given tasks are suitable to be turned into RL environments for the purpose of training. And the qualification process goes as follows. You start with origins, so you have to validate, does the repository actually exist? Is the starting commit accessible? Is it open source? The journey, where you look at the starting prompts, the other follow-on prompts that the user might follow up with agents, you have to try to understand what was the user actually trying to accomplish, what was the spirit of their task. And lastly, it's the outcome. So can we find the actual commits or PRs that fix the problem in real life? Like, did they actually commit the solution to their problem later on in the timeline? And we're actively looking for easy disqualifiers as part of this. So things like vibe coded slop, we don't need another benchmark that tests for build an XJS app from scratch. We're looking to disqualify trivial tasks that are too easy and tasks that have no reliable start or end states. And lastly, what makes a good RL environment good? How do we actually make an RL environment? And what makes a good test or verifier? So phase 2 of this pipeline is building the actual RL environment. So you start out with archaeology, where you actually reconstruct both states locally. You pull down the code. You see if you can implement it yourself, reconstruct it, build it, and verify that the bug that the user was referencing and the solution actually exist. You document every obstacle and dependency. You containerize it with Docker, removing Git, obviously, so agents can't reward hack. And lastly, you define the verifier at the end. And this is where it gets into like a little bit of the art of building a good verifier. And I want to talk about this because the analogy that I typically give is a tea kettle. So let's say the user's goal is, I want to boil water. A really good example of a verifier to test whether or not the water is boiling is a little whistle attachment that goes inside your tea kettle. And the whistle is a pure outcome verification. It's an example of a pure outcome-driven verifier where the water either reached the boiling point or it didn't. Either it's whistling or it's not. The kettle doesn't care how you achieved it, whether you used a gas stove, an electric induction stove, or a campfire, it just signals the result. And in the process of doing this, all these weird bad tests can emerge. So you might have noticed like that the sub-agent might have noticed like, oh, in the ground truth solution, like in a previous run, the burner was set to high. So maybe we should be checking for that. But we all know that water can boil at a low setting on the burner. Or was it on the front left burner, has 5 minutes elapsed, like all kinds of weird bad tests. And the key point here is don't over-prescribe based on the ground truth. Test for the spirit of the task, test for the outcome of the task. And the outcome at the end of all this is a containerized benchmark or RL environment for that task. Agent work is recorded so you can see the traces, the trajectory that the agent took to complete the task, and you can reliably score it and verify it. It's fully portable. You can run it on any device. So the path to automation that we've been undertaking as part of this is, can we fully automate the process of converting real-world coding data into RL environments for the purpose of training models? And this work largely started out manual, but in the first time, the RL environment was like about 16 hours of my time. And what used to take 16 hours now takes less than 20 minutes per task. And we're building towards a fully automated RL environment factory where the bottleneck shifts from engineering to collecting high-quality tasks. And an interesting kind of point here, the natural endpoint of all this is, what if we actually built RL environments? This is like a question for everyone in the audience, is what if we built RL environments to test how well agents can actually make RL environments, kind of like a meta benchmark? What would hill climbing on that look like? And you can kind of start imagining that as models get really, really good at making their own RL environments to train on based on real-world user data, you kind of complete that loop. Something to think about. So, okay, this next part is the truth nuke, also known as Truc. An unspoken fact is that we're not alone at Klein building this kind of system. Every major agent lab captures this data. They all do some version of this behind the scenes, but no one really talks about it. And I don't even need to name them. If you know, you know, and realistically, you all know. These same companies cite internal benchmarks to justify legacy systems that they spent months maintaining. But curiously, you'll never be able to study or inspect them because they don't publish them openly. And this data is so valuable, yet no one shares it. It's the only thing that actually moves the needle. And here's the heart of my argument, is by standing between real-world engineers working on real-world tasks and the models, agent labs have a unique role in history. We can build better prompts, we can build better tools, but none of that improves the underlying models. We possess the single richest data set of real engineering work anywhere in the world. Models don't improve without this data, and keeping them closed is slowing down frontier research. So today we're announcing KleinBench. This is our attempt to finally create a benchmark that isn't cosplay engineering. It's not write me a server that generates Fibonacci sequences. This is real software development captured and packaged into standardized RL and eval environments. And this is the benchmark that we always wanted someone else to build. No one did, so we're doing it, and anyone can participate. So here's how it works. The whole thing is open source. There's no secret sauce, no locked away data sets. You can openly run it yourself and inspect it to see how it works. Anyone can use these environments for SFT, RL, evals, whatever. The point is to just give the entire ecosystem a real substrate to measure and improve models on, not just leak code puzzles. And this only works if the community contributes. And the good news is you don't actually need to do anything special. Just work on your open source project with the client provider turned on and opt into the KleinBench initiative. If a frontier model gets stuck and you step in to fix it, that's actually an ideal task to be a candidate for a benchmark. And that's it. Just use the client provider, see where the model struggles, and we'll pick it up and introduce it into this open source benchmark. So KleinBench will always remain free, fully open source, and freely accessible. Thank you all. If you want to contribute. Thank you. you want to contribute.
If benchmark scores for AI coding agents are so high, what explains the problems developers and teams face when working with them? Here to provide us with a few explanations is meta researcher Joel Becker.
Hey guys, thank you so much for having me. My name is Joel Becker. I work as a researcher or member of technical staff at META, which stands for Model Evaluation and Threat Research. As we'll see in a second, I'm going to be talking about AI capabilities. How do we know how performant AIs are today, how performant they might be in the near future from these two different sources of evidence that seem to give somewhat conflicting answers. You know, I could have done this whole talk without reference to META papers in particular, but we'll look at two papers I've been involved with as examples of benchmark-style evidence and then more economic-style evidence. On the benchmark side, measuring AI ability to complete long tasks. This is the paper that comes with the charts that many of you would have seen on Twitter and so on that META is well known for. And then the second, this RCT, measuring how allowing AI affects developer productivity. And then we'll be talking about how to reconcile the gap that's implied between these two different kinds of measurements. As I mentioned, META stands for Model Evaluation and Threat Research. We are an independent research non-profit that seeks to inform the public, policymakers, labs, about the degree to which AIs might pose catastrophic risks to society. The model evaluation part means that we seek to understand AI capabilities and propensities, and the threat research part means we try to connect those capabilities and propensities to potential potential catastrophic risks. Okay, the first paper we're going to talk about, associated with this chart that many of you I think might have seen. Taking a step back first before we dive into the paper, how usually do we think about measuring AI capabilities using benchmarks on a SWE-bench or a GPQA, so on and so forth? There's some notion of 0% performance or random performance, so for GPQA that's 25%, which corresponds to this floor, the worst you can possibly do. Perhaps there's a human baseline that's below 100% for GPQA. I think this is something like 75% that represents maybe expert human performance. And then of course you can go all the way up to 100% potentially on these kinds of benchmarks. But what does it mean? If I'm getting 50% on GPQA, if I'm like half the way from the floor to the expert baseline, what does that really mean about how performant the AIs are? If I meet the human baseline, does that mean that the AIs are now as performant or even more performant than expert humans in a relevant sense that I care about? It's hard to interpret. Another thing that you see from this graph is that benchmarks seem to have less and less time between coming online, sort of giving any signal at all, and being fully saturated. It's harder and harder to create benchmarks that have plenty of signal that might be informative to us about how capable models are for an extended period of time. So we're going to go about this a different way. First, we're going to gather human baseline data for diverse tasks spanning a range of difficulties. You should think of these humans as, experienced experts, but on their first day or first week on the job. These are not people with context on the tasks in particular. It's not exactly the kind of thing that's come up in their work before, but if it's a software engineering task, they're a relevantly skilled general software engineer. Same for the machine learning tasks and the cybersecurity tasks here that we'll talk about. The type of tasks come from these three buckets or task distributions. HCAST, which is a collection of software-based tasks seemingly requiring autonomy, interacting with tools, interacting with the environment, thinking through the problem, not just this kind of Q&A style data set. The SWA suite, which are these atomic problems. These are problems that maybe GPT-2 can do, maybe it can't. Problems like, here are 4 files. One of them is called passwords.txt, which file contains the passwords. And then on the other end of difficulty, we have RE-bench, which are challenging, novel, open-ended machine learning research engineering challenges, which are very difficult even for top human experts. In addition to gathering the human baseline data, we'll also, under as close to identical conditions as possible, measure AI performance for the AIs that we're interested in on the same set of tasks. And then we're going to convert the time it takes for humans to complete these tasks into an estimate of AI autonomous capabilities, as I'll show you in a second. Here's an illustrative diagram, in this case for Claude 3.7 Sonnet, which was the front-end model at the time that this paper came out. You can see that for the very short tasks, something like 4 minutes or below, Sonnet is getting the answers correct, essentially 100% of the time, or maybe even here, literally 100% of the time. For the very hardest tasks, it's struggling, and then there's some range where we're kind of in the middle, somewhere between 10 and 90%. I'll say that this empirical pattern, where models are less performant at tasks that take humans longer, is it's not a fact of nature, but it's something that we see pretty commonly, pretty robustly across models, at least on this task distribution, and I conjecture for other task distributions as well. So we try and fit this dark purple line to something like this data on how long it took humans to complete the relevant tasks that the models are attempting, and then we call the point on the x-axis, this horizontal axis, this human time to complete axis, at which we predict the models will succeed 50% of the time, the time horizon of those models. There's much debate in the 50% number. I can talk later about the reasons why we chose that. And then we'll do the same exercise for the other models. So here I have Claude 3 Opus has a time horizon of something like 4 minutes. That's where we're predicting that it has a success probability on this task distribution of 50%. For O1 Preview, I'm seeing something like 15 minutes, so on and so forth. And then, of course, all these models, they come out over calendar time. So if we plot the time horizon, the x-coordinate on this set of plots, the time horizon, the x-coordinate on this set of plots against calendar time, we find something like this. It looks, kind of like an exponential trend that's going up at some constant rate. In fact, it doesn't just look like an exponential trend. If we had a perfectly straight line here, it would indicate a perfectly exponential trend. We see something really remarkably steady, actually much more steady than we were anticipating when we went about doing this research project. And that's continued to be the case. So many of you will have seen updates that we've made of this graph on Twitter. This is going all the way up to GPT 5.1 Codex Max, so extremely recent. The predictions from this shockingly straight line have held up very well, I think. Taking a quick step back, what are benchmarks telling us, or here kind of benchmark-like evidence? Well, one thing is that AIs can succeed at what for humans would be exceedingly difficult tasks. The tasks in REbench are really far beyond my capabilities personally, and the AIs are having a good crack at them some decent percentage of the time. And the second, kind of obvious, is that progress is rapid. On the other hand, how much stock should we put in the evidence suggested by benchmarks? What limitations might they have? Lots, but here are three that I'll note. One is, as I mentioned, these are humans who are expert in some relevant sense, but they're low context. It's something like their first week on the job. They haven't seen tasks exactly like this previously. They just have some relevant experience. Presumably people who were more sort of, not just having the relevant experience, but also highly familiar with the set of tasks would perform the tasks even sooner, and then we think relative to those people, the AIs were more performant. The second is that benchmarks can be low ceiling. Even GPQA, I'll use that example again, we're beginning to get to the point where that benchmark is totally saturated, not providing additional information for marginal models, whereas time horizon is providing this nice way to sort of chain benchmarks together in some sense over time. But nonetheless, it's still very hard to create these ever harder tasks when the time horizon of models is doubling every something like 6 to 7 months. So even time horizon might be saturated in not too long, or the benchmark's underlying time horizon. And the next one is not a concern that's limited to the meta task, to the task behind time horizon. It's also true for SWE-bench. It's also true for many of your favorite agentic benchmarks. The problems aren't very messy in some sense. They don't require a ton of coordination with humans. They're often in relatively small, contained environments where not much can go wrong. Not these sort of massive open source code bases, or other ways in which the problems can involve more interaction with the real world, or be messy in some sense. So we did this project, and then early this year we were trying to think about how can we attack some of these limitations. What's a different source of evidence that might have its own pros and cons, but importantly be more externally valid in the scientific jargon? Perhaps field experiments are the answer, so more economic style evidence. So here we might be interested in very high context developers who are expert on the kinds of tasks they're already doing. Speed up, or some notion of productivity boost, it seems to have more signal through even some superhuman according to benchmarks range. Perhaps GPQA is fully saturated and you're getting a 1.5x, 2x speed up, something like that, but you can still achieve a 3x, 4x, 5x speed up. Even after that, we maintain more signal. And the last is that the tasks are messier. They are tasks that are coming up in people's real work. They're not synthetic. They're not small and contained. This is a real deployment scenario. Here's what we're going to do. For this paper, we're going to gather 16 experienced developers on large, mature open source projects we'll go through in a second. Each of these developers will, on average, complete about 16 tasks from their real work. These are these issues on the relevant GitHub repositories, the kind of thing that they might otherwise have completed, with the caveat that the very longest issues we're not going to include. The tasks will be randomly assigned to AI disallowed or AI allowed. AI disallowed means what you think it means. It means software development in 2019. It means no AI-powered tab autocomplete. It means no cursor agentic coding tools. It means no LLMs via the web UI. Or they can be randomly assigned to AI allowed, in which case everything's on the table. Any of the AI tools I just mentioned, or not using the AI tools. If you're in AI allowed condition, you're not compelled to use AI, you just have the option. And we buy these developers Cursor Pro. So for the most part, that's the tool that they're using, with typically 3.6 or 3.7 sonnets at the time. Which was the front-end model when we conducted this work. And then we're going to record the time it takes for the developers to complete each task and see the degree to which they might save time when AI is allowed versus when it's not. These are some of the repositories. Many of you will be familiar with them. We've got the Haskell compiler represented. We have scikit-learn. We have Hugging Face transformers. These are, on average, 1 million lines of code plus. They've been around for 10+ years. The developers who are going to be working on these repositories as part of this study are, on average, the third top contributor out of hundreds or even in some cases thousands of contributors to these repositories. They personally have been contributing to the repository for something like 5 years on average. These are top experts. Some of you might have seen this graph too and said the punchline's been spoiled. For the rest of you, we asked economics experts, machine learning experts, these are people at major AI companies and labs, top academics, some graduate students, so on and so forth, how much they expect developers to save time when they're using AI. They say something like 40% or a little bit less. We asked the developers themselves, the study participants, how much they expect to be sped up ahead of time, and they say something like 24 or 25%. Then we asked the developers, after the study has been completed, how much they think they were sped up in the past by AI being allowed on the issues they completed as part of the study, and they say that it would have sped them up by something like 20%. And the punchline is that we find that developers are slowed down by 19%. They take 19% more time when AI is allowed relative to when AI is not allowed. When I first saw the data coming in, saw sort of early versions of this plot, I thought presumably the same thing that many of you might be thinking right now, that we've messed something up, that something's gone wrong, there's some issue in how we've set up the experiments. How could it possibly be the case? At least these developers have access to the 0 points because they cannot use AI at any time. So we poured over many hours of screen recordings from these developers working on issues as part of the study. We looked to dive into a bunch of hypotheses that might explain what's going on and try to categorize the things that we think are going on versus not. Many of this is listed in the paper. I'll just quickly go through some of the things that we think are contributing. First, over-optimism about AI usefulness. That seems like an obvious one. The developers, even after the study's completed, they think that AI is going to be helpful to their work. It makes sense they might overuse AI on that basis. Two more, implicit repository context and high developer familiarity. These developers are coming to these problems already knowing the solution to the problem. They're so expert in this work. I imagine them as not trying to spend a bunch of time thinking through the solution that the AI can work through. Instead, they're just limited by how fast they can type, which means that using AIs, instructing AIs to do it, comes with some significant time cost versus how they might otherwise have spent their time. I think many of us have the sense that AIs might be less performant on large and complex repositories, which is different from this benchmark-style evidence or from some previous work. And then low AI reliability. Maybe the AIs are very performant on these kinds of tasks, but they're only performant 50% of the time, or 80% of the time, 20% of the time. And so at the very least, you need to check their work afterwards, and perhaps even you need to spend time correcting their work afterwards, which is something we see quite a lot on these issues. One thing from the factors with an unclear effect that I'll mention briefly, I have to talk to people about later, is below average use of AI tools, which came up in the public discussion. This is in the unclear column because it's sort of evidence for and against. That's true for many of the things here. We don't have anything so conclusive to say. We're still working on this line of work. Here are some caveats, all important. First, obviously, we do not provide evidence for all software developers or tasks. These are extremely experienced developers working on extremely complex, long-lived, open-source repositories. I, in my own work, am not as expert in the relevant sense as these people are. I'm working on much smaller repositories. I feel more comfortable saying that even at this time, I was fed up by AI tools, even if the developers weren't. This setting is weird. It's weird for the same reasons that it's interesting, this unusual developer population. Second, the experiment is concentrated in March 2025. As I mentioned, we know that AI progress is rapid. Perhaps this result will have already changed by the time I'm giving you this talk. So this kind of puzzle suggested, right? The benchmark-style evidence is giving a very impressive sense of what AI capabilities look like today, whereas the more economic style, I include labor market impacts working here too, in addition to our field experiment, looks somewhat more bearish or unimpressive. Why is the former not translating to the latter? At least naively, there seems to be a clash. How might we go about resolving this puzzle? So one possibility is that, in fact, we messed something up. This is still live and on the table. Maybe the developers really are not very capable at using AI, and if we continue to run this experiment, as in fact we are, they'll learn more familiarity with the tools and so get productivity benefits that they weren't getting at the time. I'm a little skeptical of that story, but that's one possibility. Another that economists like to bring up is that we're not incentivizing these developers to finish quickly. We're paying them per the hour, which we do for external validity reasons. Looking through their videos, I really do not think they're developing differently in accordance with these incentives, but that certainly is one possibility that's on the table. Another more statistical in nature possibility is, this is a small study. You shouldn't over-update so much from small studies. We are doing big things that I'm excited to release at some point. Okay, but let's assume we haven't messed something up, and this is a result that we think does hold up. How could we resolve the puzzle? So one possibility, as I alluded to briefly, is that reliability needs to be very high to save time. That you need to be getting the answers to these problems that developers are putting in correct, something like 95, 99% of the time, in order for developers to tap through and not spend lots of time verifying the AI's work, which of course is pretty costly from a time perspective. Another possibility is SWE-bench-like or algorithmic costless scoring at the margin versus mergeability-like scoring. SWE-bench scores are not trying to account for whether the code is build onable by other people in future, or whether it's matching quality considerations that aren't considered by the unit tests. Perhaps AIs really are performant according to SWE-bench-like scoring, but not performance according to this kind of more holistic scoring that we might care about. Low versus high context baseliners, I mentioned previously, these are just much more skilled humans. Relative to those humans, perhaps the AIs are less capable. Task distribution, maybe these are just different kinds of tasks, in particular less messy than the benchmark style task. Maybe that's explaining what's going on here. Suboptimal capability elicitation, a huge amount of work has gone in at Meta to making the agents as performant as possible, given the underlying models on all kinds of tasks. And that involves churning through a load of AI tokens. Perhaps that's less the case for Cursor in particular at the time when we completed the study. And then interdependence across tasks. Maybe it's the case that if humans can complete task A and task B, AIs can only complete task A but not task B, and of course can do task A faster, then it still makes sense for humans to do task A and task B, not delegate task A, because they need to know the outputs, they need to know how task A was completed in order to reliably complete task B. I think that's part of what's going on. You need to maintain context as you're working through these subtasks. Lastly, I will say that we are hiring, not just for this kind of work that you've seen being extended, ever longer tasks, ever more ambitious RCTs, even more sources of evidence from which we can triangulate the truth about AI capabilities, but also for much more besides. You can find this at meta.org/careers. In particular, I'm excited about research engineers, research scientists who might be hiding in the current audience. We're excited not just for research types with academic experience, but very much for scrappy startup people as well. And we're also hiring for a director of operations. And with that, thank you very much for listening.
Our final presenter is here to speak about Google's first agentic development platform, Anti-Gravity. Please join me in welcoming to the stage engineer at Google DeepMind, Kevin Ho.
Woo! All right, hello. Last one of the day. Can we get a little energy boost? Who's ready? Who's ready? All right, happy Friday. I hope everyone has had a good week, a good conference. And let me tell you, it's been a really bad week if you're Gravity. Wicked 2 is coming out tonight. And then, of course, Anti-Gravity came out earlier this week alongside Gemini 3 Pro on Tuesday. Google Anti-Gravity is a brand new IDE out of Google DeepMind. It's the first one from a foundational lab, and it is coming right off the press. In fact, I probably should be working on the product right now, but I wanted to spend some time to share what we built here today. Anti-Gravity is unapologetically agent first. And today I'm going to tell you a little bit about what that means and how it manifests in the product. But perhaps maybe a little bit more interestingly, we're going to talk a little bit about how we got here. Product principles, direction of the industry, these sorts of things. So my name is Kevin Ho. I lead our product engineering team at Google Anti-Gravity. And let's start with the basics. And first, just to get a sense of the room, who has used Anti-Gravity? All right, there you go. Power of Google. Love it. Who's used the agent manager? Cool. Nice. Good. Good. All right, so basics of Anti-Gravity. Anti-Gravity, notably anti-gravity, not anti-gravity. Anti-Gravity, it's an AI developer platform with 3 surfaces. The first one is an editor. The second one is a browser. And the third one is the agent manager. So we'll dive into what this means, what each looks like. So a paradigm shift here is that agents are now living outside of your IDE, and they can interact across many different surfaces that your agent, or that you as a software developer might spend time in. And let's start with the agent manager. So that's the thing up top. This is your central hub. It's an agent-first view, and it pulls you one level higher than just looking at your code. So instead of looking at diffs, you'll be kind of a little bit further back. And at any given time, there is one agent manager window. Now you have an AI editor. This is probably what you've grown to love and expect. It has all the bells and whistles that you would expect. Lightning fast autocomplete. This is the part where you can make your memes about, yes, we forked VS Code. And it has an agent sidebar. And this is the sort of thing. It's mirrored with the agent manager. And this is when you need to dive into your editor to accomplish maybe your 80% to 100% of your task. And at any point, we made it very, very easy, because we recognize not everything can be done purely with an agent, for you to Command E or Control E and hop instantly from the editor into the agent manager and vice versa. And this takes under 100 milliseconds. It's zippy. And then finally, something that I love, an agent-controlled browser. This is really, really cool. And hopefully for the folks in the room that have tried Anti-Gravity, you've noticed some of the magic that we put in behind here. So we have an agent-controlled Chrome browser. And this gives the agent access to the richness of the web. And I mean that in 2 ways. The first one, context retrieval, right? It has the same authentication that you would in your normal Chrome. You can
Got it. What else?
give it access to your Google Docs, you can give it access to your GitHub dashboards and things like that, and interact with the browser like you would as an engineer. But also, what you're seeing on the screen is that it lets the agent take control of your browser, click and scroll and run JavaScript and do all the things that you would do to test your apps. So here, I put together this random artwork generator. All you do is refresh and you get a new picture of a piece of Thomas Cole artwork. And now we added in a new feature, which is this little modal card. And the agent actually went out and said, okay, I made all the code, but instead of showing you a diff of what I did, let's instead show you a recording of Chrome. So this is a recording of Chrome where the blue circle is the mouse, it's moving around the screen, and in this way you get verifiable results. So this is what we're very excited about our Chrome browser. And then the agent manager can serve as your control panel. The editor and the browser are tools for your agent, and we want you to spend time in the agent manager. And as models get better and better, I bet you're going to be spending more and more time inside of this agent manager. And it has an inbox. And I'll talk a little bit about this and sort of why we did this. But it lets you manage many agents at once. So you can have things that require your attention. For example, running terminal commands. We don't want it to just kind of go off and just run every terminal command. There are probably some commands that you want to make sure you hit OK on. So things like this will get surfaced inside of this inbox. One click, you can manage many different things happening at once. And it has a wonderful OS level notification, so if there is something that you need, it will sort of let you know. And this kind of solves that problem of multi-threading across many tasks at once. And so our team is thrilled to launch this brand new product. It's a brand new product paradigm, and we did so in conjunction with Gemini 3, which is a very exciting week for the team. But alas, we ran out of capacity. This has been tormenting me the last couple of days. And so I apologize. On behalf of the anti-gravity team, I'd like to apologize for our global chip shortage. We're working around the clock to try and make this work for you. Hopefully we'll have a few less of these sorts of errors. But what's been really exciting is people who have used the product have seen what the magic of combining these three surfaces can do for your workflows, for your software development. So let's talk about it. Why did we build the product? How did we arrive at this sort of conclusion? You might say, oh, adding in a new window, it's pretty random, right? It's this one-to-many relationship between the agent manager and many other surfaces. And it's important to remember, I've been at this conference a couple of times, and every single time there is this theme. The product is only ever as good as the models that power it. And this is very important for us as builders, right? Every year there was this sort of new step function. There was a year when it was autocomplete, right? Copilot. And this sort of thing was only enabled because models suddenly got good at doing the short form autocomplete. And then we had chat. We had chat with RLHF. Then we had agents. So you can see how every single one of these product paradigms is sort of motivated by some change that happens with model capabilities. And it's a blessing that our team is able to work and be embedded inside of DeepMind. We had access to Gemini for a couple of months earlier, and we were able to work with the research team to basically figure out, what are the strengths that we want to show off in our product, what are the things that we can exploit, and then also what are the gaps, right? This desired experience. Where are the gaps in the model, and how can we fix that, right? And so this was a very, very powerful part of why anti-gravity came to be. And there are 4 main categories of improvements, powered by a little Nano Banana artwork. The first one is intelligence and reasoning. You all are probably familiar with this. You used Gemini 3, and you probably thought it was a smarter model. This is good. It's better at instruction following. It's better at using tools. There's more nuance in the tool use. You can afford things like, there's a browser now. There's a million things that you can do in a browser. It can literally even execute JavaScript. How do you get an agent to understand the nuance of all these tools? It can do longer running tasks. These things now take a bit longer, right? And so you can afford to run these things in the background. It thinks for longer. Just time has gotten stretched out. And then multimodal. I really love this property of what Google has been up to. The multimodal functionality of Gemini 3 is off the charts, and you start combining it with all these other models like Nano Banana Pro, and you really get something magical. So we have these roughly 4 different categories where things have gotten much better. And if you think about these properties, the question becomes, what do we do about these differences? And from a product perspective, it's like, how do you construct a product that can take advantage of this new wave? And hopefully, in my opinion, this is the next step function. Autocomplete, chat, agents, and then I probably got to come up with something more interesting than whatever this thing is called. So step 1 is we want to raise the ceiling of capability. We want to aim higher, have higher ambition. And so a lot of the teams at DeepMind were working on all sorts of cutting-edge research, right? Google's a big company. One of my learnings going from a startup to one of these bigger companies is that there is a team of people that is attacking a very, very hard technical problem. And as a nerd, this is super exciting, right? And then as a product person, it's like, wow, we can start using computer use. So browser use has been one of these huge unlocks. And this is twofold, right? I mentioned the sort of retrieval aspect of things. I guess for software engineers, there's much more that happens that is beyond the code, right? You can roughly think about it as there's what to build, there's how to build it, and then you actually have to build it. I would say building it has become more or less, it's reasonable for the model to now, given context, it can generate the code that hopefully functionally works. And then you've got the what to build. This is the part that is up to you, kind of human imagination. And then there's the how to build it, right? And there's this richness in context, the richness in institutional knowledge, and these are the sorts of things that having access to a browser, having access to your bug dashboards, having access to your experiments, all these sorts of things that now gives the agent this additional level of context. And maybe I should have clicked before, but if you saw on the screen, let's see, how do I do this? So this is now the other side of things, browser as verification. So you might have seen this video. This is a tutorial video that we put together on just how to use it. But this is the agent. The blue border indicates that it's being in control by the agent. And so this is a flight tracker. You put in a flight ID, and then it'll give you sort of the start and end of that flight. And this is being done entirely by a Gemini computer use variant. So it can click, it can scroll, it can retrieve the DOM, it can do all the things. And then what's really cool is you end up with not just a diff, you end up with a screen recording of what it did. So it's changed the game, and the model can take this, and because it has the ability to understand images, it can take this and iterate from there. So that was the first category, browser use, just an insane, magical experience. Now the second place that we wanted to spend time is on image generation. And we noticed this theme when I first started at Google. We noticed, okay, Gemini is spending a lot of time on multimodal. And this is really great for consumer use cases, right? Nano Banana 2 was mind-boggling. But also for devs. Devs are inherently, this is a multimodal experience. You're not just looking at text. You're looking at the output of websites. You're looking at architecture diagrams. There's so much more to coding than just text. And so there's image understanding. This is verifying screenshots, verifying recordings, all these sorts of things. And then the beautiful part about Google is that you have this synergistic nature. This product takes into account not just Gemini 3 Pro, but also takes into account the image side of things. And so here I want to give you a quick demo of mockups. So I have a hunch, and you all probably believe this too. Design is going to change, right? You're going to spend maybe some time iterating with an agent to arrive at a mockup. But for something like, oh, let's build this website, we can start in image space. And what's really cool about image space is it lets you do really cool things like this. We can add comments. And so you end up commenting and leaving a bunch of queued up responses. And it's kind of like GitHub. You'll just say, all right, now update the design. And then it'll put it in here. The agent is smart enough to know when and how to apply those comments. And now we're iterating with the agent in image space. So really, really cool new capability. And what was awesome is that we had Nano Banana Pro. We pulled an all-nighter for the Gemini launch because that was our first launch. Then they said, do it again, do it on Thursday. So we made Gemini Pro, or I'm getting all these model names confused. The image gen one, the Nano Banana one, we made that available on day one. I'm running on very little sleep. On day one inside of the anti-gravity editor. And our hope is that the anti-gravity editor is this place where any sort of new capability can be represented inside of our product. And so step 2 was, all right, we have this new capability. We've pushed the ceiling higher. Agents can do longer running tasks. They can do more complicated things. They can interact on other surfaces. And so this necessitates a new interaction pattern. And we're calling this artifacts. This is a new way to work with an agent. And this is one of my favorite parts about the product. And at its core is this agent manager. So let's start by defining an artifact. An artifact is a dynamic representation of something that the agent generates. Sorry, it's an artifact. Is something that the agent generates that is a dynamic representation of information for you and your use case. And the key here is that it's dynamic. Artifacts are used to keep the agent organized. They can be used for kind of like self-reflection and self-organization. It can be used to communicate with the user, to maybe give you a screenshot, to maybe give you a screen recording like we described. And it can also be used across agents, whether this be with our browser sub-agent or with other conversations or as memory. And this is what you see on the right side of this agent manager. We've dedicated sort of half the screen and your sidebar to this concept of artifacts. And so we've all tried to follow along chain of thought. And I would say this, we did some fanciness here inside of the agent manager to make sure conversations are broken up into like chunks. So in theory, you could follow along a little bit better in the conversation view, but ultimately you're looking at a lot of strings, a lot of tokens. This is like very hard to follow. And then this is actually like, there's like 10 of these, right? So you just scroll and scroll and scroll and you're like, what the heck did this agent do? And this has been traditionally the way that people review and sort of supervise agents. You're kind of just looking at the thought patterns. But isn't it much easier to understand what is going on inside of this visual representation? And that is what an artifact is. The whole point, and the reason why I'm not just standing up here and giving you this long stream of consciousness, is because I have a PowerPoint. The PowerPoint is my artifact. And so Gemini 3 is really, really strong with this sort of visual representation. It's really strong with multimodal. And so instead of showing this, which of course we always let you show, we will always show you this, but we want to focus on this. And I think this is the game-changing part about anti-gravity. And the theme is this dynamicism. The model can decide if it wants to generate an artifact. And let's remember, there are some tasks, we're changing a title, we're changing something small. It doesn't really need to produce an artifact for this. So it will decide if it needs an artifact. And then second, what type of artifact? And this is where it's really cool. There are many potentially infinite ways that it can represent information. And so the common ones are Markdown in the concept of a plan and a walkthrough. So this is probably what you've used most often. When you start a task, it will do some research, it will put together a plan. This is very similar to like a PRD. It will even list out open questions. So you can see in this feedback section, it'll surface, hey, you should probably answer these 3 questions before I get going. And what's really awesome, and we're betting on the models here. What's really awesome is that the model will decide whether or not it can auto-continue. If it has no questions, why should it wait? It should just go off. But more often than not, there are probably areas where you may be underspecified. Or maybe it did something during research, right? Everyone has gone through and started a big refactor and realized they actually don't have all the information ahead of them. They got to go back to the drawing board, maybe talk to some people. Same idea. So it'll surface open questions for you. And so you'll start with that implementation plan, and then you'll say, all right, LGTM, let's send it. You'll go all the way down. It might produce other artifacts. We've got a task list here. This is the way that you can monitor the progress of the agent instead of looking at the conversation. You might put together some architecture diagrams, and then you'll get a walkthrough at the end. And this walkthrough, you kind of saw a glimpse of this before, but it is, hey, how do I prove to you, agent to human, that I did the correct thing and I did it well? And then this is the part that you'll end with. It's kind of like a PR description. And then there's a whole host of other types, right? Images, screen recordings, these mermaid diagrams. And really what's quite cool is that because it's dynamic, the agent will decide this over time. So suddenly there's maybe a new type of artifact that we missed, right? And then it'll figure that out. It'll just become part of the experience. So it's very scalable. But this artifact primitive is something that's very, very powerful that I'm pretty excited about. And then I guess another question is, why is it needed? So we'll always explain to the user what the purpose of this artifact is. And then interestingly, who should see it? So should the sub-agent see it? Should the other agents see it? Should other conversations see this? Should this be stored in my memory bank, right? If this is something that I derived, one of the cool examples that I like is if you give it a piece of documentation and give it your API key, it'll go off and run curl requests to basically figure out the exact schema of what the types of APIs you're using. And it'll do this deep research for quite a while. And then it'll give you a report and basically deeply understand this sort of API. You wouldn't want to just throw that away and have to rederive it the second time you did this. So it'll store it in your memory. And then all of a sudden that's just a part of your knowledge base. So, and then there's also this idea of notifications, right? So if there's an open question, you want the agent to be proactive with you. And that's another very cool property of this artifact system. We want to be able to provide feedback along this cycle. So from task start to task end, we want to be able to provide feedback and inform the agent on what to change. And the artifact system lets you iterate with the model more fluidly during this process of execution. And so not to sound like a complete Google shill, but I love Google Docs, right? Google Docs is a great pattern. It's awesome. The comments are great. And this is how you might interact with a colleague, right? You're collaborating on a document, then all of a sudden you want to leave a text-based comment. So we took inspiration from that. We took inspiration from GitHub. But you leave comments, you highlight text, you say, hey, maybe this part needs to get ironed out a bit more. Maybe there's a part that you missed, or actually don't use Tailwind, use vanilla CSS. So these are the sorts of comments that you would leave, you batch them up, and then you go off and send. And then in image space, this is very cool. We now have this Figma style, drag and drop, or not drag, highlight to select. And now you're leaving comments in a completely different modality, right? And we've done this and instrumented the agent to naturally take your comments into consideration without interrupting that task execution loop. So at any point during your conversation, you could just say, oh, actually, mid-browser actuation, I actually really don't like the way that turned out. Let me just highlight that, tell you, send it off, and then I'll just get notified when you're done taking into consideration those comments. And so it's a whole new way of working. And this is really at the center of what we're trying to build with anti-gravity. It's pulling you out into this higher level view. And the agent manager really is built to optimize the UI of artifacts. So we have a beautiful, beautiful artifact review system. We're very proud of this. And it can also handle sort of the property that is parallelism and orchestration. So whether this be many different projects, whether this be the same project and you just want to execute maybe a design mockup iteration at the same time you're doing research on an API, at the same time you're iterating and actually building out your app, you can do all these things in parallel. And the artifacts are the way that you provide that feedback. The notifications are the way that you know that something requires your attention. It's a completely different pattern. And what's really nice is that you can take a step back. And of course, you can always go into the editor. I'm not going to lie to you. There are tasks that you maybe don't trust the agent yet, you don't trust the models yet. And so you can Command E, and you can Command E, and it'll open inside the editor within a split second with the exact files, the exact artifacts, and that exact conversation open, ready for you to autocomplete away to continue chatting synchronously to get you from 80% to 100%. So we always want to give devs that escape hatch. But in the future world, we're building for the future. You'll spend a lot of time as agent manager working with parallel sub-agents. Right? It's a very, very exciting concept. Okay, so now that you've seen we've got new capabilities, multitude of new capabilities, we've got a new form factor. Now the question is what is going on under the hood at DeepMind? And the secret here is a lesson that I guess we've just learned over the past, I don't know, we've spent or I personally spent 3 years in CodeGen, just to be your biggest user, right? And that creates this research and product flywheel. And so I will tell you, anti-gravity will be the most advanced product on the market because
get a 5-point improvement, but when they scale to 1,000 examples, the improvement jumped to 10 points. So the number of high-quality examples you provide can very directly translate to a better agent behavior. Second, we also learned that
you all outside of your agent. To talk to you.
I'm Kathy.
To the stage, members of technical staff at OpenAI, Will Heng and Kathy Zhou.
Google engineers, DeepMind researchers, we were able to give them an early access and now an official access to anti-gravity internally. And so now all of a sudden, the actual experience of the models that people are improving, the actual experience of using the agent manager and touching artifacts is letting them see at a very, very real level, what are the gaps in the model? And whether it be computer use, whether it be image generation, whether it be instruction following, right? Every single one of these teams, and there are many teams at Google, has some hand inside of this very, very full stack product. And so you might notice as an infrastructure engineer, you might say, oh, this is a bit slow. Well, build it for yourself, make it faster. Image gen, all of a sudden computer use isn't going well. It can't click this button. It's really bad at scrolling, really bad at finding text on the page. Well, go off and make that better, right? So it gives you this level of insight that evals just simply can't give you. And I think that's what's really cool about being a DeepMind. You are able to integrate product and research in a way that creates this flywheel and pushes that frontier. And I guarantee you that whatever that frontier provides, we will provide in anti-gravity for the rest of the world. These are the same product. And so I'll give you 2 examples of how this has worked. The first one was that computer use example, right? In collaboration with the computer use team, which we sit a couple tens of feet away from, we identified gaps on both sides, right? So we're not just using an API. We're interacting across teams to basically say, oh, like the capability is kind of off here. Can we go off and figure out what's going on here? Maybe there's a mismatch in data distribution. And then on the other side, it's like, yo, your agent harness is like pretty screwed up. You got to fix your tools, right? And so then we'll go off and we'll fix our side. But it's this harmony. It's both sides talking to each other that really makes this type of thing possible. Similarly, you come up with a new product paradigm, artifacts. Artifacts were not good on the initial versions, right? What part of training, what part of data distribution includes this like weird concept of reviews? And so it took a little bit of plumbing, a little bit of work with the research team to figure out, all right, let's steadily improve this ability. Let's give you a hill to climb. And then now we were able to launch Gemini 3 Pro with a very good ability to handle these sorts of artifacts. And so it's this cyclic nature that I'm really, really betting on. And this is really how anti-gravity will defy gravity. We've got pushing the ceiling. We're going to have an agent with very, very high level of ambition. We're going to try and do as much as we can. And this includes vibe coding, though I will say there are some excellent products out there by Google. AI Studio is an excellent product. We are in the business of increasing the ceiling. Second, we built this agent-first experience, artifacts, agent manager. And then finally, we have this research product flywheel. And this is the magic, and this is the 3-step process that we used in building anti-gravity. So it's been a blast. I mean, I've been back at AI Engineer Summit. Thank you again, Swix and Ben, for having me. It's been awesome to come back every year. And so on behalf of the anti-gravity team, I just want to thank you for your time, for your patience as you use the product, and your support. And of course, you too can adopt the TPU and help us turn off PagerDuty a bit more. And then of course, you can also yell at me on Twitter. That's another way of doing it. Maybe do it in DMs instead. But we've got a lot of exciting things. And I'm really, really excited to bring anti-gravity to market. The team is thrilled that this is now out in the wild. So we welcome your feedback. And thank you again for listening. Enjoy the rest of the conference.
Ladies and gentlemen, please welcome back to the stage, Jed Borovic.
Thank you, Kevin. Let's hear it for Kevin and all of our speakers today. All right, what a great way to end our sessions. How are we doing? I know it's been a big day. Yeah, we're still somewhat alive? Okay, before we wrap up, a few logistics. Thing one, there's an official after party tonight. If you've registered, there'll be a follow-up email in about 30 minutes. The second thing is tomorrow is a full day of workshops. Importantly, they're not here. There's 2 different buildings. There's the Datadog building that's right around the corner. There's also the AWS building, JFK 27 on 39th Street. But when in doubt, the schedule is on the website. My last act as MC is to invite the event's co-founders up to stage for a special closing word. Please join me in welcoming AI Engineer co-founders Benjamin Dunphy and Swix.
All right. Let's keep it going for Jed, everyone. Let's keep it going for Jed. And Alex yesterday, our lovely MCs who really glued this place together. So we really had such a great time. Did you all have a good time? So glad to see that. hopefully the program went smoothly. Me and the team here, the lovely team at the Time Center, Argus HD, Max Video Productions, everyone here supporting the production, that's us. And the content curation, let's give it up for this guy.
Oh, thank you. I hope you enjoyed it.
You have no idea how hard he works on this. And for me as a conference producer who used to do both the content curation and the production, it's just a godsend to partner with someone who is on the forefront of thought leadership like this. And you have no idea how hard he works. And he's actually recently so invested in this that he's actually recently stepped up as CEO. So just kind of announced that.
That wasn't what I was expecting, yes.
But yes, Sean is now the new CEO of the company, and I wouldn't have it any other way. If there's one person I want to follow, like in this world, it's this man. And there's one person I'm happy to be working for, it's this man. So.
Oh, yeah, likewise. The production quality and the creative design and all the music that you hear online is all Ben, so you got to give it up for him as well.
Thank you. I think we're on, let's go to the other notes. Let's go to this. So we wanted to talk just a little bit. I mean, you saw the slide earlier from Sean. It's basically just showing the growth that we had. When I started conference production, I always approached events from the point of view for myself and with clients that from your first event, you want to start small and worst case scenario, you sell it. You don't want to start big and you have an empty venue, you blow the budget, you go bankrupt. So we did that intentionally. We kept the first one very small when we announced it, with the rise of the AI engineer back in 2023. And we sold out that. And then we sold out every single event since then, and we're also growing online. So all of you watching on the live stream, thank you so much for being part of this community remotely. If you can make it to one of our events, we are growing. We have some announcements for you. In just a few moments, we'll be coming to you a little bit closer around the world. And for this event in particular, we had 2,463 applicants, and 815 of you came. So if we ask an LLM, it might tell us that's maybe 2% admission rate, I think, something like that. It's actually 33%. But that's just showing the exclusivity of this event in particular. Summit is designed to be a little more exclusive because we want this to be our Solve conference. If you know the Solve conference, some of you might, that's essentially where Albert Einstein, Marie Curie, all of the physicists from around the world came in advanced physics over the course of a couple weeks, I think. Basically decades, right? And basically to the point where we are today, because string theory, where's that taking us? Come on. Hopefully we can solve that with the rise of AI. In any case, that's what we have for Summit. And where are we at? I put this together in the last 30 minutes, so pardon me. So there's clearly demand for this community. There's clearly growth here. There's a lot of excitement here. There's a lot of great content, and there's a lot of questions to be answered. There are no clear answers here. This is potentially, as people argue, a new consciousness, right? The new form of consciousness, right? We're all discovering this together. So as we push forward into the dark, into the future, in this wonderful, beautiful moment in this temporal existence, we will figure it out together. And that's why we're excited to announce, roll tape. World's Fair is coming back to San Francisco 2026 on June 29th, typo, to July 2nd. So we're going to do 4 days. So we're going to do 1 workshop day and 3 days of sessions. So tickets are on sale now. These are going to be the cheapest they will be. Did we decide on a discount code or just the price is cheap?
No, it's super early bird is the discount.
It's a super early bird. Yeah. Okay. Well, there's 2 choices, right? The ticket is this price, and we're going to change the price later, or here's the discount code. So that's always a question. We're running the event. This is, side stuff. This is future events. So these, so we're really happy and very excited to announce that. This year we are at Moscone West. That is the baby brother of the Moscone Center, so we're not quite there yet. But we sold out the Marriott Marquis, which is the largest event hotel in San Francisco, at about 3,200 just a few months ago. And so the only place to go from there is to Moscone West, which is about 6,500 capacity. So we're estimating, conservative 5,000, but we hope to get to the max capacity of 6,500. So buy your tickets now. They're not going to get any cheaper. Where are we? Oh, the video ended. It's supposed to be quicker than this. Let's go to the next one. We got one more announcement. You want to say something about World's Fair?
Yeah, World's Fair is our attempt is our flagship. We are basically trying to capture all of AI in one event, and for you to basically have kind of an all-you-can-eat pass to go to multiple conferences at once. This year we had 10 simultaneous tracks. That was a lot. So we will never expand beyond that. But I think we want to really make it count and have you basically just dip into whether it's generative media or voice or robotics or anything else that you want to explore. We are also bringing it to Europe for the first time, so that's the next announcement.
Yes, so this next April 8th to 10th. Whether you're from Europe or you want to make the trip to beautiful London, we are right in Westminster at the beautiful Queen Elizabeth II. We can fit about 800 people in there, so buy your ticket soon. We expect that one to sell out as well. It's going to be basically Baby World's Fair. We want to establish World's Fair essentially in Europe. There's no better place than London. We love Paris, and we love what the Koyev team did with AI Engineer Paris, but we feel London is the right call for this event. The venues there are beautiful. The city's beautiful. I'm biased. I really love Paris, but London ain't bad too. I lived there for a little bit, so I do enjoy it.
I really care about direct flight from SF to London. So.
That's it. That's it. Very nice.
Yeah.
Okay, so tickets are also on sale here. Again, super early bird pricing, the cheapest they're going to get. So AI.engineer/Europe. I don't know when those are going to expire, but I'm sure we'll communicate that to you guys later. And then I think this is a video, so let's go to the next one. Okay, so with all of this growth, little old John and me, we can't do this ourselves. So we needed to bring someone on to really help grow the company. We needed to get procedures. A lot of organizing conferences it's a lot of grunt work, right? It's a lot of human connection. It's a lot of reminders. It's a lot of sales, but it's also running the business and then just coming up with processes. So a lot of times, you're kind of figuring it out as you're going, and you get these processes, but then things change. And then some things are not perfect. So you're always behind, and deadlines are always coming. And these budgets are insane. You have no idea. And you don't want to see a budget for one of these events. And there's just a lot of complexity to that. So when we first started the event, back in 2023, we brought on Leah McBride, who used to be the director of events at Twitter, and she helped us out within 2 months. Basically, she was helping us to run Engineer Summit to the point where it was a lot smoother than when I was just running events on my own. With you get the Hollywood crew that comes as professionals to help you run the actual event, but the whole production is a lot of difficulty. So we're very, very pleased to announce that Leah McBride is joining us as our new general manager to help us grow into a proper corporation. So please join me in welcoming to the stage Leah McBride, everyone.
Yeah.
Thank you, Ben and Swix. Hi, everyone. As Ben has just told you, I'm very excited to join the company as general manager. I've been working in event marketing, tech event marketing for almost 20 years. I was lucky enough to join one of the biggest London agencies. I am Scottish, so I'm from the UK, quite a few years ago. And Google was my main client for quite a long time. So I kind of grew up through that Google excellence and how we operationally produce excellent events. I was then lucky enough to go on and be the director of events for the developer platform at Twitter for a number of years, where I led multiple global tours.
Just a go.
I led multiple global tours, and I also led our flagpole event in San Francisco, which was Flight, if anyone ever went to that. And following that, that was in San Francisco, then I moved back to London, and I started a company called Improbable, which is a gaming platform. So I worked mainly with gaming developers there and grew the marketing team from 3 up to 38. And following that, I was lucky enough to meet Ben and Swix. So yes, I've been with them since the first event, and we have just got a super exciting year coming up. So to add to our program of Europe and Moscone, San Francisco, if anyone was there, I don't know, was anyone in Paris with us? Yeah. Excellent.
Show of hands. We got like 5, 6 people.
So you'll be able to contest that the Paris event was absolutely phenomenal. So our partners, CoWeb, came to us and asked if we were going to do Paris. We weren't really ready for that, and they suggested that we partner with them. This was a great idea. They did an absolutely incredible job of producing the Paris event. It was a sold-out sponsorship, sold-out event. We had so much incredible feedback that we have actually decided to turn that into a program. So we are launching in 2026 our partner program. We have already signed up, so we are hoping, again, to be doing Paris, October 2026. We have also recently signed up with a Miami team. So we're going to be doing an AI Engineer Miami, April 20 to 21st. And then also, we're very excited to be going to Melbourne also with a partner. So we'll be doing Melbourne, June 3rd to 4th, 2026. This program is obviously just starting, so there's going to be more opportunity as we grow to be part of this program. So if there is anyone in this room who wants to know more about that, please just email us at sponsorships@ai.engineer, and we can talk about what that looks like for your city. So thank you. I'm very excited for 26.
Thank you so much, Leah. All right, so that's basically all the announcements we had. We hope to see you at one of those events, whether you come to San Francisco or London. We'll probably be back for New York. So should we come back to New York? Yeah. All right. By the show of woos, how do you say that? By woos, how many of you are from New York?
Wow. Yeah.
San Francisco? Ooh. That was close. Let's do it again. New York. San Francisco. Oh, man. I
Scotland?
Think like 70,
San Francisco changed pitch.
All right.
San Francisco went higher this time. I don't know.
I met Cape Town the other day. So is Cape Town here? Cape Town has left the building. Yeah. We had New Zealand, right? So people coming all over the world for these events. So obviously New York is one of the great cities of the world. And of course, those 70% of you will say the greatest. We love coming here. We love giving people an excuse to come here. So we hope to be back soon. And we love this venue. Despite being in Times Square, we put up with it because the crew here is just so fantastic. Obviously, look how gorgeous this place is. So we hope to potentially be back here next year. And then the rest of our crew that we cannot do this without. Everyone from Argus HD, who's running all of the AV. Can we give a round of applause for them? And they put up with us because we're getting them assets super, super late. So namaste. I think that's what I'm supposed to say. And I always forget people at this moment. Who else am I forgetting? Florimon Catering. Our caterers are super fantastic. Photographer, Randall Gee, Max Video Productions. Doing our B-roll. We're going to have some of those end-of-day clips.
Marina, Kyle.
Yes, of course. Our rest of our team members. Oh my God. Why did I add those as our slides? We got those in the end credits. I at least thought enough to. I was doing this like 30 minutes away. Anyways, yeah, Marina, our senior event producer. Wendy recently just joined. Kyle, our program production manager, just joined 2 weeks ago, and it's been just hit the ground running. Trish, our production assistant, supervisor, and just so many of our partners in programs. So we want to thank all of them. But that's about it for that. Apologies if I forgot you. But we now have until 6:30 in the venue. So we have a little bit of time to kind of chill, make your final evening plans. We do have an official evening after party brought to you by Cerebras, along with some friends, BCV, McKinsey, Warp, EXA, Modal, am I pronouncing that right? And Metronome. So that is the official offsite after party. We're not giving you the location right now because we're on the live stream right now, but we leave it on the signs outside, and we'll also send an email in just a few moments. And it's also on your attendee guide. So do go ahead and check that out. They are asking for RSVP for headcount, but you don't need it. You can just show it with a badge and you can get it. But don't forget your badge. So let's give it up for Cerebras.
Thank you, Cerebras.
Also, last people to thank is our sponsors and speakers. Our speakers, they work so hard for this, and due to Sean's no vendor talks policy, which is it's a great boon for the for the community, but they have very little incentive to do that other than thought leadership. So that is a lot of work, and they do a great job with that. And then our sponsors. Did we enjoy the sponsor expo?
Yeah. It's really well done by Art and Display too.
Should we try for the photo?
Sorry?
Should we try for the photo?
Sure. Yeah.
Let's do it.
Okay, cool. Yeah.
So we did this last year, and it was really great. This is our Solvay conference photo. If you want to come up here and do a photo, we can do that together. Randall Gear, our lucky photographer, is going to take a photo. He will direct us. We can actually get him the mic, and then he can yell at us to go left and right. So come on stage. Just one caveat. These things here, they look like you can step on them. You can't. They will break, and we'll get charged a lot of money. So just be careful of those. But otherwise, come on down if you want to.
Yeah, we did this. We've done this every conference.
Totally fine.
It's a little memorabilia.
But please come on, and please keep my mic on for a little bit.
Hi, thanks for coming.
Yeah.
Hope you enjoyed it.
I'm going to everyone now.
Hey.
Thank you so much.
Yeah.
Listen, I'm in Minneapolis, so we just started like a meetup there. And that's awesome.
Yeah, we do AIE meetups too.
My pleasure. Yeah.
I'm like on a hot mic.
Code Summit, World's Fair. Yeah. So the AI Engineer Series events. Yeah.
Okay, don't be shy. Take up some steps to the front of the stage, and we'll have different rows. And if you're on the left side of the podium, I won't get you, so get on this side of the podium. And don't squat yet, but we'll do kind of like a little squat in the front, but not yet, okay? And if you can, don't be shy. Squish in. There's a lot of space in the middle, so don't be shy. Squish in towards the middle. This is the middle. Thank you very much. Oh, we'll just go super wide. Okay, this will work. Okay, cool. Oh, wait, where's this? Where's he? Want to go get burritos? Actually, since we have some time, can we get like half of this group to come to this side? It's like way left heavy. Can you just go make the make jacket this way? Some other teams are busy running around outside. Okay, so now we're gonna have the front squat just a little bit. If you're in the middle, squat medium, and then if you're in the back row, tippy toe a little bit. Yeah. Okay, on three. Here we go. On three. Looking at me. 1, 2, 3. 1, 2, 3. Wait for it. Wait. Make sure it's good. Okay, now give me some yay! Perfect. Thank you.
Hi, Mike. It's Thanksgiving weekend in the US. I'm not sure if people will be joining today.
I'm here.
Oh, okay.
By the way, the last call, I tried to download and install the voice to text app we were talking about, like Whisper Talk or Whisper Talker or something like that, and my computer got isolated by our security systems at work, and so it took. I was off the internet like the whole day. I couldn't get anyone to restore me. So, I what's that? Yes, it didn't like me downloading the app, so it isolated me as a risk, and took me a while to figure out what happened. So that's part of why I dropped out. I mean, our automated security systems, whatever we have Zscaler. I think it must have been related to Zscaler. It just noticed that I had downloaded an app that it considered didn't know what it was, so it just assumed it was malicious. And then it isolated me from internet access. So I had to get in touch with our support folks. So, but we have many layers of support. So like the layers I was dealing with didn't know their heads from their ass. So they didn't understand that that's what happened. So it took a long time to resolve it. But anyway, no more downloading new apps near holidays. Yep. Yeah, I don't have a separate laptop. Yeah. I don't know. It's a good question. I don't think, I mean, we're a European-based company, really. Informa bought our company, so I don't know if they're allowed to do that. You know, they have a lot of privacy laws, so I don't know. I really don't. Boy, there's a lot of MCP stuff happening the last couple of weeks. Yeah. Uh, oh, Yuri, you didn't go to any of the AI engineer stuff in New York, did you?
No, I think a year ago I signed up, but then it was like you had to be like approved, like to prove you're worthy to attend.
Right.
And then after that you can pay. It was like a few $100s, but like I didn't want to do it at the time. And now I'm like at work, we use AI, but I'm doing different stuff. Like so, I don't know. I didn't. I wouldn't be able to justify like going.
What are you focusing on most now in your actual
So
work?
we're building software. We're like kind of building this climate risk analytics function. So we use AI like a little bit, but not it's not an AI system. And I'm not build like a part we're building with AI are very like software centric. Like you know, searching documents for like contractual clauses, and then generating like basically going through databases with natural language. So those are kind of a standard software things now. I only use AI really. I think I kind of described it before. I only use it to do deep research because we're like, and we're learning. Like we thought like, oh, well, maybe we don't know, but apparently like not a lot of information is published on climate hazards. So we're trying to like find everything that's published with a deep research.
What's specific about the climate model you guys are building? I mean, aren't there already models out there?
So there are a lot of companies that deal with climate predictions. We like, so basically what's gonna how risk is gonna change you know 20, 30, 50 years from now. We are building that part, but that's not the main thing. Like mainly we are looking for like a 1 to 3 years predictions, because that's a lot more practical. You can actually do meaningful predictions, so you have some skill. You can actually like predict how like a probability of your hazards and distribution of your hazards is going to change. So you can actually sell insurance based on that.
You guys have customers?
And there are companies that do it. The
Yeah.
companies that are doing it for real estate now, but we're doing it specifically for energy assets.
For energy assets?
Energy infrastructure, like solar, wind, transmission.
What would a climate prediction have to do with them? Why would they want that info?
Oh no, because they're very dependent on climate, right? So, like a renewable generation. First of all, it's very like it's affected by hazards, but it's also a generation is affected by climate, by weather.
Right. Like the amount of energy in the atmosphere can be calculated, and that's how much you're going to get out of your wind farms and stuff like that, right? So you'll get more wind probably with global warming, more energy in the system.
Well, that's the thing. Like, so we're looking at the climate change scenarios, and clients keep asking about it because the same people like we want to actually like sell like shorter term predictions, but the same people who want to use it, they need to say how distribution of hazards is going to change like longer term, because when people are buying assets, they want to hold them for like 20, 30 years.
Right. So I'm thinking wrong. I'm thinking wrongly. What I should be thinking is the core of what you guys are is next year. You know, can I tell my shareholders next year, give them a good prediction, that sort of thing? Can I?
Yeah, no, but it's So not even prediction. We're calculating risks on top of that. So show where your risks are increasing, like compare different assets, and is your risk coming from specific hazards? Is it coming from generation? And then you can actually like mitigate risk within that. So you can sell insurance that will lower and show how that insurance will lower your risk.
But it's all for the power generation industry, and for the insurance companies itself, insurance to them. For them to get insurance.
Yeah, insurance companies, they could be doing that, but they don't. Like, so usually it's people who own assets or want to buy insurance. They actually like.
So is it mostly wind related because that's the most
Wind,
affected?
solar,
How's solar?
transmission.
How's solar affected by climate? Is cloud
Hail.
cover?
Well, cloud cover for generation, like atmospheric rivers, and then hail.
Oh yeah.
Hail and then
of course.
And then like general like a flood. Flood is dangerous in some places. Yeah, but we'll look at like all of them.
So how many core scientists like yourself doing the statistics, the models? How many people are actually building those models? Is it just you, or you have a couple people with you?
No, we have a few people. We now work with people part-time, a lot from people from industry and like academia.
So are you friends with the founders or something, or are you a founder?
I don't know how to call this, but yeah. So one guy like yeah, I'm on the founders team. Like one guy kind of wanted to like he saw the interest, he created the company, and then he invited people in like data science, climate,
Is this a connection from
geospatial.
Is that a connection?
Yeah, like indirectly.
Yeah.
So it's a very similar. So before I was doing climate and agriculture, now it's climate and energy. So just because I had experience with that. Yeah.
And do you guys have customers yet?
Yeah.
And when you actually are doing your work, what data is mostly what you specifically are dealing with? Is it like satellite data?
So right now we don't go directly to satellites. Usually and that was that's a big difference between when we in the previous company they wanted to be data companies, so they would like pull satellite data, they would calculate things on top of that, they would maintain, improve data. We're trying not to do that. So everything we can outsource to other companies, like, and things change. Like basically, there are already a lot of companies building stuff on top of like data and on top of satellite data. So weather data became pretty standard. Even hazards, like we try not to like we're building some of our own data sets, but for like generic for like a generic hazards, we try to use NOAA and FEMA. And even with NOAA and FEMA, we try not to like use it directly. We're relying on another company, like similar to the company we used before, that already like pulls the data, makes it easy to ingest, verifies that it's correct. So.
Okay, so you aggregate, you use all the people's data, and mostly
we're trying to like use aggregators. So we're trying to just pull the data that we need.
So what's your deliverable go to a customer? Like literally,
it's a risk, basically risk, specific risk for specific asset for like next year.
So you've got an individual customer in the energy sector.
Yeah, they usually own a lot of assets.
Yep.
So we
your risk is custom to not only them but to the assets they want you to.
To the asset to like a super local location and configuration of the asset. Right? Like,
so basically use all the climate data, all your statistics, all your modeling for their specific assets, for the specific company. You deliver a report that outlines the risks, and then they use, is that right?
Yeah. And then we start with generic information, right? Like, so generic asset, maybe like more lower resolution data, and then we get more and more precise.
Right, you build up.
Yeah.
Interesting. Okay, and then they use that to help them mitigate risk on their end. And
yeah, well, no, we also provide like services to mitigate risk, right? So they can actually.
What do you mean? You like sell
So
insurance?
no. So like you can buy insurance, and we show you how this specific insurance will mitigate your risk.
Oh, so as part of the report is recommending or outlining not just the risks but the mitigations. And do you then? Yeah.
So we haven't put it into report, like, because it's on the website. So you can actually try, like, basically try to structure your insurance, like try to look at your risk and try to like see what you want to mitigate. But we don't do recommendations so far. So that's
you don't make money off the mitigations? You don't like the third party?
Oh no, that's an idea. Like we haven't sold insurance yet.
What's the name of your company? I haven't even never looked at the website.
Infrasure. I'll post it.
I see. INFRASURE.
Infrasure.ai.
Yeah, I see them. They came right up. Awesome. Good name. Very good name. I'm having a hard time loading it though. What's going on, dude? Here it comes. Let's load slow. That sounds like a good place to be, Yuri. It doesn't sound bad at all. It's a really good niche.
We'll see.
Well, except for in the US, but there's so much in place already, right? It's already a big industry, even though Trump's trying to kill everything he can.
That's the thing. Like we work with, well, first of all, people still building because there's a deadline and people are still trying to build a lot. But also we work a lot with existing assets because they have to buy insurance every year. So that's why, like, the idea is that it's going to be repeated business. So like it's every year they need to buy insurance. So they would need to like optimize it every year.
Yep. I'm just looking at your site now. Yeah. Very nice. Oh, well, thanks for sharing all that, Yuri. It's interesting.
Sure. So I want to kind of go through AI engineer, but like topics that interest me are like changed. So I saw like there was one topic called like what should you replace agile in age of AI. I don't know if anybody saw that video, but I specifically want to do that because we're doing agile and it's I don't know.
Have you heard of like slices?
No.
There's some sort of technique that people use, but it's interesting because, well, I mean, if you're building with AI, it's one thing. If you're not, I guess it's a little different. But when you're building with AI, it's becoming very small, very fast teams that do a lot. And it's usually like 3 people teams, maybe 4. And of course, when you stand it up fully in production, you bring in DevOps and stuff. But it just becomes releasing new stuff almost every day. But that's because there's just so much infrastructure for AI, and then you're using, for AI stuff, it's all in the cloud. It's easy to do MCPs, it's easy to do chat, it's easy to do all this stuff now. So, but what do you think? What is that noise? Anyone, you hear that? Did you hear that noise, Yuri?
Yeah,
like a video game.
Mechanical noise. Yeah,
it's pretty weird. So what were you thinking about? Are you still talking about bringing in new people, and you're thinking about how to structure your dev processes? Is that why you were interested in the Scrum?
Yeah. So we have like we don't have professional. We don't have professional we have like one professional or 2 professional developers. One professional developer, but she's doing everything else. She's like product management, just spatial UI design.
Yeah.
So a lot of people who are working with are graduates from data science or PhDs, so they can write code, but they're not like professional code writers. So I'm interested in how to first of all structure work, but also kind of make them use AI tools correctly, coding tools correctly, because right now it's sort of everyone is a little bit on their own. Like we have a setup, but they don't have to follow it. So they can.
Oh, well,
Also,
how do you think about that then? Structuring the use of AI coding tools?
we have access to Google's program for startups. So we have Gemini. We had Claude. We don't have Claude right now, but we need to decide whether we want to buy it again. But yeah, so a couple of things. So first, tools that they want to use, but also I see that a lot of code is generated because I'm reviewing a lot of it. I'd like to be able to maybe start recording the what's the thing called, the MD files, the not requirements, but the instructions to LLMs, because otherwise it's really difficult to understand why code was written a certain way. So and right now it's not, we have requirements, but in very few places. But I want to figure out how to describe the process correctly, because now requirements are super important because basically people generate code from them.
Yeah, so you want to do some context engineering for your engineering team, where you
Yeah.
have standard markdown files, right, for context.
And right now it's sort of free for all. So somebody's using it, somebody's still using ChatGPT and develops code there and just copies it. Yeah.
And do you have scrums with everyone, the whole dev team?
Yeah, but it's not official. It is sort of agile, but
so you don't have a dev manager?
I'm doing it for half the team, and then somebody else is doing it for another half. So we separated between models and sort of production code.
Right.
I'm doing it on the modeling side.
Right. I mean, how many people do you have on the modeling side anyway? But
5
or 5. Well, that's enough to make it complicated. So you run your you have, so you're managing that team of 5. You're an engineer.
Sorry, there's a noise now coming through. Can you say it again?
So you're managing an engineering team.
Yeah, but I'm working at the same time. So
yeah, I keep hearing that. Yeah. Yeah, I know. Okay.
okay. Mayank, your summary, can we pick what to listen out of it? Should I read it for that? Mm-hmm. 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 Cool. Yeah, I'll check it out.
What are you talking about with what were you outlining? Yeah, that's the one you already created the summaries for that Yuri was asking
No,
about?
this is AI engineer, the one
Oh,
you were
okay.
asking about.
So
Yeah,
you're
mine
talking
has
about
like a summary.
in LinkedIn?
No, I think in our
Oh, I see. On Slack.
no, Slack. Yeah.
Okay. Duh. Oh, okay. All right.
All right, let's get back to shopping.
Yeah, shopping. All right. Talk to you guys soon. Thanks, everyone.
Bye.
Bye.
as well as the corresponding code labs is your operational playbook for bridging this massive last mile gap where 80% of the real work often lies. So the white paper, it starts with people and process, defining the specialized roles needed for mature agent ops, from AI engineers designing guardrails to platform teams managing authentication and authorization. A core theme in this white paper, in this section, is the evaluation-gated CI/CD pipeline, and I recommend diving deeper into that section. It's very interesting, in my opinion. It's simple but powerful. No agent version should ever reach production without automatically passing a rigorous evaluation suite that proves its quality and safety. We covered safe rollout strategies like canary deployments, starting with, say, 1% of users, and blue-green deployments to minimize blast radius and allow instant rollbacks if something goes awry. Once live, you need a continuous observe, act, evolve loop using real-time monitoring to trigger immediate fixes, like, say, or circuit breaker works, but instead in this context for a failing tool, and then feeding insights back into the development for long-term improvements. The paper concludes by looking at scaling beyond single agents using the agent-to-agent, or A2A as we call it, protocol to build collaborative ecosystems where agents can discover specialized peers and delicate complex goals. So that would be it for the summary of the white paper. For those of you who haven't had the opportunity to read it completely, I would recommend starting off with the summary Notebook LM generated podcast. And then if you feel like it, load that paper up in Notebook LM and ask it questions, use the mind map to navigate it, as well as get your own video and audio overviews to interactively interact and read the white paper. All right, Kanch, then give it over to you to the exciting Q&A session.
Thank you, Anand. And one of the things about this paper is also it's very short. So it's easy for you to be able to grasp as well. So looking forward to having you place reviews. So now on to the meat of the section with the Q&A. Can we have Vilgranis, Socrates Katakis, Elias Eshi, and Saurabh Tiwari on stage, please? Thank you, everyone. Thank you for joining, despite your busy schedules in answering questions with the community. Community definitely enjoys it. We see that in the live chat. We see the interactions going on, and they appreciate you being here. So thank you so much for being here for us. Would you like to do a quick introduction? Why don't we start with Elia? You are on my screen first.
Thanks, Kanch. Nice to meet you all who are watching this. I'm Elia. I'm a ML specialist in cloud AI, looking at helping developers, customers, bringing agents to production.
And one of the white paper authors.
And one of the white paper authors, yeah.
And do try out his agent starter pack, which is very useful as well.
I'm sure you would do the branding. So thank you. Well, you're on my screen next.
All right, well, honored to be in your screen. Hi, I'm Will, and I'm the CTO here at Google Cloud, and super excited to be a part of day 5 of this Agent Intensive, and a big shout out to everybody who put this program together. Amazing stuff. Honored to be here.
Thank you so much, Will. Appreciate it. Saurabh?
Yeah, hi, everyone. Super excited to be here. And thank you to all our viewers who are watching it. It's an amazing journey that we are working together with you. I lead a cloud AI organization, which includes Vertex, Colab, Kaggle, and a few other businesses. By the way, one quick shout out that I'm also a follower of this course because my kids are trying to follow along. So I'm following up as well.
We love it. So we would have candid feedback.
Yes.
They're getting expert advice. That's no fair.
Yes. We have an insider track.
Right.
Awesome.
Socrates?
Hello, everyone. I'm a Gen AI black belt for Google Cloud. I help enterprise customers to bring some hundreds of agents into production. And this is my love, Agent Ops, ML Ops, and the whole area of Ops. And happy to help you today.
And one of the authors of the white paper.
And also the previous two.
Thank you. Thank you, everyone, for being here. And definitely in the live stream, we see it. And on demand after too. There are close to like 200K folks in Discord who are continuously asking questions. So we are excited to see what we do here today. Anand, why don't you take this first?
Thanks, Kanch. Excited to ask Saurabh this question for you. So going forward, what do you think is more important for models, deeper reasoning capabilities or the extreme token efficiency and speed required to make real-time multi-agent meshes commercially viable?
No, I think this is an excellent question. I think at a high level, I would say it depends, depending upon the application. If you look at from a reasoning perspective, from a core model reasoning perspective, the reasoning needs to be very strong for the models to make choices during the agentic application as to what tools to use, how to act when they are seeing responses which have uncertain outcomes, how to decide which path to navigate, etc. So core reasoning is important. In many applications, if we don't have fast enough latency, it may not be viable, or like practically viable, because you may not want to, as a user, wait for a very, very long time, which is there. So I would say it is a trade-off as we go along. Let me provide some color from where the research is heading. What is happening is that as foundation models are improving, a lot of the reasoning is becoming a lot thinner because much of the logic is being processed by the model itself internally within its own systems. So what you should see as we go forward is that the number of reasoning tokens which are getting produced will become smaller for the same type of task. Now, what that provides us is that we can now then use the model for much more complicated tasks. So you can have, instead of creating a mesh of like 3 agents working together, you can now have 5, 15, 50. Our ambitions over here are pretty high. We do see a world where
agents will be able to work across like multiple very complicated structures as we go along. One other thing from a practitioner's perspective I would call out is that when we are building agents, it is good to simplify the task of a particular agent so that it becomes, so the reasoning becomes a lot more easier. So if you can break down the task into multiple sub-agents, which can all orchestrate amongst each other instead of one giant prompt and one single super agent which tries to do everything, that will help both with latency as well as with quality.
Amazing insight. Thanks, Gaurav. And I find it fascinating that just some time ago, reasoning wasn't there in the models at all. And now we had reasoning, long traces, and now we're going back full circle to minimizing reasoning. So life goes full circle, and so do agents, it seems.
And the agent sub-agents is interesting because in the day one of the question was, what if I had agent with 50 tools? That was the question which was out there.
Yeah, actually, if you look at in commercial systems, what we are observing is many of the developers who are building their agents, they start with one or two as a toy example. But very soon as these agents start performing the job that they are expecting, the expectations rise, and then people start throwing more and more tools at it. And it becomes basically a reasoning challenge as if you go into like 50 or 100 tools. And that's where like having some level of like hierarchy or some subdivision will be helpful.
And if I may, we need to treat the sub-agents and multi-agent systems as microservices, right? The same reason that we build microservices is this, to reduce the problem into the minimum effort, let's say.
Yeah, but I believe the statelessness part might not be necessarily true for agents. You might need to share the state. But other than that, yes, definitely, with modular design. Amazing. Thank you. Thanks for the interesting conversation, everyone. All right, shall we move on to the next question, Kanch? So this one is for you, Bill. What is the biggest gap you currently see in the industry's tooling for productionizing agents at scale? Additionally, in your opinion, how should it be addressed?
Sure. So one of the principles that's actually covered in this week's Agent Intensive is using evals as a quality gate before you move agents into production. And I think it's fair to state that the state of our tooling today is that humans are the deployment gate for agents. So where I see things heading is a world where we have so many agents being built, as that confidence builds, as Sarah was talking about inside of organizations and across development teams everywhere, more and more agents need to get into production. They're going to be acting in parallel. You're even going to have agents writing code on the fly to include other agents. It's going to be super difficult for human-centered and human-gated evals to keep up. So the tooling I see emerging from this really centers on this kind of continuous agentic evaluation. How's it going to take shape? Well, let's see. I think you have to think about this in terms of the organization itself. So in any reasonably sized organization, about 80% of the use cases or applications for agents are going to be kind of moderate to low risk. Going to be internal processes, going to be things that aren't necessarily in full view of users. So, I see a world where agentic evaluations can leverage the observability and trust primitives that, Sarah and the team have built into our cloud and AI platforms today. You can have those, and then you have the simulation and offline agent improvement, mechanism, and the net of all that is the development of AI evaluators. And AI evaluators are going to move these lower risk agents into production more quickly and autonomously. It's going to give everyone a lot more confidence, and it's going to speed up the big task queue and agent queue that's headed for evals. But the best part is that the most complicated and risky deployments, which are going to be the focus, kind of for the CTOs, the CIOs, the CISOs, the leadership of these organizations, they get to be evaluated by engineers because they have the time to really dig in and look at these more complex or maybe potentially more risky agents. And so the primitives for this architecture that I referred to, they're already put in place in Google's cloud and agent platforms, things like Cloud Trace and Sessions. This is going to allow all of you to pre-train these eval agents, and you can use either real or simulated agentic behaviors. And then you combine all of this with the manual and automated feedback loops, and you're really going to be able to build these AI evaluators that are much more and more capable over time. And that's going to enable the scale of adoption and the climbing of the value curve inside of these organizations. And it's going to also partition the tasks that we give to agents, so that partition the agents themselves along risk and use case specific boundaries, which is really an implementation concern for every leader in every organization right now deploying agents.
Yeah, and one other thing I would add, completely agree with Will on the points that you made, is that particularly within teams, groups of either small teams or larger teams or organizations, what is happening is as different people are building agents, there is also this level of kind of like the Play Store analogy of which agent should I go trust, because that is made of high enough quality that I can use as either as a building block or as a standalone agent for my task. So this agent management, review process, some level of quality gates, etc., that is becoming more and more common. Another thing that we are seeing is that there's this notion of an agent marketplace where people can publish agents, and then either you can modify them or you can use them as is. But again, the level of trust, etc., starts coming into picture. And we do have some efforts relating to agent marketplace within Vertex as well.
Yeah, and these reputation mechanisms, because that's really the currency of trust, over time in these organizations is, both the people that are developing them, but also, just this history of agent development. And it goes beyond, I think a lot of the metrics today are around quality and, kind of performance or efficiency. But there's also going to be these new metrics that emerge around, consistency and around actually staying in alignment with policies, especially over long task duration. And as Sarah was mentioning earlier, as you have these multi-agent systems, it's much more complex.
Yeah, one other thing which is about security. As you start putting, Will was mentioning, right? As you start putting things into production, security becomes a big challenge because you can have fairly sophisticated attacks which could be structured around agents. An agent can do all the tasks that it is expected to do, but then it can do some additional things which it is not expected to do. So there is also, like, when an agent is deployed, right? How do you monitor it, right? And how do you give it accreditation? What kind of identity you should use so that we can retrace the steps back? There is also some requests for, should we have an undo step as part of the agent, so that we can retrace some of the type of, like, the previous state management kind of a thing. Like, for example, in your collab notebook, I know there is a reset all kind of an option that is there in the notebook instructions, the factory reset button, something along those lines. Like, these are all things that seem to be important as our agents become proliferated into the industry as well as in other places.
And in terms of security, a very important also topic is how you can implement the authentication authorization hopping. What I mean by that, you have an agent, you authorize this agent to use your credentials to do whatever you want, and then this agent needs to call another agent. This agent needs to call another agent. How do you pass this to all these agents?
Yes.
Definitely. Wow, I think that answer summarized pretty like a lot of the topics for all of our 5 days. Authorizations to agent evals, to the reminds me of the movie Inception, agent evaluating other agents, which then in turn need to be evaluated, and all the great security as well. Amazing. Thank you, everyone. That was very insightful. Awesome. Kanch, shall we move on to the next question? So this is for both of you, Saurabh and Will. So as enterprises struggle with decades of legacy IT, do you see agentic interfaces via protocols such as A2A becoming the de facto standard for modernizing these legacy systems? Or is that, in your opinion, just adding more technical depth that somebody needs to manage?
Well, I mean, for me, the short answer is yes and yes. Yes, agentic interfaces and architectures are going to become standard for modernization. And yes, there will also be some tech debt that comes with it, but it isn't necessarily a terrible thing. We'll talk more about that in a bit. But just think about the sheer velocity and scale that agentic workflows are enabling. It's going to completely transform how organizations think about delivering internal services and their external customer experiences. And it's already happening. I work with a health system right now that's using agents built on Agent Development Kit. And this is cascaded out to over 30,000 workers, and it gives all of them immediate access to all the policies in their organization without them having to do a bunch of searches over a bunch of internal sites or deal with slow keyword matching chatbots. So even in highly regulated industries, organizations are already taking this existing architecture that they have in their business processes, they're kind of breaking them apart, and they're recomposing them into these agent-based workflows. And as the ROI continues to increase, it's just going to encourage more and more of this, and more of the existing applications, data stores, and systems to be available to agentic workflows. And ironically, the tech debt that's being built is going to be increasingly burned down in parallel by agents that can execute tasks like code reviews, bug fixing, and the like. So we have a way out of the tech debt possibly for the first time as these agentic systems improve. And I do want to mention one other protocol, which I'm really excited about right now, and this is the agent payments protocol. If you think about the modern web, the foundations are basically a set of standards and protocols that enable high-speed, reliable communication. But it wasn't until the web became the vehicle for commerce and supported value exchange and payments that it really flourished. And it is the vehicle for digital transformation today of every industry. I think you're going to see the same arc with agents. You can imagine how enabling an agent to retrieve items from shops for you based on parameters you provide can make shopping, it's better for you and it's better for the merchant. It's way more efficient, and it's going to make your everyday life it's like a superpower operating in parallel to get things done. And I also think it's going to be true that business-to-business transactions are going to be completely reshaped by agents communicating, negotiating, transacting, verifying, even representing suppliers and ecosystems. So the value is going to be really compelling, and now the programming model, thanks to Saurabh and the team, is natural language. It's going to bring more people into the innovation process, and you're going to end up on this kind of multi-party, multi-agent commerce engine at web scale. And that's going to build upon this agent-to-agent. Step one, you got to be able to build the agents, ADK. Step two, you need to enable multi-agent, interaction policies. But the long game is enabling value transaction to happen, across multiple agents, whether it's within a firm or multiple firms coordinating. And I think that's where you're going to see, this breakthrough, this transformation.
Yeah, no, completely agree with Will on his yes and yes to the question. If you think about enterprise IT systems, one of the challenges that and why the systems are where they are and some of the challenges is because the level of investment is not that heavy, because very small teams have to manage a variety of different applications, and they can only do so much in any of these areas, right? And that's why some of the tech debt, etc., starts getting accumulated. One, I would say if you look on the positive side, because of the coding capabilities that the models have and some of these agentic systems have, we actually, what I'm expecting is much more better IT systems, like from the ground up itself, that may come up because you are basically now having extremely sophisticated software engineers building code independent of whatever is the application, and you are not making a choice based on the return on investment or how. And that's the big promise of AI, right? That it kind of democratizes quality code across the board, right? That's just one aspect of it. The other thing which these agents are offering is that within the computer use paradigm, even if you have traditional enterprise systems, which with their UI being a lot more clunkier, etc., right, and hard to use, and only the subject matter experts know which button to click after which one in what order, etc., and so on. With computer use, the agents can actually create reasonable encapsulations on top of these, so that the ramp-up time for using some of these traditional enterprise applications would be a lot easier. And I'm talking about, obviously, there are the SaaS providers, but also there are when I'm talking about enterprise applications, the applications provided by SaaS providers, but also in-house built kind of like applications, right? So you could have interfaces on top of pre-existing applications, which can make them easier to use and interact and with higher enough quality, so that the brittleness between, particularly when you are chaining together multiple applications, that brittleness kind of improves quite a bit, right? Now,
yeah,
go ahead.
So I was also going to say, so, to your point around legacy systems, one of the really emergent behaviors we see is AI and agentic workflows being able to understand legacy code bases or proprietary code bases that are specific to an organization, being able to reason about how to potentially refactor, or to Socrates' point earlier, like how should we go about the dependency mapping and kind of breaking apart some of these larger monoliths and breaking them into microservices. That's another emergent behavior that's really exciting.
Yes, and so one of the thing was that one challenge on the whether it is going to add technical debt is because of the stochastic nature of these agents, we need to design them in the right way, and that's where even from a thinking perspective, when we were doing, I think in the lab 2, we were doing the currency conversion agent, etc. If you play around, you need to be careful with how you construct these agents so that they are not probabilistic, because then we are passing on that responsibility of correctness onto the user rather than on the agent. And so the design, etc., the earlier conversation that Will was talking about like evaluation systems and agents evaluating other agents, etc., becomes really crucial, because you don't want just a mesh of agents where each one of them worked in a particular demo and you just connected the whole thing together and you hope that it continues working. So we need to be more principled relating to that as well.
Amazing. That was a great overview. A lot of my favorite topics like code modernization using agents. Personally working on one project like this, really exciting. To computer use, to connecting workflows and evaluating them end to end. I think there's a lot of excitement in store, even though it's day 5 for us. But amazing answer. Thank you, Saurabh and Will. Really, Kanch, would you like to move over to the community questions now?
Sure. I love that, Saurabh, you were actively testing the code lab. And thankfully, we didn't know this before. I think we would have been even more, tensed about it.
Next time we should enroll you as a tester, a very unbiased tester.
Unbiased tester, but I didn't know that before this call. So I'm super happy that we didn't know about it. So thank you. So now with respect to the community question, particularly these came from the community Discord channels, and this is from the Discord user Ottil Lasry. For Elia and Socrates, what is the recommended security model for cross-boundary untrusted third-party A2A calls, considering that A2A lacks built-in authentication for zero trust mechanisms? Elia, why don't you go first?
Actually, Socrates prepared.
Yes,
let me start, and then I'll complement.
Okay, so first of all, I want to start with the word untrusted, right? I'm not going to use any agent in my systems if I haven't tested the agent, if I haven't passed through a security review, if I haven't evaluated the agent and generate the performance review and metrics that I want, right? It is like you open the door to an unknown person to your place, right? And you say, get my personal card and do my purchases. You cannot do that, right? Even in agent payment protocol that Will mentioned earlier, what we have introduced there is the notion of mandates with verifiable digital credentials that actually the user needs to sign like a document to say, yes, I approve this to move on. And then AP2 or agent payment protocol is built on top of A2A. I need to say that. And then we can move on to the task and we can perform actually the different actions. Now, about the authentication and authorization, I want to speak about this, is what we have seen is different users or developers, they use to pass the tokens from one agent to another in order to authenticate them. I don't recommend that at all. It is not secure at all, right? Second option is to re-authenticate the user every time that uses a new specialized remote agent. But again, this is quite annoying for the user because every time you need to authenticate yourself. What I see in the future coming is something like a central agent authorization authority that you will have all the agents communicating with that, storing all details of the users, what agents we have authenticated already. You don't need to do that multiple times. Everything will be stored in secret managers. You don't need to exchange tokens. And more or less, this authority will play the role of agent police, if I may say, right? Like a gatekeeper in order to be able to perform everything with a very secure way. Now, from A2A perspective also, the users, they can use extensions, is a capability that we have over there, that they can implement any security measure they prefer. And on top of that, they can augment that with guardrails as well. Ilya?
Yeah, I wanted to add that we need to think about A2A as a protocol that stands on the top of an existing foundation. Yeah, so you don't need to just use A2A to solve everything end to end. You can leverage existing practices that are common to other solutions like a microservices network. For example, if you think about agents as part of a microservice, you will think about API gateways, access tokens, API keys as a way to enforce authentication and authorization, or doing things like rate limiting to ensure traffic only reaches the runtime of the agent when it passes a set of verification. This is done by design so that we avoid to reinvent every security practice on A2A, and we actually build on the top of existing things. So you can use a battle-tested infrastructure like Google Cloud to actually build this kind of skills and capabilities.
One quick call out, like in the last few days, this sounds like an amazing idea to look into kind of like a secure MCP for agents for your capstone project. So we'll be evaluating the novelty of these. So those of you listening, might be an idea for you.
Yes, and also last week, I think we announced in Vertex AI, the agent builder capabilities, which has some inbuilt of this. So I think when you're looking at capstone, like these are the hints which you have to be able to build for yourself. So thank you, Elia and Socrates. On to our next question for Will and Socrates. From Daniel Forberg. In a system of autonomous generative agent swarms, how can we limit their operational scope and assign accountability for undesirable outcomes, including A2A actions?
Well, yeah. Well, first off, thanks for the question. And it's interesting because I think it goes back to the last question a little bit, and that is in many ways we're going to see the principles of zero trust security show up for agents. And meaning it's not just going to be your agent isn't just going to inherit permissions from a business function or individual that they're representing in a transaction. So it's going to be layers of identity, authorization, and telemetry on a task by task and system by system basis. There are things that are out there to help all of you with this. Maybe like agent identity and agent registries are a great place to start because that'll give you like these initial guardrails. And eventually it'll evolve into things like risk management and policies as code or instructions for your orchestrator agents. Because again, as you start getting multiple agents executing more and more complex workflows, you're going to have this kind of orchestrator agent. You're going to have these sub agents that Sarah was talking about earlier. And you're going to want to be able to inculcate those agents with the policies that you have and kind of the trust policies that you have within an organization. And what I see is, and also, we're just talking about cloudy patterns. We're going to see cloudy patterns all over again. So, applying zero trust inside of an organization, we use simple cybersecurity principles, and you can stratify trust tiers, for agents. So you can have agents that exist in different trust tiers. Just like today, we have people and/or systems that operate in different trust tiers within any given organization based on their inherent risk and based on telemetry and based on like what certificates or what authentication they're carrying with them, and also patterns that we're in such early days, like we don't really even know really. In most cases, how these large multi-agent swarms are going to be operating within, one organization or across organizations. So there's a lot to build around the kind of signature of agents. And, a lot of the things that we described earlier in terms of, like tracing and sessions and the telemetry and the places where you can identify what's happening between agents and individuals. That's all going to be the fuel for developing kind of these patterns and these tiers of trust. And I also think we're going to end up kind of where we are in autonomous vehicles, which we're going to categorize the risk and the permissions of agentic systems kind of in these tiers like we do today in levels of autonomy in autonomous vehicles. So plenty of things to get started in terms of collecting the data and inculcating kind of these sub-agents with forms of trust. But eventually the organization is going to have to define for themselves how they feel about these trust tiers and how they're going to free up agent workflows along those trust tiers.
From my side, I want to elaborate on what Will said because I totally agree with him. First of all, we need to reduce the scope, we said, right? How we can do the operational scope of these agents. Agent registry, agent identity, auditability. You mentioned that already, Will. In agent registry, we will store all the different agent cards, all the different capabilities of all the different agents. But that does not mean that all the applications, they need to use the complete set of agents. Probably we need to store over there, this application has access only to those agents, for example. Then after we have reduced the scope of the number of agents we can use, is about agent identity that we reduce the resources that these agents can use, or who is the user that can use this agent. And of course, along this journey, we need to follow the footprints of the agents and to record everything for auditability purpose. But on the other side, we can imagine the swarm of agents, or we can parallelize them with the real communities or real corporate environments that at some point, you have managers, directors, or ICs, and more or less you apply the divide and conquer. What I mean is you can have small teams that they will operate only specific tasks with specific goals. You can assess them with specific KPIs. So we will see agents like managers, reviewers, approvers, auditors, that they will start planning and performing tasks. I have seen already customers implementing this hierarchical model. For example, I have seen customers that they build planners before they execute something. They said, okay, I want to run this task. Who is the right agent to call this, and that? Okay, the plan that I said first, I will call this agent, then that agent, etc. And then they give that to the agents. Then a reviewer assess if this plan was executed correctly. And then an optimizer takes this plan and optimizes that for later on. Of course, even if we have a swarm of agents that they can work completely autonomous, automatic, we cannot forget that agents have been created for humans. That means that human in the loop is critical. We need always to have someone for critical decisions in the loop in order to say, yes, I approve that. With that way, also, you know that the human is accountable, at least for some critical decisions.
Yeah, so just one more thing too, as you mentioned, kind of the architecture of how this is going to emerge. My belief is that organizations as a whole are going to be more secure. And that's because for the first time, they're going to have to actually, deliver policies, or that, there's a lot of inside of most organizations, there's a lot of like stated policies, and then there's like the way things actually work. But in order to give instructions to agents sufficient for them to execute tasks, you have to be very specific. This is back to sort of like, you have to, fine-grained specific, very particular things. And in many organizations, they use humans as kind of the interstitial fluid between, the policies that they have and what actually happens in the real world. And so as more of these policies come to light, or the kind of hidden policies of an organization come to light because they're being written into software, generally it's going to raise the security level of every organization. So agents as a path to improving security.
Yeah. Thank you so much, Will and Socrates. As you all were walking through, I felt like flashy demos are easy, right? Anyone be able to create it. But these hard things, which as you all were mentioning, eval, security, governance, risk, compliance, all of the things are what is going to make a difference when you are positioning yourself as an expert. So thank you. So this question is from Archie6170. How are safe degradation strategies defined for a partially unavailable Vertex AI agent engine agent, focusing on real-time adaptation by peer agents task rerouting, and dynamic capability downgrades?
Perfect, Kanch. It's a great question. I'll try to unpack it, actually, because I see two common themes here, two common asks when building multi-agent systems. The first one is the need for control, and the second one is the ability of an agent or a system of agents to be resilient. So on the first one, we want to avoid those echo chambers, right, where you have multiple agents interacting together and potentially taking wrong assumption and going on a tangent on these assumptions, like in echo chambers. There are some practices to mitigate this, which you can put in place. First of all, you can adopt a supervisor pattern, where you have a central agent capable of monitoring the conversational flow, interrupting and cutting potential loops. You can also adopt a separate, totally independent critic agent that is capable of inject itself and dedicated solely at verifying facts, potentially even using code execution as a way to do it if the use case allows it. I would also consider model diversity. So potentially considering using a larger or a different model for these critical steps compared to the rest of the systems. For example, you may have for a part of the system Gemini Flash, and for the supervisor Gemini Pro. This prevents shared bias because it's not the same model making the decisions, so that the supervisor is not really blindly agreeing with the workers. On the second one, which is the ability to be resilient, so the ability of have certain degradation strategies. The real question is, if one agent is down and I'm using A2A to have a mesh of agents, how do we adapt from it? So really, I would say the goal there is still provide value to the end user, even in the case of failure. Of course, like a common practice will be implement a strong retrying system. For example, you might want to consider exponential backoff so that we keep retrying even if the agent, if the remote agent is failing. But then you can also consider rerouting. So the idea that you might want to back off to a generalist agent that can answer some of the question. It might not be as deep as the agent that is failing, but you can still provide value to the end user. I would also consider a transparent UX. That means that for critical actions, imagine you have a sub-agent which has the only task of booking a flight, and that agent fails. You don't want to back off to a generalist agent to book the flight. You might want to be transparent with the end user and say, the flight is not possible at the moment to book for a flight, but I provided you an itinerary. If you want, you can book it. Here are the instructions. So depending on the UX you can and the product that you're building, you can adapt some of it. And so the idea is really to give this partial fulfillment of your task, where even if one agent fails and 3 others are completely, you can still provide value to the end user by partially fulfilling the request.
Yeah, and I would refer back to the assignment which was there, where I think there are references to when you are defining the agent, be clear with their error messages which are there and failure patterns. Don't just silently fail. Basically, let's say you have a sub-agent which is talking about a particular task. Let's say due to whatever reasons, the service is not available and you are calling and it is giving a 429 or a 503, etc. Give nice responses so that the other agents can adjust around themselves. They know what is the reason for the failure, and through that, they can educate the user and can bubble up those messages or the failure patterns which are there. This actually, I would say, because of the natural language capability of the agents, these systems can be a lot more resilient than traditional software systems, where any code path, if it fails, everything just breaks because you assume perfect responses, etc. Here, there is a chances of, and thank you for a very deep question, really appreciate it. The chances of recovery is a lot higher with reasonable outputs for the end user.
Amazing. And just one quick thing to add on to that, when we talk about agents supervising and figuring out failure modes, etc., let's not forget humans in all of this, because there are also ADK offers ways to do long-running forking of control flows to humans, so some kind of risk management to see when it's become too messy for the agents to figure out, fork it to a human to make the decision. Yes.
I'm actually thinking Bill's comment too, with respect to agents, the coding agents building themselves so that figure out the optimized way of answering this. Sometimes, maybe in the future, I don't know if it's there yet, but maybe in the future, there would be an agent that gets created that solves the problem and then kills it by itself. So it'll be interesting to see.
Ephemeral software development, agents by agents.
Agents by agents.
Buckle up.
Automatic automation.
We have been doing well on the tagline for the classes, so for the sessions, and I think this would be one which we really look forward to. The next question is, the last question is for Saurabh from Chumban Bokche. Agents can take different reasoning paths, making cost unpredictable. What architectural strategies or hardware optimizations do you recommend to keep agent latency and cost stable at scale in production workloads?
Yeah, I think this very well connects with our earlier question as well, right? So I would say if you look from an end user perspective, there are a few strategies that you can use to control cost as well as token length, etc., because it may make some of the applications infeasible, right, if the latency is very, very large. The very first one, and we still see a lot of people not even being aware of it, is prompt caching. As you might have been writing agents, you might have been seeing that the length of the prompts keeps also increasing because you have all these different conditions that are there that you need to capture. You need to describe the tools. You need to do it in a lot more detail. We just talked about error messages. You need to explain that as well to the model. Most of all large language model providers, right, including Vertex as well as others, provide prompt caching, where a repeated prompt which is being sent to the model again and again and again, you don't need to recompute it. That has 2 advantages. Actually 3 advantages. One is your costs go down because we are caching and you are not computing it, right? The latency is better, right? And even to a certain extent, predictability or uncertainty, etc., that also goes down as well. The second one I would say is relating to model routing, and I think there were some other we alluded to it. I think maybe Socrates was mentioning it, that depending upon the level of task or the complexity of the task, you may have a pro model for very, very sophisticated top-level orchestrator versus a much more simpler, like a flashlight even, that you can use Gemini Flashlight for very pointed tasks, right? Like let's, as an example, like the case that we often discuss internally is if a user is saying hello, you don't need a trillion parameter model to go decide what's the response over there, right? So those type of things. And then the third one, which is a little bit more sophisticated, is the constraint sampling piece, where if you have outputs that you think are within a particular domain, and I think maybe Will was mentioning about it, that we could instruct the model to sample only from that space instead of generating everything in natural language, etc. And so that can also improve both performance, lower cost, improve quality, all the benefits that you can imagine. Now on the hardware side, that is, I would say, a lot more involved. That is where there are techniques like KB caching, which is there to improve performance. That's how we can expose the prompt caching aspect to our users. And there are some other optimizations that we do under the hood. There's also speculative decoding to make things faster, as well as quantization is a very, very strong mechanism through which, instead of using, well, right now we don't use like 64 bits or 32. Most of the development is on like 16-ish bits, then 8, then 4, etc. and so on. So those also improve efficiency because you have fewer bits to process, etc. So.
And if I can add one more thing, also guardrails is very important to stop the interaction as soon as possible to find something. ADK probably saw up. You saw that in collabs that you already run, right? We have collabs. We have callbacks before and after calling an agent, before and after calling a model, before and after calling a tool. You can set over there guardrails and to stop immediately the interaction. Exactly. We have in ADK plugins that you can set these guardrails across all your agents, and of course you can link everything with Model Armor. And immediately, if something is relevant, you can say, no, I cannot answer this question, for example.
Exactly.
And just to elaborate, technologies that sort of mentioned things like speculative decoding, prefix caching, etc. This is covered in the first white paper foundational models of our previous iterations of the course. For those of you watching, please go have a look. And we will also attach it in the description of the YouTube link. All right, Panch?
Thank you. So one of the things which the community really loves is also to understand what are your thoughts of where everything is going. Like, we have had incredible discussion, but I would love to hear final thoughts of what you want to say to the community. Why don't you start ahead, Bill?
Sure. Well, as you can tell, probably from this discussion and probably from the last 5 days, it's early days. And all of us here, building technology for all of you, we're really depending on you rolling your sleeves up and exposing where things are working well and where things aren't working well. So your engagement this week, your learning, your interaction, your feedback to us is absolutely critical. Sarab and the team are creating incredible technology at incredible scale, and there's lots more to do. So my final thought is, please continue, exploring the rapidly emergent capabilities of, cloud and AI and Vertex and agent platforms, and get your feedback back to us, because that's how we're learning. As Sarab mentioned earlier, he's got his sleeves rolled up this week. He's debugging for his son. He's blowing stuff away with the delete button. So we're all doing it, and we're counting on you to really, give us those insights that are going to make our products better and better over time. So thanks for your engagement.
Thank you, Will.
They'll be talking about insights and feedback. We'll be rolling out the post-course survey right after this, so before the capstone. So please give us your insights there so we can improve the future iterations of this course and see what you liked as well. Yeah.
Socrates, why don't you go next?
What we will see in the future? Actually, 3 areas. Make everything simpler to go to production. We are not there yet. Second is ethics and legal aspect of things. We need to consider, we need to create some regulations. It is very important. Nobody talks about, or we have started talking about this. And the last thing is live agents. We will see all these multimodality live agents. We will see new ways of interacting with computers. Probably we know now we have the computer use, for example. You can control your computer with agents, but probably in the future we might not need computers at all. We might speak in a speaker and we can do everything that we need, right?
Yes, and I know you, Hypo also has a demo. Maybe we could add it to the live agent with computer use that has been very popular. Yes. Elia, why don't you go next?
Well, future is difficult to predict, but I would say that we will see more and more agents becoming an amplifier for the value each one of us is delivering. And I would say, if I have a suggestion, please start adopting your agents. What I mean is really invest time into developing or using agents that can enhance your productivity, because it's something I personally did for a long time, and really I can see, like myself, looking back in like a year, my productivity has increased. So I will see that more and more and more. On the pragmatical part of it, I would say read the white paper, because we provide a step-by-step kind of execution on how you can build and deploy agents to production. You don't have to start with a full-blown picture. Start simple and iterate over time.
I love it. Last but not least, Saurabh.
Yeah, I would +1 to Ilya, what he said, and I will emphasize on the learning part. The field is moving extremely, extremely fast, and actually it is a good learning opportunity for all of us. Like what agents can do today, even if I think we had references about, like, for example, the ADK, we added a lot of new features even just last week. Agent engine capabilities, we added core capabilities. The AP2, the agents payment protocol, which we believe is critical for the success of agents in the real marketplace that Will was mentioning. Like all of these things have happened. There are more things that will happen in future as well. And I would say to be very abreast with like whatever is the latest technology, so that you can absorb it into highly functioning agents which can go into production. And as Ilya was mentioning, it can also help your productivity, the productivity of your organization and whatever is the workplace. Like super exciting time to be here in this particular field. And again, thank you all as well for participating as part of this journey. And this is a learning for all of us together.
I do have to say though, when you said learning, like all of us have blind spots, in my opinion. We all think, oh, I'm sure you all have been doing this for a long time, but even for simple things, going from AI first to AI native is so important. Like the folks might not know, sort of, we have the Cloud AI for AI sessions. Just that, learning what others are doing and incorporating that in our day-to-day life has been really impressive. So I think all of us need to bring a curiosity for us to be able to build. So thank you so much. Despite your busy schedules, being here, answering questions, sharing your thoughts, it has been a really great to hear all of your viewpoints. Particularly, most of us talk about flashing things, but you talked about the challenges of how the enterprises or everyone would be going through, and then how we help try solving them and breaking down into smaller pieces and adopting it and having sort of try it and then sharing the concerns. All of this has been really, really amazing. So thank you so much for being here, for being part of the journey, and for also the support. We have had this crew who have been going through these challenges. So this is real life experience. So thank you. Thank you so much. Appreciate it.
Thanks everyone for joining.
Thank you.
Honored to be here. Thank you.
Bye.
Thank you all.
Thanks.
Bye-bye.
This has been amazing. And now on to our next session. So we have 3 more segments. We have the code labs as normal, and then pop quiz coming. And then the last thing, exciting thing, which we have Brenda coming in with the capstone announcement. Code labs, can we have Lakshmi on stage, please? Hi, Lakshmi. You're back?
Yes, back to day 5. Hello, Anand. Good. Okay. And what an incredible week it has been. And we are on day 5. Right? So for day 5, we have 2 notebooks. We start with agent-to-agent communication and then end the day with deploying agents to production. So as we start, first, I want to give a shout out to Lavi, my colleague, who is the author of this notebook. Thank you so much, Lavi. Now let's get started. Right? So as you build agents, you find that a single agent is very difficult to handle all the functionality that you have. So as you build complicated scenarios, you will need a multi-agent architecture. You will need specialist agents who are experts in one specific area. But how can you do that? So you might think, okay, I will have a root agent, and then I will have multiple sub-agents who are experts. But real life is not so simple. You might want to use agents which are built by other teams in your organization, or you might want to use agents which are built by another organization. Cool, awesome. But how do you make sure that these 2 agents can communicate with each other? Because they might have been built in a different language, or they might have been built using different frameworks. And more importantly, they might be running in 2 different networks, right, or servers. So you need a standard for these agents to communicate. And that's where the A2A or agent-to-agent protocol comes in. It is a standard for cross-framework, cross-language, cross-organization agents to communicate with each other, right? So what does all of this mean when you're building an agent? So let's kind of dive a little deeper. So what I'm trying to do today is to build a customer support agent. And this agent will interact with the user and answer questions about a product. Like you ask about a specific product, it will give you its price, what are the features of that product, and also the availability. Cool, awesome. But there is a problem. You do not have the data of the products. This data is with your vendor, right? So the vendor owns the products and he has all the details of the product. So how do you make this work? One, you could try asking the vendor for the data, but that's not a practical solution because there are different organizations who own the data. So what can I do here? So I went and spoke to the vendor and they said that they already have an agent called a product catalog agent, which does exactly this, answer questions about the product. Awesome. So we already have an agent and I already have a customer support agent. So, but the product catalog agent is running in the vendor's network. So how can I access it? So the vendor tells me that the product catalog agent is A2A compatible and customer support agent can talk to that. So what exactly does this mean when you say that it's A2A compatible? So, and more importantly, how will the customer support agent know what the product catalog agent does and how to call it? So these are the 2 questions that we need to solve for. So when you say that an agent is A2A compatible, what it means is that it is exposing something called an agent card. Think of it as your business card, right? So this is the example of a product catalog agent card. And here, the agent is giving a description of itself, and it says that my name is a product catalog agent, and this is my description. And it also talks about the tool it has, which is the get product info. And the customer service agent can access this product catalog agent and then get this information. And how can it access that? So since it's A2A compatible, it has been deployed onto a URL. So in this case, we are for this notebook, we have deployed it locally, and hence you will see a URL like localhost. But in reality, this could be the the server in your organization where you are running it. So this makes sure that there's a way for your agent to be called by other agents, and also this agent card explains everything that you need to know about the product catalog agent. So if I take a step back, here there are actually two problems, right, or two parts here. One, how do you build an agent and make it A2A compatible so that all the other agents can access it? So that's the first part. And the second part is, okay, there is an agent out there, and how do I access it? So let's kind of look at the first part now. How do you create the product catalog agent? So you create an agent, as you've done over the last 4 days, and that's get product info is the tool which takes the product catalog and returns the results to the user. And then to make it A2A compatible is extremely easy if you are using ADK. So if I kind of get into the technical aspect of it, it's as simple as making one function call, right? So you have built an agent and you're converting it into an A2A compatible agent by saying the port at which it needs to run and specifying the name of the agent. So that's all you need to provide, and you have an agent. And when you kind of use this function is when the agent card gets created. And this agent card would always be available as .well-known/agent card.json, which you can access it. And in our case, this is on localhost since this is for a notebook. Awesome. So this product catalog agent is already, and then we just need to call it. And how can we do it? So at our end, we have a customer service agent. And this agent can have, sorry, let me just go here. Yeah, so this is the customer support agent. And then how do you make sure that it can access the product catalog agent? So create a sub agent, right? So, and the sub agent here is called the remote product catalog agent. And if you look at the remote product catalog agent, it's a little different from the sub agents that you have created before in the sense that this is a remote A2A agent. And again, like any other agent, it has a name and it has a description, right? And it also has another field, which is the agent card. And what we need to do is point it to the other agent that you want to call. In this case, it is the product catalog agent, which is running in a local host, right? So that is how simple this entire part is. So if you kind of scroll down in this notebook, we have put in some scenarios for testing the A2A communication, right? So there are a few queries like, can you tell me about iPhone 15 Pro? Is it in stock? And then what is actually happening behind the scenes is that our customer support agent gets this query, it passes it on to the sub agent, which is actually a proxy for the remote A2A agent. And this agent will go and fetch the information from the catalog and return it back to the customer support agent, which then responds to the user. So that's how the flow is going to be, right? And that brings us to the end of this notebook, but there is a whole lot of information out here. The documents that you can read to understand A2A better, the sample code you can access, and all of that, right? So also, I strongly encourage you to try out a few of these ideas. Try adding an inventory agent or try adding a shipping agent and see how it goes and let us know. And with that, I move on to my next notebook, which is on agent deployment. So let me just share the tab. Okay, cool. So you have built agents, but it's all in your notebooks, right? And if you kind of stop the session, then you cannot access it anymore. So that's one. Plus, since it's in your system, nobody else outside other than you will be able to access it. So how do we solve for this, right? So the way to solve for this is to deploy it. And today we'll be talking about deploying an agent on GCP. So if you already have a GCP account, you can use the GCP project to deploy on it. But in case you don't have, you can sign up for a free Google Cloud account. So there's a link in this notebook on how to sign up. And when you sign up, you will get $300 in free credits. And this is valid for 90 days. When you sign up, you will be asked to provide your credit card details, but that's a form of verification. You are not going to be charged. And then once this $300 of credit is over, or the 90 days is over, whichever is earlier, then you will not be charged until you explicitly upgrade. And also the demo in this notebook, this stays within the free tier of the agent engine. So I'll talk more about it as we come. And there are a lot of links to the videos and the documents in this notebook. So make sure that you kind of read them and watch this video. Awesome. So let's kind of go back to a very simple agent. So today we are going to have a weather agent, right? So what this weather agent does is it calls a function and it will kind of return to you the temperature in different cities, right? So you have a couple of cities listed out here. Okay, awesome. So you do have the agent, and the next step is deployment. So ADK supports multiple deployment platforms. In this notebook, you will be deploying to the Vertex AI agent engine. And Vertex AI agent engine is a fully managed service specifically for AI agents. It's easy to deploy, and it has built-in auto-scaling and session management. And then if you want to read more about Agent Engine, understand what it is, there's a documentation out here. Also, Agent Engine offers a monthly free tier, the rates of which is again available in this documentation. You can also deploy your agent on Cloud Run or on Kubernetes Engine. Cool, awesome. So we need to have some configuration again for these deployment. And so that's what we are setting in the config file. And once that is done, we are ready to deploy. So Agent Engine is available in multiple regions. And for the purpose of this notebook, since we are deploying a very simple agent, we are randomly going to choose one of the agents. But when you're going to deploy it in production, there are a couple of things that I want you to keep in mind. One, choose a region which is close to your users for lower latency numbers. And then again, some of the companies might have some requirements with regard to the data, right? So which again, it relates to what are the policies and other requirements. So make sure that you follow all of these requirements when you choose a region. So we have done all the settings, and all that is remaining now is to deploy the agent. And with ADK, it is a simple one-step deployment. So it's as simple as ADK deploy agent engine, and then you kind of give the name of the agent that you have created, which is like sample agent in this case. So when you kind of run this step, it takes around 3 to 5 minutes for it to complete. So please wait while it is completed. So you'll kind of see all the logs while it is being deployed. And once it's deployed, you will get a resource name of this format. So awesome, your agent is deployed. So what's the next step? The next step is to query it so that you get a response. So in this case, what our query is, what is the weather in Tokyo? So what is happening over here is this query is basically a query to the remote agent, right? Or the agent which is now running not locally, but which is kind of deployed. And then you get a response. Awesome. So here, throughout the week, we kind of talked about sessions, we talked about memory, right? And then in today's notebook, we have used an in-memory session. So what happens is that when you kind of log out and when you, close the session, all the conversation until then is forgotten by the agent. But suppose, you want to know, say, for example, you ask the weather about Tokyo. Suppose you want the agent to remember what to converse with it in the previous session. What you can do is you can use a memory bank. So memory bank gives your agent long-term memory, right? So irrespective of the number of sessions you have, it kind of saves that information. And suppose I kind of, ended that session and I kind of start another session, and then I ask about, okay, which city was I talking about in my previous question? And it will kind of tell you that you were talking about the weather in Tokyo. So again, there are a lot of resources that you can go and read about, and some samples that you can test out. Last but not the least, once you have used your agent engine and you have tested everything, please make sure that you delete the agent engine. So this will ensure that you will avoid incurring additional costs if you kind of just keep it running. So make sure to do that. Cool. So with that, you're ready for your production deployment. And again, there's a whole lot of documentation on ADK, on Agent Engine, on the ADK deployment practices, again, Cloud Run deployment, as well as GKE deployment. Make sure that you go through them. And with that, we come to the end of day 5. We started with simple agents. Then we talked about multi-agent architectures. We enhanced our agents with tools. We talked about context engineering. We learned about observability. We learned how to evaluate agents. And then we spoke about agent-to-agent communication using the A2A protocol. And finally, we learned how to deploy the agents that you've created into production. But this is just the beginning. I hope that you complete all the labs over here, and we are really looking forward to what you're going to build in the capstone projects. So Brenda will be explaining more to you about the capstone projects. But first, back to you, Sanj and Anant.
Thank you, Lakshmi. This was great, particularly walking through the entire course. It was really good. And I hope folks take the benefit of it, and all the documentation are right there for you to be able to explore further as well. Thank you so much for being here and walking us through the journey, Lakshmi. Appreciate it.
Thank you.
So now we are on to our favorite part of Pop Quiz, Anand.
Yes, get your pencils and pen ready and some popcorn as well.
Yeah.
So let's go to the pop quiz.
In the world people are from, can you all start typing while Anand is going with the question? Go ahead, Anand.
All right, your first question would be, what is evaluation-gated deployment? Is it A, a process where users must rate the agent before they can use it, kind of the thing that Sarah talked about having a trust-distributed marketplace, or B, a principle where no agent version reaches users without passing a comprehensive automated evaluation? We have talked about this today. C, a deployment strategy that only releases agents to internal evaluation teams, or is it D, a method of manually reviewing every single agent interaction in real time? So think about that.
I see answers popping in.
Yes, your answer would be shown in 3, 2, 1, and B. So it's about evaluating comprehensively before you give it to users, and that is, I think, evaluation we mentioned in the previous days and a lot today. So that should ideally be part of your capstone as well. All right, moving on to the next question, shall we? How do the A2A and MCP protocols complement each other? These are two separate things, but how do they complement? Is it that A2A is for delegating complex goals to other autonomous agents, while MCP is for standardizing connections to specific tools and resources? Or B, A2A is for connecting to databases, while MCP is for connecting to other agents? Or is it C, A2A replaces MCP in enterprise environments? Or is it D, MCP is used for remote agents, while A2A is only used for local agents? I see a lot of you have guessed the correct answer in the chat.
I can't believe how you come up with this answers. Thank you.
Very good. Happy to see that you are reading in detail, and hopefully it helps you understand the course even better. So the answer is A. Yes, that's right. A2 is for autonomous agents, and CP is for tools. Moving on to the next question. Which safe rollout strategy involves running two identical production environments and switching traffic instantly between them? Your options are A. Canary deployment, or B. A/B testing, or C. Feature flags, or D. Blue-green deployment.
You can take the course. You should be able to answer.
Exactly. Even the question kind of mentioned the answer, but your answer will be shown in 3, 2, 1, and it's D. So
I see a lot of right answers.
yeah, it's not engineering principles, but this also applies, this also applies to agents because agents run a software after all. All right, let's move on to the next question. What are the 3 layers of defense in Google's secure AI framework as applied to agents? Is it A. Firewalls, encryption, and identity management? Or is it B. Red teaming, blue teaming, and purple teaming? Or is it C. Policy definition, system instructions, guardrails, filtering, and human-in-the-loop escalation? Or D. Unit testing, integration testing, and end-to-end testing? Your answer will be...
Talk about this today.
Yeah, in the white paper. So, and if not, you can think about what could be a possible option here. All right, let's go to the answer. 3, 2, 1. D. So, secure framework involves all of these guardrails, policies, humans, just to make sure that the agents do not go off rail.
And ADK lets you define many of it. Yeah.
Definitely. And if I have a good framework, a framework ADK is super important for your production workloads. All right, let's move on to the final question for the day in the course. All right, everybody. So, get all of you. I would like you to think about it, assemble, and think about this question. You've got to get this one right. In the observe, act, evolve operational loop, what is the purpose of the evolve phase? Is it A, to real-time triage security threats using circuit breakers? Or is it B, to use insights from production data to update evaluation datasets and then permanently improve the agent's architecture or logic? Or is it C, to monitor dashboards for latency spikes? Or is it D, to automatically scale the agent's infrastructure based on load?
I see a lot of wrong answers.
I think that should be straightforward as well, everyone. For example, option number D is should be suspicious to you, but it doesn't fit into the logic. But your correct answer is B, because B is where you evolve the agent's logic and architecture to match what it needs to do. All right, that will conclude our pop quiz. And Brenda, would you like to come on stage?
Yes, this is the most exciting thing, Brenda. I think everyone's been asking for it.
Hey folks, I'm Brenda from the faculty, and I'm so excited to get to announce the details of our capstone project on Kaggle. This is your chance to take what you learned and put it in practice. In this final project, you will be called upon to build an AI agent. We have 4 categories you can submit your project in. The first one is concierge agents, which will help solve problems that individuals have, like meal planning, shopping assistance, or calendar management. The second one is enterprise agents, which are designed around corporate problems like business workflows, data analysis, or customer management. The third track is agents for good. These are solutions for problems that humanity experiences, like challenges in healthcare, education, or sustainability. Finally, if you have a great idea that doesn't fall into one of those 3 categories, we have a freestyle track where you can exercise your creativity. We've covered a lot of concepts and technologies through the white paper, code labs, and Q&A sessions during the live stream. We're really looking forward to seeing how you incorporate them into your final projects. A few things to keep in mind about the capstone project. Each participant can submit only 1 track, so choose carefully. You may work individually or in a team of up to 4 people. It's completely up to you. The deadline for submitting your projects is the 1st of December, but we recommend submitting early in case any issues arise. Finally, the top 3 winning teams in each category will receive Kaggle swag and recognition on our social media channels. Every participant in the capstone will get a Kaggle badge. Now, we have heard a lot of you, including Rob, say that you really want a certificate for your participation in the course as well. I'm thrilled to let you know that we have listened, and participants in the capstone project will also get a certificate that you can share. The capstone project link will be shared with you all shortly on Kaggle Discord and an email, so keep your eyes peeled. Thank you so much.
Thank you, Brenda. That's amazing. And I know folks have been waiting for this, particularly the certificate as well. So we are looking forward to it. And I know Anand, all of us are looking forward to seeing what the capstone projects are going to be and what are the things that are coming out of it. So thank you so much for announcing this, Brenda, and really appreciate it. And thank you for all the help with the course. You're really an effort in making things happen. Anand, we are towards the end, and we are here. Thank you so much for being here. Of course, Anand mentioned it earlier. The post-course survey is really important because that helps us drive towards our next steps. Is there anything to add, Anand, from your end?
No, that'll be all. Thanks, everyone. And I'm really looking forward to how you enjoyed it, your submission to the capstone, and maybe stay tuned for another iteration.
We're already ready for it.
In the future. Yes. All right, thanks, everyone.
Thank you, everyone. It was great having all of you for the last 5 days, and we really appreciate your time. Looking forward to the agentic journey. Take care.
Bye.
Thanks. Bye.
And sometimes I hate that we have to use Docker for everything. Like the least of the evils, though. So technically, Joseph will remember that. Hello, folks. I think we're going to put in a little bit of time today on the vectorization backend. We're still going to do more stuff on Tiny, either tomorrow or early next week. I think, though, I want to do a little bit on vectorization at the moment. I got a couple meetings that might get slotted in later today as well. We shall see. But for now, this is what we're going to work on. Yeah, we're fine here. So, right. I think where we left this off. Fix the drivers first. Hey, Harris. That was good. I got some rest in. It's one of those things where getting a little rest only kind of told me, like, yeah, I'm actually a lot more tired than that, and I probably just need to take a mini vacation at some point soon. But I figure I can wait until, after NeurIPS and all the conference stuff comes out, and plus there are a couple things I need to get done in the next week anyways. So no big deal. Welcome, Jess. Okay, so, right, I remember we have this implemented, but it hangs, right? Let's see how if I did this in a way that makes any sense at all. So, I currently have this buff percent num buffers. Block size is going to be the number of m's divided by the number of buffers. 2 buffers in both spots, okay. Create m's, yeah, with 2 buffers, cool. We can do a little bit of work on vectorization. I'm pleased to report I did not completely stuff myself yesterday, because I got up super late. I slept a bunch, and, well, super late being 8:30, but still. And I didn't have as much time as I would have liked before breakfast, so instead of doing a 10K or even a 5K, I just did a 1 mile test. So it's like 1 mile warm up and like a 1 mile max effort. And I don't actually know exactly how long the road is here. It's at least a mile, so I did something like a 6:30, maybe a little better. I was quite happy with that. Yeah, double buffering stuff, Jess. Split this into blocks, right? Buff times block size. State out. It's all fine, right? The reason I'm working on this as well is no matter what happens with TinyGrad, we will need this anyways. Like, it doesn't matter if it's a torch tensor backend or something else. Is it any model execution performed locally? No, I have a box right here. I do a lot of my dev just on the same machine I'm streaming from. I pretty much have like the same type of machine as we have back there. You see all like the single GPU boxes, and then there's no point using a 6 GPU box for dev. I mostly use those for bigger experiments. Like a 6 GPU experiment is actually quite large for the standards of what I'm working on here, because like here, look, this is running on a 6 GPU box. Actually, this is kind of funny. The fact that this ended up sloping up, because this is a completely stupid neural net architecture that's doing very well in neural net 3. But the reason I pulled this thing up is this is a 6 GPU box run, and this x-axis is in hundreds of billions of steps. You know, there's over 1.5 trillion steps worth of data here. Something like uncompressed data would probably be like 12 or 13 petabytes. A lot of data. How do you recommend getting into PufferLib? All right, yeah. We have some new people here from the content yesterday. So the usual advice, because this is the most common question I get asked, so I actually put a good amount of effort into just putting all of my best advice and all my best guidance in one place. If you're new, / don't know how to write good code, / want to know like how to think about science, this one. If you want specific RL advice, this one. These are interactive in the sense that they will tell you do this, do this, do this. It's not going to just be like read this and you're good, but it's a lot more condensed and a lot more like fast-paced than pretty much anything else out there. You can work through this pretty quick. So there you go. Is there anything? I don't think there's anything we could block and screw up here. I think it's just gotta be the back. Right. Good thing. Happy Black Friday. How many hours of streaming today? That is actually to be determined because I have 2 people, well, 2 clients, 2 like potential clients who wanted meetings, and with Thanksgiving and stuff, there was like some scheduling, whatever. So I have my email up on the other window to see if anybody books last minute. If not, if nobody books last minute, then I'm probably just gonna stream like probably 5 hours today, and see if I can get a good chunk of this done. Well, I guess now we start figuring out where it's blocking, right? That's the obvious thing. Take my watch off. Watch always play with my keyboard. Easily do 5 to 6 hours, 5 to 7. Yeah, but that's not really that much work if you think about it, right? Like a good work day, if I were working hard, I'd be cranking like 12, 14-hour days. This is kind of towards the end of a block of work where I've kind of like done as much as I can and tired myself out. And I'm kind of just like putting in, more manageable 4 to 6 hour blocks here and there, trying to like, there are like a few concrete things I want to just have be fully done before I take like a longer break. The vectorization is definitely one of them. The evaluation of TinyGrad is another. And I say it that way because like I want to basically have no uncertainty about the remaining work in Puffer 4. And as it stands, it either has to be like get some cool kernels out of TinyGrad somehow / do something with that, or it's going to be like do CUDA graphs plus finish custom kernels plus like some other stuff. I think yeah, so I want to have all the uncertainty out of this before I finish this block of work and take some time off. How much GPU do you recommend locally on the dev workstation? How much GPU do you recommend locally? I just have a 4090. Is that 4090 on this box? Yeah, 4090 on this box. If I were to get this now, I'd put a 5090 in it. 9950X. I mean, the one vice I have is when I'm tired, I end up playing games, so it's like, yay, dual purpose. The only saving grace I have is I don't have Windows on this machine at all, but at least most of the really addicting stuff I can't even download. I'll pull this up actually. Just this is what I've been doing lately. This is awesome, and it's kind of on topic as well because I do all this work on NeuralMMO. That is one dev has just like apparently while I was cranking NeuralMMO, one dev was cranking a single player MMO with scripted AIs that follow you around. It's really freaking cool, and there's kind of some stuff in there that makes me think about NeuralMMO 3 is going to be solved at some point. What do I do for NeuralMMO 4? This is obviously Linux. I don't understand the whole like dev on Mac thing. It's just bad. I don't know, deving on a laptop in general just feels freaking bad to me. I really like my the setup I've got here. Honestly, the biggest thing, because for a while I would like not want to be at my desktop and would want to like go dev on the couch with my laptop until I got myself a proper chair. If you're in an office chair, you'll basically just never want to be in it. But something like this is just like pretty much everybody as comfortable as just being on a sofa all day. Okay, so what the heck happened here? I'm gonna figure out where this thing is hanging. So this thing, obs action. So it actually did a couple cycles of this. Oh, maybe there is a race condition. Hang on. I gotta go through the way that I did all this logic again. So this is, for folks who have not seen me work on this before, the purpose of this thing, this is a C vectorization backend for our custom RL environments. So the idea is you run a bunch of threads, maybe each thread is going to like handle processing of environments, kind of just as they're available, but it's all done in like shared memory with no redundant copies. And the really key thing that I'm doing now, so I have a version of this in Python that's very, very low overhead for Python. This will be a little bit faster, but then the key thing about this is that I'm going to buffer the CUDA transfers. So the idea is by the time that you need a new set of observations, not only is it already going to be computed, but it's already going to be moved onto the GPU for you. And that's the thing that makes it substantially more complicated to do this correctly. But this is going to eliminate like one of the biggest sources of overhead in RL in general, I'd say. And it's one of the key things that like makes people try to put environments on GPU even when it's like obviously wrong. So yeah. What chair do I have? I mean, this is just like a recliner, man. This is like a full recliner. It's not an office chair. And if you think that's bad for your back, then you gotta deadlift more. Like comfy chair plus stay in shape, way, way, way better than like ergonomic whatever the hell plus not do anything. All right, so the logic for this thing, this is the worker thread. Yeah, it's funny actually. One of these is cheaper than a good office chair as well. Isn't that nuts? All right, so we've got this threaded step. So this thing is going to wait for work. Let me. How many of these did we get? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Let's do this. I really like that I don't have to rebuild this. So this entire thing is just a DLL. So I just that script, you see that builds, it runs instantly because it's just building a tiny little C DLL, and then the heavy thing doesn't actually need to be rebuilt. Okay, so look at this. We have all this stepping. 3,000, 4,000. They all print out of order, which is fine. So this is all the way. Yeah, it looks like this actually gets through a few cycles. Let's actually check this. Index. No, I don't actually know which one this is. Okay. Is there a better way of debugging where exactly this is blocking? I don't think so. I think I just sort of need to look at the way that this works and figure out the possible deadlock spots. Okay, so you're gonna call receive. Play. Do this. Right? You're gonna call vec receive. And then you call vec send, right? Yeah, so you call vec receive, vec send. So what's receive going to do? Receive is going to do. Go check reset. I think I did reset kind of hacky. Yeah, so reset just does. Well, this shouldn't be async. This one we want to block. Okay. Ooh, okay, that actually got us something quite different. Actions ready. I was ready. We got actions ready twice, which is jank. Receive. The multi-threaded. Use the ThreadSanitizer. If that exists, then yes. This is not something I've had to do before. That might be surprising, but like I wrote Python for 10 years, and threads in Python are worthless. So I did a ton of multiprocessing and basically no threading. Is that just in like every compiler, or is this something separate? Oh, it's in Clang. Ooh. fsanitize equals thread. How does this work with the DLL? If I compile the DLL with this, and then I import it from something else. I didn't realize this was built in. I used the address sanitizer. I didn't realize it also had thread sanitizer. That's cool. Scripts build back. Yeah. Okay, so that's gonna break because. Well, we can just use this as an excuse to write a test for this thing, right? Yeah, it's kind of funny, Vlad. I'm not trained as a systems dev. Like, despite all the low-level stuff I do around here and how like RL's getting super fast, like I'm a researcher. I wrote Python for 10 years, and I just kind of like went more and more towards genocide over time. Been learning a lot of stuff lately, but there are definitely gaps. To be fair, the thing that put me off of systems in the first place was all my systems courses in undergrad. They didn't tell us that any form of sanitizer existed at all. Yeah, it was a mess. That was binding.h. Okay. Yeah, so I think that all we need to do here is vec reset. All right, so now we're going to receive buff to and then actions for action random 3. Okay, so we just essentially force this thing to be. I think we do have access to this. I think we can just force this to be random actions. Computer runtime not found. Lovely. Yeah, you just need this include, right? This. Cool. What are you working on today? We're working on devectorization for a bit. This is test binding. Should it not be test DLL? Oh, okay. Do this. Create environments, rec reset, step, send. Cool. You mean to use? Incomplete type. Do I need to test this through the DLL for some reason? Is there any reason I need to do it that way? Kinda isn't, right? Full DLL test. By just binding. Okay, that's better. There's no reason we need to do this through the bloody DLL every time, right? See? Okay, so we can't find the CUDA stuff. Oh. Does this have to be shared then? The way I have this, it has to be shared. Yeah, that's why I had it this way. Okay. Hey, Convert. Welcome. Oh yeah, I need to buy a couple things. A couple small things. Tiny Red doesn't have a $20,000 off for servers or anything today. I say. Any new PCs? Yeah. They have them on customs or they just have them on pre-builts? Nah, they just have them on laptops and pre-builts. It's actually kind of funny. I probably will get one of their laptops next time just because of how bad Razer is just screwed up on my current one. But I don't really use a laptop at all, so my current one. Any good pre-builts? They usually skimp on at least something. I usually just go grab their custom ones and put what I need. Yeah, I'm not building my own stuff, man. I've built enough PCs in my time. It's like it's no longer worth my time to build it myself. Incomplete type env. Yeah, so this is the thing you can't do, right? Yep. I'd hope with the new stuff you're doing, there's at least some reasonable comp for that. Raise prices on boxes? I hope not. I'm thinking about grabbing an 8x 5090, but I really don't want to do it until I see the benchmark on Puffer 4 and like confirm that it's actually going to be useful, right? It was a $50,000 server. I don't want to get it if it's not going to be like genuinely awesome. And I wouldn't mind getting like a bunch more of the single GPU boxes as well if I can get them at a decent price. So we can have just more contributors doing stuff. Put some of the the revenue back into Puffer machines probably early next year. Okay, so this is going to be actions, right? Actually, I don't know how to do this without Torch. Hang on one sec. And then we'll get ThreadSanitizer and we'll have a standalone test and things will be good. I do not want to launch a freaking kernel. That's obnoxious. Yeah, because I don't want to have to do... that's annoying. I suppose I don't need, Yeah, there you go. CUDA memset. Better and cleaner way for non-zero values. Why is it doing this? I think this is fine. Yeah, I think I can just set this here. Like, I just need something that's gonna cause the kernel to have to sync, right? This is gonna require me to include. Yeah, this is gonna require me to include the CUDA runtime though. Let's do it this way and we'll see. Wait, what? Define symbol. Oh,
Welcome. I hope you're all in the right place. Welcome to EECS 49800.
I just need to compile both of them with it. Try this.
Welcome. I hope you're all in the right place. Welcome to EECS 4980007/598005. This is special topics class.
Okay. Operation not permitted. I'm in a container. Oh gosh, are you kidding me? Do this. Oh, that's annoying. Gotta love Docker. We'll have to do it without it. I do not want to have to remake the container. Actually, but ThreadSanitizer would be so nice to have. Oh, no, this is way better. Yeah, I need this. This will just save a ton of time.
Error. That seems really stupid, but we'll try it. And sometimes I hate that we have to use Docker for everything. Like the least of the evils, though. So technically, Joseph will remember that. To host Alec. Okay. It should be this. I suppose I could commit this stuff and just try this not in a Docker. Would work, right? I already have it set up on tiny boxes. Should we just do that? Let's just do that, because otherwise this is just so dumb. Screw Docker, man. Then I won't just be sitting here doing fighting Docker. I'll actually be able to fight the bug. Yeah, this one is free. I will watch the Ilya interview on stream at some point, Jess, when I get a chance. Oh, we have a bunch of people on YouTube at the moment. Welcome, everybody. If you're new around here, I stream all my dev. It's all open source. We're currently working on a high-performance vectorization backend for the next version of Puffer 4. This is going to do a bunch of stuff that's going to make pretty much all of the GPU, CPU transfer overhead go away magically. But there's a bunch of threading, and I'm tracking down some data races. If you're interested in my stuff, though, it's all here, Puffer AI. You can help me out for free by starring the repo. And if you want to get involved with all this stuff, Discord's right here. Most of these environments are built by contributors. And a lot of these end up being really useful in research as well. Back to dev. Okay. So now we're on tiny boxes. And the reason I'm doing this is because the tiny boxes don't work on, they're not using Dockers. So this should just be a quick way for me to get the address sanitizer to run, or the thread sanitizer rather to run. Hey Tim, welcome. Yeah, and if we can figure this out, so pretty much I have this working with one buffer. But what I want to do is I want to make it so that when you compute your observations and actions, right, your model only goes through the environments like in chunks. And then while you're processing this chunk over here, you know, then this chunk over here is still computing observations, which is already how PufferLib works. But the difference is that now instead of computing observations on CPU, it's also going to move them to the GPU for you in the background, because that is the main source of overhead right now. Pretty much in all of the RL we're doing. There are a few other like low-level sources of overhead that I am fairly confident I'm going to be able to remove in this next version. This is the big one, and this combined with CUDA kernel fusion, combined with maybe CUDA graph should get us 10 million steps per second training. That's the goal. I don't want to launch this before we have 10 mil steps per second. PufferLib extensions breakout.c. Apparently I forgot to commit this. Okay, so now we have, we no longer have sanitizer errors. Why do we have this? Ooh, apparently this test does not, apparently CUDA is not getting included in this. That's weird. Uh-huh. So CUDA does not get used anywhere in here, but this end of binding DLL does. But I thought that I have, well, this is definitely, oh, okay. Yeah, it's because, it's because the setup.py file, when I'm running this from Python, yeah, this is getting included from here. Oops. I thought I had. There's got to be some extra flag. Yeah, the link args. I thought I had that. Oh, I went. Did I not have that? Let's just try that. L, and this goes underneath here. Yes. Okay. This is what we wanted, folks. This is exactly what we wanted. So now we have ThreadSanitizer. And this will tell us exactly what we're doing wrong, and we won't have to guess. That is incredibly convenient. Right of size. Interesting. So we're actually getting a data race in compute observations itself somehow, which should not be possible. I think that's a real error, though. Here. Let's see if anybody else. What was the result for TinyGrad? It's good so far for both of you guys. We're going to do more TinyGrad stuff either tomorrow if we finish this or early next week. We're definitely doing more stuff with Tiny. You know, I didn't get enough time yesterday in to say if I'm like fully on board or not yet, but what I saw I liked. I mean, so far the impression is definitely better than Jack's. But we'll see whether it gives you the same low-level flexibility as Torch does. Like, Torch's low-level stuff is terrible, but at least it exists, right? Alright, so how on earth could this possibly be touching the same environments, right? Because you do atomic fetch, add, explicit. Let me go check what the hell is going on. There's some weird construction or something. Give me 1 minute, and I gotta get coffee anyways. Oh, and yeah, let's make it 3 or 4 minutes. I'll also get my first bench set in for the day. 9 reps. Build number 10. 10 would have been tied PB. And that PB was from when I was 15 pounds heavier than I am now. So, 210 for 9 ain't bad. I only weigh 170 at the moment. I think I PR'd the mile this morning as well. It might have been like an exact tie with my old one. I'm not quite sure. Hey, David. All right, let's get back to the real heavy lifting here. Hey, Ratswag, welcome. So I don't understand how there could possibly be a data race on this of all places. 5'9", Jess. Plum average. 210 on bench? Yeah. 210 for 9. My best single ever is a 265. That's when I weighed like 187 though. That was much heavier. I'm not doing like heavy triples, doubles, and singles at the moment though. Pepe, I've been saying that I will watch the Ilya and Dorkesh podcast on stream at some point. I haven't gotten around to it yet. That's disgusting. I feel like Fred from, Scooby-Doo. Oh, I bench 210. It's like, alright, it's okay. You'll get there one day. Hello, welcome. I'm definitely still out of breath from the 1 mile this morning. I gotta so I did something kind of stupid. This is a $100 phone. I got this thing as a temporary thing because I ordered a minimal phone. Figured I'd try it and see if I like it. But I have not actually bothered figuring out how to get Strava and everything set up. So I have not synchronized this to my watch data from running for the last 2 months. So I actually don't know how good any of the PRs I have set are until I go and do that. But I know I've gotten several of them. He doesn't say much. I will be the judge of that, Tim. Is there anything that would make this? I guess technically screwing up the work index could make this atomic load explicit. But this just reads to it. So wait, how on earth can this possibly be data race? Still get mad at Dorkesh? Of course I will. From what I've seen, I don't exactly have a high opinion of him. That's why I tweeted, Ilya's literally the only guest that he could get that would make me watch his podcast. Is it possible? Hang on. What does this say precisely? Create environments. Oh, wait. It's in create environments. It's wrong. Wait, no. Created by main thread. Right of size 1 at this address. Right of size 1. Is it telling me that it can get all the way around? Huh. Does that make any sense? Is this a real bug or is this the ThreadSanitizer being like wrong? Like I haven't used this before, so I don't actually know. Because the thing is, I'm synchronizing. The thread should be getting synchronized through CUDA. And let me go look at this manually a little bit. Because this is just counting upwards forever. Oh, this is going to skip environments. This is bad. Yeah, this is going to 100% skip environments. I didn't realize that. Yeah, okay. Is it? Yeah, it is. You can't actually have this like index less than end check. Okay, so we have to redesign this a little bit. This is definitely a race. Do you see why? So because like this less than check, this is just like ignores the last few increments before this syncs. But then the index is going to be wrong. That's a problem. But this counting up forever architecture is like kind of nice. So let me see if I can kind of just talk through this. So what's going to happen is you get all your environments reset, right? And then you get observations submitted. And each time you submit a batch of observations, you increment this end counter, right? Not great. Not really great. I could assign them explicit chunks of work. That makes it easier to synchronize, but I think you can lose perf doing that. But isn't this like a very common architecture? This is just producer consumer, isn't it? Single producer, multiple consumer. So why does this feel off? Well, because you want this to be super low overhead, right? So I'm trying to manage this just with like one atomic index. And the problem is well, the end index is basically, yeah, that one doesn't have to get checked very often. You do just have this work index. Yeah, this is definitely a race condition right here. If you were to fetch these both at the same time, no, it's because you need the entire block to be atomic. You'd have to lock the whole block. You'd basically have to do a more complicated locking mechanism for this, rather than relying on atomics. That feels sketchy, though. That feels sketchy. Yeah, so these atomic ops just give you like a very minimal set of things you can do without more complex locking. I'm not done testing Tiny Rat Swag. I'm going to be doing that more. I'm working on our new vectorization stuff. It's going to be pretty awesome, but it's going to take some work. A dish. This is true. This is very true. I still have not read this. I've meant to. Oh yeah, this actually does get me excited about the interview, because this is spot on. This is basically what I've said the whole time. And actually, this is kind of what I told Ilya, like, 7-8 years ago now. When he asked me, like, what I thought about language models, it's like, yeah, I think they're going to work really well, but they're not going to solve everything. And you're going to need, well, in my case, I thought it was you're going to need learning from sim. You need RL, interaction. Okay, so I can just bite the bullet here and do some more complex locking, but this loop you want to be very tight is the problem. You actually don't want to do any more complex locking in here if you can avoid it. And this is actually, So really all I need then is, if I fetch the current index and the current end, you'll never go over it at least. Hang on, does that work? Wait, I think that this does work. Hear me out. So if you make sure, I think I just have to change how I broadcast a little bit. So when actions are ready on CPU, I add block size to the end, and the problem only happens, I think, when this has already gone past the current end point, right? Because then you're going to miss some environments. I think that's the key problem. And then you say, hey, your actions are not ready. Cool. And then you're just going to check when the work index is greater than this start. Yeah, so this can definitely screw you over. Okay, hang on. I have an idea. Int end. Concurrency is very difficult for me to think about for whatever reason. So what I want to do is I want to avoid incrementing index at all costs above the end, right? What about C atomic? C atomic. Flag. Fetch. XOR fetch and. Change explicit. Well, end only gets set. End is never going to get like smaller on you. The problem is, and we don't actually care if end gets incremented. The problem is just index, right? We don't ever want index to go above the end. Hang on. The heck is this? Atomic fetch add plus compare. Oh, that's interesting. Why the hell didn't I think of that? That never breaks, right? Isn't that like, that's so obvious? Why the hell didn't I think of that? Is there some reason this doesn't work? This end can still go up here, right? Atomic fetch sub implicit 1. Yeah, like this, no? And oh, this is a different one now, isn't it? Cool. Okay, so let me think about this now. Can this ever result in you processing this index twice? It can't, right? Because you only ever... So what happens if this gets triggered a whole bunch of times, right? Let's say you add up, you go way above the index. this never happens then, and they all get subbed out. And if end goes above on like one of the threads, then you'll process out of order. You can end up processing out of order. Slightly. You can end up processing slightly out of order, I believe. Is that a problem? Up to num threads out of order? I don't think so. I don't see why it would be. I think this is fine. And this is very, very low overhead. This op. Okay. Let me compile this without, well, let me see this. This previous write, vex send. You don't track. I don't think it matters here. Because it's only, hang on, does this? Oh, actually there is still a race condition here, shit, there is. So, your last threads can still be processing C step, and this work index will be too high. Okay, that is annoying. I could add a completed index. Does that help if I just add a completed index? That does it, doesn't it? Let me see what's going on in my thing here. One sec, guys. All right, I thought about how we're gonna do this. Nah, they're just doing a little bit of maintenance. Invert. And apparently they left a pair of pliers up there. But all we need to do, I think, is add one more atomic, which is going to be completed index. And I think all I have to do is this. Atomic add explicit. We did. Like this, right? And then, instead of checking the work index, yeah, see, this is, I even knew it right here. How many NERPs have you attended? How's the vibe changed there throughout the years? I don't know off the top of my head. Somewhere between 4 and 7, I think. First year was 2017, which was back when it was still called NIPS. Other way of not having to worry about it is to use code just for you. I mean, the theme around here is I kind of do all the ridiculous, painful, low-level crap. And then you all just get to do chill, low-level game dev. And that actually somehow turns into real awesome research progress, which is pretty awesome that it works that way. It's pretty cool. Why doesn't autotune work? The reason that autotune doesn't work, Jess, is because our M's got so fast that like I haven't bothered with that thing in a long time, because you no longer need to run autotune on anything native because everything is just fast. Ideas for a strongly tree-like structured env. There are a lot of things you can come up with that. It's difficult to come up with meaningful ones because, like, technically everything is an exploration tree. I'm kind of fresh out of intelligent thoughts, honestly. I'm kind of just coasting on the last bit of this dev before the holidays. I just have like a few more things that I want solid on Puffer 4, and a few more things to get done for clients. Not atomic add explicit. So far, Chungli, yes. I did not finish it yesterday. I thought I was going to have all day. And then my family informed me in the morning that Thanksgiving celebrations were to be held at 2 p.m. instead of, 5, 6, 7. So I'm going to do another stream on that. Maybe tomorrow. If I happen to, by some miracle, get all the vectorization done today, I'll do TinyGrad tomorrow. If not, then it'll be once this is done on like Monday or Tuesday or something like that. Atomic add. Atomic fetch. Should be fetch. Use variable work index. Yeah, we don't need this here anymore. Okay. Read size of 4 and step. Previous write. C reset. I'm a little sketched out by this because this is a synchronous operation. So yeah, this entire thing is synchronous. It says it was previously written by the main thread in reset. How is this a data race? You always call vec reset here before you call receiver send. Oops. When does it start reading? Hang on. Maybe it is off. Go look. Geez, everybody watching stream on Black Friday, welcome everybody. To all the new folks here. That is not including anybody on X, 27 people. So if you're interested in RL, whether you're already in the space or you're interested in getting involved, this is all free and open source work. The vast majority of it does not require you to wade through low-level hell, though you're free to dig into that if you want to learn stuff there as well. It's all on puffer.ai. Want to help me for absolutely free? Feed the puff for a star. It actually helps me way more than you'd expect and lets me spend more of my time on this rather than like client stuff, business, whatever. Now, there's technically a company here as well, even though I spend all my time on research. Discord's where all the dev happens, and I also post educational stuff on X. And if you're looking to get into RL, the articles on my tab here are where you get started. Has all my best advice. Back to dev. Okay, so we've fixed a couple of these issues. Now, when does this thing get started? It gets started as soon as... I mean, it gets locked right here, doesn't it? So, wake cond. When do I wake the threads up? the thread manager wakes these threads up, right? This is when you create them. So it initializes the wait cond. So then these threads are all created. I'm a little confused though as to where wait, does this not get broadcasted at all? It only gets broadcasted in the C thread manager. Oh, okay, I'm dumb. Yeah. Wait. No, because then this only broadcasts when actions ready on GPU is true. Right? Threading actions ready on GPU. Ready on. Where do we set this? It's on vec reset, right? So you set obs ready on CPU to true. Actions ready only gets called when you call vec send, no? Okay, so let's actually just see when everything is happening here, right? I think I have some idea now. So let's do a quick F worker on wake. I don't have my autocomplete here, so give me if I mess things up. Woke up. Hello, Hyper. Welcome. Okay, so worker wakes up here. So then we're going to figure out actions ready, obs ready. Okay, perfect. So we already have these in place. And then we're going to call the bottom, we're going to say finished creating n. Okay. Anything resonated? Everybody keeps asking me that. I've said I'm going to watch that podcast on stream. I have not watched it yet. Probably not going to be today because I'm actually getting good stuff done on this. But we are going to watch that on stream. So, and then I'll probably post the VOD of that on YouTube. I think I'm allowed to do that, right? I'm super fast. Data transfer. Yeah, so this should actually fix that, Jess, completely. Now, obviously, you can't get above. We're going to have a bandwidth test that tells you exactly how many gigs a second you can have of OBS. But, like, we should be well under control with this. There are a couple sort of weird side effects, I think. Shouldn't be too bad, though. Especially with the other optimizations that we have going for us. All right, so we want to do break 57. Okay, so new thread. All the workers are waiting on waking up. thread manager is initialized, finish creating M's. Nothing can possibly be racing yet because everything is just waiting. And I think, actually, we're going to do one other thing here. Do I have any threads that are just like... There should be one thread that's spinning, no? Thread manager initialized. I thought I have one thread that I just have busy waiting. I do have one, don't I? Why don't I see one thread like spinning? Oh, I do, right here, 37. Yeah, 37%. Wait, but this is the display service. This is not even my thread. Oh, because I'm in GDB. Duh. Wait, no, GDB shouldn't stop threads, right? Yeah, GDB shouldn't stop threads. Okay, I actually have no idea why this thing is not taking any compute, but whatever. We'll not question that for now. Okay, now we call vec reset. And no, nothing gets printed because this is a fully synchronous function. Now we call vec receive on the buffers. And nothing should happen again because the only thing that vec receive does synchronizes this stream on CPU and it sets this to false. Okay, ob's ready, and I don't think this flag gets used at all, right? It should not get used at all. On. Yeah, so this only gets set by this here. Cool. Next one is to update Discord. Takes 2 seconds, Jess. Just dpackage-i on the binary it downloads. It's a little annoying that it's not automated, but... now this should print a bunch of stuff. Okay, so we called vec send. PyTorch PR get merged. Let me get rid of this bot real quick. I have not checked it. And I don't want to break momentum here actually because it's complicated. Okay, so what do we get? We get workers woke up, actions ready on CPU. Right, so this, because we call vec send initiates, an asynchronous copy. Right? They're ready on the GPU, yes. And then the manager thread this waits until this CUDA transfer is done, and now obs are ready on the CPU, not just the GPU, right? And then all the workers are going to wake up. So what is this race? This is saying that we have a race vec send Oh, did I do this bad? I think I did it bad. Wait, why is this a problem? Is the ThreadSanitizer just expecting me to sync everything? Or is it too aggressive? Or do I have something wrong here? Let me see. So here, send marks actions ready on GPU as true. And then this thing is going to poll Let me go check on this. I want to see if this is just the sanitizer being pedantic. I think either way, it's probably will be good to adjust this. Oops. Any advice for noobs starting out in RL? Entire guide of it, my guy. These two articles, and feed the puffer a star. All free, and all the resources that this points you to are free. Okay, so let me just go double check. I mean, there's no point, not really a point in doing this. I think I can just do atomic flag. Atomic flag. Let's do C atomic flag. Oh, it's just atomic flag. Cool. Atomic flag star. Atomic flag. Atomic flag. How do you check this thing? Just atomic load. Flag clear. This, right? Atomic flag. Okay. Is atomic flag test and set buffer. Then this will not have anything possible to complain about. Atomic flag test set. Atomic flag. Flag. Set. And even if this is the ThreadSanitizer being pedantic, I'd like to pass the ThreadSanitizer because that's kind of a useful tool to have. And now I get to do, well, not atomic load. Atomic flag clear. Atomic flag star. Cool. And okay, so I think this is going to be what we want. Atomic load. This needs an ampersand. What was it 123? Atomic flag clear. Address must be pointer. Atomic flag. Yeah, this will just do minimal. Use. Do you not have this? Trying to set it. Like that. Member reference type is not a pointer. Yeah, I just made the same error a bunch of times. No worries. Those should all end up, like, those will all get cleaned up anyways. Flag test. Oh. Are you kidding me? That's super stupid. Why the hell is it like this? That's so annoying. Go away, AI. Oh, okay, it's a low-level thing. Fine, we just want atomic bool. But then why is there not a C atomic? Why is there not an atomic bool? Oh, there is. But wait, there's not... Oh, you dummy. It's just atomic bool instead of atomic flag. Alright, that's easy. Does Puffer have an easy way to use image obs? Yes. You have to create the image arrays manually in step. Well, it depends. Like, if you have a custom environment, then your custom environment has to return image obs, right? If you're using an existing third-party environment, then it's already going to return image obs, and that's just an array. Like, images are just arrays. So the reason that we don't use image obs usually is because they're slow to compute and they're big. But there's nothing preventing you from using them, right? There are like plenty of M's that have them. The only advice I can give you on that is, ideally, if you have to use image obs, like usually you downsample them, do the downsampling operation like as close to the env as you possibly can, so that you're not like manipulating giant chunks of memory on the main thread. Be surprised how often people mess that up. Discord. Oh, cool. Thanks, Jess. Oh, I see. Your content. Oh, you're also, you do technical content? Hang on. Oh, okay, cool. Heh. That's fun. This one's actually kind of relevant. Yo, Green, so RL is really, really bad at mazes. Like, and if you think about it and you know a little bit about the field, it's kind of obvious why. But we do have the state-of-the-art maze agent by like a factor of 10 in PufferLib, which actually is way smaller of a maze than what you even have here. Like, again, it's a really, really bad problem for RL. But that environment is included and you can play with it. Somebody just PR'd TCG stuff as well, which is kind of cool. Cool. Not Atomic Set, what was it? Atomic Store. All right, this now builds. Nice. We get farther this time, I believe, right? Okay, we make some M's. Reset some M's. Interesting. We are not getting any... We're not getting any thread errors now. but we are hanging. Huh. So we fixed some stuff, apparently. That's cool. This. Ooh, look at this. That's a cool PR. I like that. Ever so slightly faster as far as ELO is concerned. That's good. Yeah, the architecture thing is kind of funny, Jess, because, like, even with a completely terrible architecture, this is neural MMO. Look at this. This is without the conv encoder. This is with just, like, a flat linear layer as the encoder, even though you have categorical data in there. No retuning of hypers either. Right, let's see what this gives us when we just run like this. All right, so now we have some ThreadSanitizer. So we are saying that there is a write in C step, previously in C reset. Interesting. Oops. Create our M's, reset our M's, buffer, Steve, send. Worker woke up. Steve, send. Steve. Okay, so let's get some more debugging in here. F. Save. Waiting on obs. View obs. GPU. We're just gonna like add some stuff in here, right? And oh, and let me make sure I don't have any important emails. Speak is better, perfect. So I don't have any emails last minute. Very good. And Twitter has reminded me third bench press set time. Take a couple minutes. I get my coffee refill as well. As it is, what time? Well, 2 p.m. I should be able to get some stuff done. I have it, and if there are no meetings, I got 3 hours more to do this. Okay. So. Get rid of this. We don't need this. This one's here. We also want to do vex send. Literally nothing blocks in send. So. Trained a small, stupid maze-solving model with Puffer. That's cool. Yeah, it was one of the things we did in our demo, right? For, where's the maze agent? We had a really good maze agent. The 3.0 article. Yeah, this is our maze agent. And if you know the literature in RL at all, like, this is SOTA by an order of magnitude. Tiny bit better. I mean, we didn't have to do very much with it. Yo, Kevin, how's it going? Were you actually benching live? Yeah, I mean, I do all my sets in the background throughout the day. Have you not noticed? That's kind of one of the perks of working in a gym, is I get to just do my sets throughout the day. Hey, Nalacha. Welcome. How is the compute startup going? Nalacha does, what's the URL, man? I'd be using it, but I haven't used any cloud compute in a while since I have all these servers. What? Ah, gotcha. Where are you? There it is, cloudy. Nalacha builds this. It's pretty cool. So you all can go check that out if you're looking for cloud compute. Actually, this thing has a ton of backends, right? Does it aggregate? Does it include Vast in the aggregations right now? This is pretty solid if it does for that. No? Ah, yeah. So Vast is like the super cheap one for single nodes that I usually recommend my users use. The stuff is just so cheap. I mean, we have all of our own compute now for Puffer, pretty much. Unreliable network speeds. Yeah, I noticed that. But the thing is, it kind of doesn't matter a lot of the time for single node stuff. Like, there's basically no point in going to multi-node with how fast a lot of our RL is. If you'd ever like to see 1.5 trillion steps worth of data on one plot, here you go. X-axis and hundreds of billions of steps. Like, I don't know, 12, 13 petabytes uncompressed of observations. And this just ran in, this is like on one tiny box, 6 GPU server. You definitely don't need Cube for this, man. It's way too heavy. I just have, like, here. If you look behind me, you can see all of them, right? There's single GPU boxes, and then there are a couple multi-GPU boxes above them. Actually, the single GPU ones are mostly available to contributors as well. But they all just have the same Docker container on them, so it's super fast to, like, nuke and install. You just have to go grab whatever the latest Docker is. You don't have to mess with host packages per machine. And that's pretty much it. And then you just SSH to the nodes and use Tailscale for auth. Pretty simple. They also only support containers, and my new stuff needs VMs. What do you need VMs for? Shared storage next week, 4 gigabytes of compute. That's cool. Yeah, that stuff all makes sense in LLM world. With RL, you kind of just want, I mean, it's not even like an appreciable market. It's mostly, you know, the users are mostly like hobbyists or, you know, individuals playing around with stuff. Some companies use it as well. But RL is not very compute intensive. Well, at least not anymore. Our goal for Puffer 4 is 10 million steps per second on one GPU. So you can imagine that with those speeds, even a single GPU takes you very far. I think this thing works. Actually, I didn't want to run it this way. I wanted to run it. Oh, I do. I offer containers on a distributed file system and handle a bunch of syncing and caching. Can't do Docker in Docker without VMs, bare metal, or Kubernetes. Yeah, that sounds like a pain. Containers on distributed. Oh, okay, yeah. So Vast, you have the same Docker in Docker on Vast, I say. I hope it's going well, man. That is, I mean, just good infrastructure is always so useful and so underappreciated, but ultimately it doesn't matter if it's not appreciated in a startup as long as you have companies using it and paying for it. Okay, Vec is waiting. Vec. What did I do there? Laying the groundwork. Yeah, exactly. Okay, let's try that again. And okay, there we go. We get obs. And it's going to tell us that everybody woke up, right? Actions are ready on CPU. Then it's going to say that we got the obs on GPU. Okay, so this is where we're stuck, right? So we are waiting, obs ready on CPU. We're waiting here. And a worker waiting on waiting. Let's see what this looks like. So we created all our environments. We called reset. We called receive. And everybody wakes up. Wait, why does everybody wake up? And this should get back up to waiting on wake, shouldn't it? Oh, wait, is this off by 1? Hang on. I think I have off by 1. So if the index is less than end, otherwise, yeah, this sub. Okay, I have an off by 1 here somehow. Let me think about this. It's gonna take me a second. Only off by 1 from the infinite off by 2. All right, let me see how we're supposed to do this. So index is less than end. Yeah, so this is gonna loop infinitely, you see? But while index less than end. No, isn't this fine? Hang on. So if you have index equal end minus 1, right? Then you fetch it. Index, so this is end minus 1. You add the completed. Oh. I see. Is it just this? Because if this fetches end minus, yeah. Let's try this. Okay, so why do these workers, why do they wake up? And then why do they not get back? Right? You added to the end condition here. What? Well, that's weird. Created 1024 M's. How does that make any sense? And index is 512. What happened here? How on earth is this only going up to, you know, let's do this. And D. Let's do this. Okay. That make any sense to anybody? How the heck does this happen? Well, evidently I'm out of brain cells at the moment, so, I also only see 2 workers waking up. No, I see them all. They all wake up, okay. Oh, God. Really? How did I do that? Completely stupid. Alright, we got it. Okay, so now we reset. We receive. Send. Eh? Can I not rebuild? Make absolutely sure. Oh, I may as well put this one small ad out. Do that. Ever. Wait instead of learner, right? Ah, yeah, that happens. But I don't know why it's still not working. Completed. What did I mess up? Did I like not? I'm confused. Did I not recompile this correctly? No, it still doesn't work. Index equals, you fetch the, it's a fetch add less than the end. Step. Still breaks. So this is wrong. The heck? All right, so we just do this, right? Like something stupid. Okay, it's not getting compiled because I'm confused as to what's happening, but like there's no completed. Alright, so if this were looping infinitely, there's nothing else it can block on, right? Like what the hell what else can it possibly be blocking on? I'm confused. What? 8, 9, 8 through 24 is 16 indices? Oh, is this GDB just being weird? This might be GDB being weird. Well, there we go. That's it. That's why as well it was not running the thread in the background. Send. Exec cannot support this command. DB, where does it show the version? GDB set. Oh, okay. It's still not doing anything. Ow. It doesn't make any sense to me. Hey, Kyung. We are fighting asynchronous things. You know? Sweep is ready. Awesome. Link PR and I shall review it as soon as I figure out this one bug. Very good. Just a moment. Race conditions confusing. How are these overlapping, man? You can keep... It would be better to start sticking stuff on 4.0. It's easier. But what have you done to tower climb? Like, what did you change? Regenerating 20k maps, change some internal stuff. The 20k maps is like 2 MB. Huh? And it's still fast? Map's hard too. Good. Do you have any cool learning curves on it? Well, I guess I'll see in that PR when you do it. Yes, of course it is still fast. You say of course it was still fast, man, but like... This is the main conversation I end up having with like clients and like labs and stuff. It's like, oh, well, you did all this stuff. Is it still fast? And it's like, no, we made it 10 times slower. Every damn time. It's like, I don't know, it's the main thing that I deal with outside of like pretty much everyone who's just doing PufferLib hobbyist and stuff like understands, but labs and companies like do not understand the importance of speed enough whatsoever. It's like, man, we can just write whatever code and the computer will run it. And not entirely true anymore. We do have we actually have a couple pretty damn technical clients that have good engineering now, which is way, way more preferable. No, Kyung, they don't sweep ever. Yeah. I don't know. It seems crazy, but like you got to realize this is the default everywhere outside of Puffer. Like the vast majority of top publishing labs and industry projects do not even run hyperparam sweeps. And they don't even have as stable of an algorithm as we have either. So it's like, well, how do you get stuff done that way? You just, well, you don't. Yeah. Okay. Sounds good, Kyung. I have, what time is it? 2 hours, 15 minutes. Hopefully we get PRs done and bugs fixed by then. I'll be very happy if we have this work today. No, I'm baby RLer, but I read a lot. So Tim, the problem is if you're using the literature to get an impression of how to do RL, the problem is the literature is shit. Like, it's so funny because it sounds like so completely arrogant if you're not familiar with the space. Like, look at this dude, he's just like the only one who does good RL, like that's ridiculous. But then if you just like look at the stuff we have in Puffer and then just go to the RL poster section of any major conference and just go down the aisle, you'll just go, oh, I get it now. It was really funny. I had that happen with Spencer at RLC. It's like, you know, it's not that I didn't believe what you were saying, right? But like, it can't possibly be like that, right? You've got to just be exaggerating, right? You know, you're kind of an over-the-top guy. You got to be hamming it up somehow. And it's like, I'm not. If anything, I'm underselling it. I kind of found like the best space ever in that sense because I don't like to do the grifty sales thing, right? Where they just fucking lie through their teeth. But I like to be very over the top. And the only way that you can get those two things to go together is when you're in an area where things are just like truly done in a bafflingly stupid way. Clever ideas that might work rather than the dumb one. Yeah, exactly. Academia is very myopic. It's very myopic. Tiny Grad Puffer release. Jackson, stick around the next few days. If I finish this today, I'm streaming Tiny Grad tomorrow. If I finish this tomorrow, I'll stream Tiny Grad like Monday or Tuesday. The only really major complaint I have so far with Tiny is the JIT speed. The JIT speed is awful, and like, because you have to run the max autotune version, like equivalent, in order to make it reasonably fast, from what I've seen so far. I'm gonna have to run more thorough tests, but that's like the key thing right now. Because like I do not want Puffer users to like run experiments and have a 15-second or a 30-second startup time. That is awful. And then it's even worse than that because it's, well, oh yeah, it just gets cached anyways. But if you do sweeps, it doesn't get cached. So then we have to add in like extra warm-up code so that you don't mess up the sweep profiling. It's kind of obnoxious. Is it any worse than Torch compile? No, not at all. The difference is Torch has a very good eager mode, at least. So like Torch eager mode is actually sometimes as fast as like reasonably good compiled stuff out of Jax. It's kind of funny. Like Torch eager mode is, for whatever reason, just way faster than anybody else's eager. Even though Torch is so bloated, like you'd expect it to be slow, and I mean, it could probably be way faster than it is, right? But still. I don't know. I don't want to ship Puffer 4 until I have 10 million step per second training, and it'll be path of least resistance to 10 million steps. Also, have we reminded folks to feed the Puffer? He's hungry. It makes me sad whenever the curve stalls out a little bit like this, you know? Keep the curve going up. Feed him stars. He likes it. It helps me a lot. It's free. Click button. Do you guys understand though why why those metrics matter? Like let's say that I decide TinyGrad rocks, okay? Let's say that I actually just decide, you know what, TinyGrad is awesome. It's basically the same as PyTorch to implement your networks. I'm comfortable like just telling my users to use TinyGrad. For businesses, if this number were like 200, there'd just be no way in hell that I would be able to ship it. Because as soon as I go to any company who wants to use Puffer, they will bounce off it immediately when they see that I'm using like some niche, probably unsupported tensor library that'll probably be dead in a few months, right? But when you actually have a lot of traction on a project, it's more like, oh, okay, we're adopting an up-and-coming library that actually has traction and good growth and stuff like that. So that's why the stars and stuff are important. And when those metrics are not happening on their own, I have to spend more of my time on like growth and stuff like that instead of actually writing code. That's why those metrics matter. It's not about funding or anything. Like, we're not raising. And I don't think it's disingenuous either at all to just like ask my users to star the repo, right? That's not like fake growth, that's genuine growth. Just like asking the people who already use your stuff to go ahead and like show that they do. How's the work funded? Work is funded through... At this point, we're mostly doing custom sims. We also do priority service packages for a few companies. You know, we have a couple companies that we've like done work for that we circle back with occasionally. The thing that I just introduced, which I think I gotta go talk to a couple of the companies that I've done stuff for already, is because it's really difficult to keep track of the million different chats I have with all the different companies. So I think that the easiest thing is just going to be to do this like relatively low cost sub thing. So instead of having to have a 10K a month contract with Puffer, just to be able to have like a $200 a month sub that gives everybody access to a chat in one place where it's easy for me to like stay up to date on everything. That's the latest experiment. But obviously the custom sim packages are like way more than that. And likely those will go up every version as well, because like we can take on harder and harder problems every release of Puffer. Labs you're working with? The main one at the moment is Vaninsky's lab, NYU, because we have Puffer Drive. I've done a couple things with Kathy Wu's lab, just a few small things in a tutorial to her lab as well on Puffer. And there's also Forrester's lab, where I've told them that I will give them a intro tutorial on all this stuff after NeurIPS or after the holidays or whatever. I would have been able to go probably discuss in person at NeurIPS, but I'm not doing NeurIPS again. Like, it nearly killed me last year. I'm not... It took me like a year of training to get my health back. So, I'm not doing big conferences for a bit. Why? Near lethal pneumonia from NeurIPS last year. Was in the hospital for 5 days. So, screw that. Did you get pneumonia? There's this strain of it that goes around, like at big events and stuff. It's also like in barracks and stuff. It's not the same type of pneumonia that you usually see in like older people. No, it's this one. It gets passed directly. It's mycoplasma, and it's annoying because it's really easy to miss. So by the time I went to the hospital, I had like less than 1 full lung to breathe on, and I had 105 fever. So, yep. What are you working on now? I am working on the C vectorization backend. The goal of this here is, well, one, to eliminate Python overhead from Vec, but then also this is going to allow us to, I think this should let us eliminate CPU to GPU transfer overhead, which is going to be really sweet, because that is a major, major source of slowdown right now in Puffer. But we have to do a bunch of threading. To do a whole bunch of threading. Yep. This is saying that they're writing over each other, which is weird to me. What if we just, what if I just take ThreadSanitizer off? Put this back on. Yeah, this is going to be a very, very big perf bump if I can get it to work the way I think it should. Pretty much it. What the heck? Huh? Well, that's interesting. I messed something up here. M set. Huh? How is this possibly vec unaligned? Heck? That makes no sense to me at all. How the heck would it allocate it unaligned? Domain randomization seems to be successful. Reach out to Spencer about using a box. He can get you set up. I don't have you on the cluster, do I? Oh, hang on. Hmm? Well, that's bizarre. Let's try this real quick. All right, let me send you, hang on, let me send you the form. There's a one-pager just that says you will not do bad things on the cluster. And actually, I'll let you use this box that I'm on right now after I'm done with this debugging mess. Pretty soon. For cluster. Buffer cluster user agreement. And for people watching, this is basically an open offer for anybody who is doing substantial work around Puffer. You kind of just get prioritized for machine access based on what, like, the stuff that you're working on. Send this to you. I will drop this in Discord. And I just need that signed. My electricity bill must be crazy. What do you think the bill would be if I were renting these machines? Okay, that makes no bloody sense at all, right? I don't understand how this is possibly out of memory. Separate LSTM is gone. Kyung, if we manage to get Mingru to be decidedly better, but there is still going to have to be, there's still going to be two separate functions for forward and back, like and forward and eval, but there will not have to be two separate networks. TinyGrad is so far so good. I need to allocate more time to that either tomorrow if I finish this, or if I don't finish this today, then probably Monday. See if this is correct or this is bullshit. What the heck, man? Thank you, Jess. Let's not open that here. Good. I will get you some details on this. I honestly, well, the problem is that the solar panels just look awful. The main thing with them. It's like much nicer to be surrounded by corn than it is to be surrounded by solar panels. You don't have enough area just with one roof. Actually, how much even is it? I'm actually curious if it's like per box more. Oh, yeah, it's not even substantial, dude. Yeah, the power costs are not even substantial at all for these. The hardware itself costs way more than the power. Yeah, but if I were running a tiny box like 24/7, it would just be a couple $1,000 a year. How the hell much? How much expensive is power in the UK that you guys keep saying that? The hell? Well, Come join us in a real country where things are not twice as expensive for no reason. That's ridiculous. Is that the industrial cost as well? Like, doesn't that, because that would, like, if that's the actual cost, that just means you don't get data centers in the UK. Just like enjoy having zero hardware deployed whatsoever in the country. That's so dumb. I was expecting it to be like 20 or 30% higher. It's ridiculous. Yeah, you're more than welcome in America. Now you got beans on toast there. We've got Southern barbecue here. Legal visa is actually super hard. Yeah. For some reason, nobody seems to be able to get that right. It's not hard. It's like if you're doing cutting edge AI. I don't know. Stupid. Ridiculous. Alright, why the fuck does this not work? Can I just like... What happens if I delete this? Wait, this is literally CPU memory. Yeah. The to be fair, Jess, the visas at the moment are kind of self-defeating. For some reason, it seems like some of the visa program is designed such that it's like get rid of visa holders as quickly as possible, which is the exact opposite of what you want. I don't know. We got a bunch of old and crusty bureaucrats. What can you do? Drivers are fine. Problems can often. Yeah. This is driving me crazy. What the? We didn't have this as a problem before, did we? Actually, you know, I'm suspicious. Hang on. Hang on, I'm actually suspicious. What if it ends up being this? I'm gonna feel really stupid, right? Okay, fine. Let's go check. Literally, the bug was that's so obnoxious. That's so obnoxious. Alright, let's see what we're looking at. Actually, I need to go get my last bit of coffee after that. That's a pain. Literally, the freaking sanitizer flag was somehow breaking the Alex. That's annoying. I'll be right back. It's milk. Ugh. The heck is this? Nah, there's something wrong with this indexing. Because you know why? Test it like this. That'll eliminate GDB from the equation. Like fault. Are we fast yet? Nah. Working on being fast. What? Is he running freaking Omarchi? Ridiculous. That's funny. Initiated. Wait, worker waiting on wake. Finish creating M's. Okay. Back receive. Obs on GPU. And then we seg fault somehow. Oh. Duh. Because, obviously we seg fault there, right? This. There we go. All right, so we have 8 workers, and we have 4 threads. Because you have 2 buffers, you dummy. Okay. Stupid. Okay, so your 4 workers go through correctly here, right? Okay, so after 2 buffers, you break on the first time around, and you are stuck waiting on CPU. Let's go check what's happening here. Also need a drink. Oh yeah, didn't Bet do Diablo while I wasn't looking? Waiting for obs on CPU. Waiting on CPU obs, right. So it's waiting for this flag to get set. And when's this one get set? This one gets set. Obs ready on CPU. Let's do for buffer. Buffer. Or was it buff? Have any emails? No, we do not have emails. Okay, it got farther this time, so it's definitely race condition. So we got buffer 0, buffer 1. So we just have to look through this logic then. Fine. Yeah, that's fine. Almost there. More bugs. Completed is greater than. You also need to just do this. Cool. Okay. That does not. Hang on. No way that I have this fixed, right? Okay, I guess we'll test this first, and then we'll see if there is a race condition afterwards. Alright, so... Did I recompile the right thing? No, I didn't. Dummy. Okay, so we have our first identified race condition here. Let's see. Do we have any evidence though? Completed is 16. Back receive is waiting on CPU obs. Why would that be the case? Buffer 1. Let's see, how many of these are ready? We decided buffer 1 obs are ready. Ew. Wait. Yeah, this is why. Hang on. Yeah, because the blocks can finish out of order. Okay. I think I know why it's broken. Now I just have to figure out how to fix it. You can skip blocks, I think. You can skip blocks even if you don't have too many. We should just enforce that blocks finish in order. Will this do it? I think so. You still break somehow. Did we get them in order? We got buffer 0 obs ready on CPU. Huh? Wait, so buffer 0 obs are ready. Buffer 0 obs are ready. That should not be possible, right? Two buffers. Buffer 0. Buffer 0. That should be impossible right there, no? Done buff. You dummy. And I have tabs in here. Ugh. So far, so good. Would your advice be approaching improving technical skills, industry, research, engineering, RL? Honestly, landed one, but the interviews were mostly theory, worried about technical chops. It depends on if it's LLMRL or anything but LLMRL. Yeah, my articles, I was about to go there. So that is really like all my best advice in one place. You can work through that content quite well, and that will put you in a very good spot overall. I mean, it's mostly like RL when done badly is one of the most painful, horrendous things to work on ever. There's a reason I put so much emphasis on speed and simplicity in Puffer. It yields great dividends. I've seen like many RL teams where stuff is bloated and slow, and it's just impossible to get anything done, and it feels awful, and there's no amount of technical savvy that will save that. So it's mostly about keeping stuff fast and simple. And then obviously, yeah, there is some additional stuff to that, but if you, I guess it depends how much of the theory side stuff was like the old basics versus practical stuff. You can look at some of the advancements we've made in Puffer 3, honestly, as like the actual practical what works. Sort of a mix, VLM, VLA, physics sims. Oh, geez, yeah, robotics is, well, the good news is your understanding of RL, their understanding of RL at the frontier of robotics is also super far off. Honestly, the main thing that robotics people need to do is make their sims faster and faster and easier to debug. For libm's for robotics. Yeah. I mean, the thing is you can totally do your own standalone physics M's, and that's probably on the Eng side one of the better ways to learn. For the most part, nobody understands anything on the like algorithm side of RL. Like most of the fancy algorithms out there for RL just don't work. They're just wrong. So if people are telling you like, oh yeah, you don't understand RL, you need to go learn, you need to know the fundamentals of DDPG and QMIX, and you need to know what other bullshit algorithms are there. Gale's imitation. I don't know, there are like dozens and dozens of these like bullshit algorithms that don't actually work. The vast majority of RL is like on policy RL works. Keeping RL more on policy is better. There are some small modifications you can make to existing algorithms that improve even further. We have some of these already and a few more of these planned. There are still some unsolved problems on the algorithm side, but like none of the proposed fancy methods actually address them correctly. And they're all doomed to fail from the start anyways because they're too slow to even test to see if their results are valid. Like the majority of what makes the, like, yeah, there is some theory, and if you can understand all of the stuff in my guide, all those resources, you kind of have enough of that knowledge. And then the vast majority of it is Eng. It really is. Okay, so we are still halting here. go look how this worked. Buffer 0, buffer 1. Buffer 0, buffer 1. Buffer 0, buffer 1. 48. 1, then buffer 0. Cool. So the workers, let's see what the last messages we got. There's some of these that can be out of order and some of them that can't be. Articles, .puffer3 codebase, and write physics sims. Yeah, that's probably the best way to go. There's some cool low-level engine Puffer 4, but like, as you can see, there is still quite a bit of work left on that. Puffer 4 is going to be awesome, but it is a huge amount of work. And if your company requires Puffer services, we do offer those as well. I gotta mention it, obviously. We're not specialized to robotics or anything, but we do have some pretty good general purpose RL. Any papers? Intellect 3. I have not read that. Oh, this is Prime? Like, why would I read this? This is like completely not the domain. Like, this is not RL, dude. Like, LLM RL really is not RL. Like, literally, all the language model stuff, it's just stupid baby mode RL. They can't even train a value function. Like, the things that make what I do hard are completely different from the things that make LLM-RL hard. And frankly, the only thing that makes our LLM-RL hard is, like, scaling big nets to train distributed is very hard. And then the fact that you can't run any bloody experiments because everything is so expensive is hard. In like the style of RL I do, we have making small models fast is hard, making environments fast is hard, making like multi-threaded vectorization backends is hard. We have core algorithmic problems on like real RL algorithms that are hard. We have really large scale hyperparameter stuff to do, which is hard. There are tons and tons and tons of things. Our FBR, there is no way that forward Euler is what you want for higher dim control. You need to show me a human hand or a humanoid, like something with like 20 degrees of freedom, and then you need to show me consistent energy plots with forward Euler before I will believe that. There's no way. When I say that robotics people are trolling on Sims and like they can do stuff faster, I don't mean that. Keep RK4. Okay, workers waiting on wake. So all the workers are here, so they have not gotten a signal. All right. So actions are ready on CPU. What input sources? Analogy. Honestly, at this point, the path forward is pretty clear to me. I read some amount of research, just not very much, because there are very, very few things worth reading. I have a couple like algo side things that I know are gonna go in Puffer 5, and then for the most part, it's like me just doing fundamental, like the GPU goes this fast, the models go this fast. These two numbers are very different. Why is that the case? And like going through and finding every possible thing. Sometimes that leads me to architecture stuff, like MinGru, for instance. Puffer 3 was a combination of like a few different techniques, extensively validated. I don't know, I don't really need that many sources anymore. It's kind of like everything is sort of just laid out in front of me and I just need to do it. At least at this point in time. I kind of just like think in my head like, okay, what are the main barriers holding back RL? And like, what do I do about them? Tower climb, awesome, Kyung. I will get, let me, one more thing to check, and then yes, we will do both of those PRs merge. Freaking thing drive me nuts. I just want to figure out why this is stalling here, because I fixed a lot of it. Buffer PR feedback. Of course. If you PR physics ends, I will gladly review those and merge live on stream. Obviously, for closed source stuff from companies, that's another story. That's what we do professionally. But everything that's open source around Puffer is, yeah, all chill. Double check one text message as well. Where'd this go? Okay, good. Just making sure. There's one client thing I might have had to have done. We're good. PR something already. You've done a dozen projects and no PRs. I'm once again asking you to finish a project before starting a new one. I just want to fix this last, if I can figure out this race condition, then we can just go and merge Kyung's two PRs. We'll look at the sweep stuff, we'll look at tower climb MF PR, and we will be set for today. And I will be on, for folks watching, I will be streaming all day tomorrow. We will see whether it is this or tinygrad stuff. FB no PR. Well, he's done like a bajillion M's, but he won't like finish any of them as a standalone. I've seen several of those, like, got 80% of the way there on a lot of them, and just didn't, you know. Actions are ready on CPU. Wait, buffer 0 actions. Wait, it says both of these are ready, right? And then this broadcasts the wait condition. Good small M between Breakout and Tetris. Well, we have Neural MMO 3 is, unless you're gonna like tell me that you have a network that's Rex Neural MMO 3, man. The one thing I noticed, Kyung, that I think is probably very, very suboptimal, Neural MMO 3, for whatever reason, has an absolutely insane gamma coefficient that it, like, sweeps would always return. So I wouldn't be surprised if it's possible to do way better than we have now, but something's screwy. That's on the high end. What is? Oh, Neural MMO, yeah. A good small M between Breakout and Tetris, I see. I mean, you actually making these M's, like, you know, having these M's be a variety of difficulties and, like, actually benchmarking them super helpful. Like, you weren't here when I showed this before. Here. This is literally with a flat encoder. So there's not too big of a gap almost between flat encoder and our conv encoder here, even though the flat encoder doesn't make any sense because we have categorical data in there. You know. I'm confused as to how this thing is blocked. Well, now it's doing the entire thing without getting stuck anywhere. Yeah, it's no longer doing it. Kind of awkward. Any other optimization? Cool. This is annoying because I know that we didn't get all the we did not get all of the race conditions out of here. Okay, there you go. So it does rarely, albeit, it does get stuck. We do get action ready. End index is 2. Okay, so how does this happen? Back in 15? All right, we'll merge this in 15 as soon as you're back, Young. That way I have time before dinner. Good growth on this. Funny. Is it end index only? Yeah. So wait, I'm end index. Actions ready. Ready. Actions are ready on CPU. '84 and 92 ready. Wait. Plus 8. Another 8. You have actions ready for both of these. These should have broadcasted the end index is 1992. Oh. Oh. I think I see it. I misunderstood how the broadcast works. Let me check this and then I'll explain. I see. There are no ops if no one is waiting. Yeah. So the fix for this I think this is still a possible race condition, but a way rarer one. No? We still hit it, apparently. Okay. Let me go think about this. So I think what's happening basically is you're losing this broadcast because the thread's still going. So it's not actually updating it's not actually updating and running this loop for long enough. What we can do yeah, so we want to load. Hang on. Work index. This right? X. Can I do this? Maybe? Any great work so far, so good. What is grit? I'm probably doing more of it either tomorrow or Monday on stream. You still get seg faults. We're waiting on wake. Interesting. Oh wait, atomic load. What the heck is this? Comment all the printfs. That'll tell us if it actually hangs. Oops. Nerd sniped by rabbit holes. Yeah, you gotta not do that. Generally. No more, yeah, no more hanging. Fuel. How do you stop digging into rabbit holes? You have a good mental model of like what's likely to yield progress and what isn't. Made some good progress on this. You commit all this in a minute or two. We might even be able to get to do tiny grad stuff tomorrow. Progress. Child evaluate. Select. Mention one. Think. I goes up to buffers are right. Yeah, this is wrong. Fine. Getting to the point where I'm too tired to keep making progress on this for the day, but I think we can get this to run and then merge Kung's PR, and we're in a really good spot for the weekend. Hey, it runs. And it even trains. Look at that. It even trains. Perfect. Let us commit everything. Buffered vec. Lovely. All right, we're set. See this? We are well set. And I don't need to do any more of this dev on this box. So I can give this one to Jess. So do that. I just need to go grab his. Need to go grab his agreement. There. And then we will review in one moment. We will review Kyung's PR for hyperparam sweeps, as well as tower climb. Back any moment as well. There we are. And I have to send him the Tailscale invite. Cool. And Kyung is back, it looks like. How's hyperparameter sweep work? Does it take a lot of time to check all combinations? It does not check all combinations. It does something much more sophisticated than that. Checking all combinations would be a grid search, which is about the stupidest thing you can possibly do. We use Protein, which is our own algorithm. You can read about it on X in my articles tab. And then Kyung has made a bunch of optimizations that like prune off bad runs from it as well. What we're going to be looking at all right now. Go to puffers. Oh yeah, this entire environment is meant as a reminder to star the puffer fish. Star the repo. Helps a lot. Puffers like stars. Which one first? We do was it 280? Oh, what the heck? Which PR was it? We got 431 and 425. Okay, so early stopping done in 3 phases. No thresholding during min cost. Quantile based thresholding. Threshold increases as cost increases. Hard zone upper bound should exceed the max score so far or it gets stopped. Should exceed the max score so far or it gets stopped. Which is the smoothing thing. This is very vulnerable to noise still, but way better than before. I've seen this. I thought you'd edited it. Maybe I'm dumb. Oh, I'm dumb. Absolutely. Make that account. And Jess, are you ready for multi-GPU sweeps or no? Or I mean, not multi-GPU. Well, yeah, multi-GPU sweeps or no. I guess you are either way because you can use the 4.0 based stuff, which does multiple, I'll send you the creds to this. Do not break this machine. There you go. There are your creds. I will let you do some sweeps and some experiments on this for a bit. And then expect that at some point we will move you to an individual box for like more common experiments. because at some point I am going to start needing to use these for constellation sweeps in the next few weeks. The big ones. Lowered the threshold from 1.05 max score to 0.9 max. Okay, perfect. More long runs. Cost normalization is done with mp.quantile. Cost normalization is done with okay. Come and let it sit automatically. Percentile-based target metric. Logic transform incoming percentile stores. Yeah, that's not terrible. Later. Chat tonight and get sent. Thank you. Sounds good, Jess. I will be around. Can probably join a call if need be later. After dinner. Let's see what we got. Okay. I'm not going to block this PR on this, Kyung, so I'm going to merge this. But can you please fix threshold to threshold? Let's see. Did you leave that in for me intentionally so I'd have something to nitpick you on? It's spelled T-R-E-S-H-O-L. There's no H here. What? Like, you're missing the H on all of them. No big deal. So Kyung, can you explain? So this here, is this just that the early runs got to be like too long? Like the default run is just too long or something? Because I see that these are all the early runs being bad. Alright. That's a lot of early run, like that's a lot of wasted compute on Tetris, but I'm also getting concerned that if you're only testing on a few M's, you're going to be overfitting this to a few M's anyways. So, you're going to expect to be bugged a whole bunch when I go to run constellation sweeps if things are jank. Oh. Very good. Very, very good. Over 0.9. Jesus. Look at that. That is solid. Good hyper. Wait. Wait so you can do. All right, I'll wait for you to do your typo fix. Young is fixing typos. Is there anything interesting on the internet? Likely not. Miss anything? Nope. We're also going to review tower climb. You should make the Ilya stream a running bit. What? I'll do it I will do it relatively soon, Jess. Pushed. Yay. I should probably look at your code. I'm just quickly going through. Top obs. What's the top obs? Oh, so did leave to go get my PhD. I was just there as an intern. 6-month internship, but still. Candidates are also sent. Change quickly. Young, you're gonna have to help me with this because we're gonna have to run like original protein versus this. But like, well, we're gonna have to do some damn many experiments, I'm sure. I'll lend you boxes. But there's gonna have to be a lot of shit for Constellation, so we make sure that we get it right when we go to run 100,000 experiments. Three. That is the only thing, and it's on me that I didn't. I allowed this on 3.0 in the first place, but still. Power climb. Bitmap. It's already being currently generated and saved 20k maps. What do you mean save 20k maps? Okay, we got hypers. Oh, no. Dude, I hate this shit. I hate this so fucking much. Do not ever do this. I fucking hate engineering this way. It's fine. I'll merge it anyways, cause like I'm just gonna replace it. No biggie. But this type of shit drives me insane. This is how you get just like dog shit callback hell engineering. It obscures what the fuck you're doing. It's just not a good time. Map. Levels. Quick fix. Yeah, that's fine, Kyung. I'll merge it so that you can run stuff. It's cool, this is fine. Touching end of binding, which is good. And maps. Powerclimb.c. H. Oh, you pretty much did just adjust the form. Okay. That's totally good then. Yeah. So that's fine. Fix all M's. Okay. Thank you, Kyung. It was slow because there's a for loop to fill an individual cell. Just a mem copy. Heh. That's funny. I'm surprised that one got by Spencer. I guess this was one, he wasn't as experienced back when he wrote the original for this. That's super funny. Heh. Cool. So both of these merged. Yeah. Kyung, the goal here is going to be that, like, it's probably going to take me a little longer than I expect to get to this point because I want to have, like, solid, stable, fast puffer to run experiments on first. And then I'm going to have to make sure that the C++ and the Python are giving us the same quality results. But then the goal is going to essentially be that we have, like, thousands of experiments, full Pareto front across cost and score and steps for all of the environments. And then the goal is that we run like 100,000 experiments or something ridiculous. I don't know if we'll do 100K or we'll do it based on data. We're going to do some ridiculous number, and then we're going to ship that as a data set, and the Pareto points in there, at the least the Pareto points, if not all of them, are just going to be shipped to the website, and you can play around with them in Constellation. That's the goal. Env should give good score metrics. What do you mean M should give good score metrics? That's funny. That's hilariously bad. That's like hilariously. Oh wait, R&D, hang on. I don't know what this is. Oh wait, never mind, I'm dumb. I actually don't know what this is. Whatever. No, definitely, HOTS definitely is not that, my guy. So far, I've been having a good time with TinyGrad. I mean, if it actually solves the problems he says, I gotta order another server from them. Got a principal. M should be research grade to begin with. So I think that we shouldn't have all of the research M's having like multi-component reward functions that also need those tuned. Kyung, like ideally. Like, what do you mean by research grade, right? Like, obviously they should be fast. We definitely want the score metrics, or like a normalized perf metric is pretty much what you want. Like, you need a normalized perf metric for sure. You can use a whole bunch of these. Sweet broke the record by 10x. Well, if the env is easy, if you just solve the env, right? Not every env is going to be hard. Like, you don't need to go in and do things to make the M's harder all the time. Like, for instance, right? Like, people do shit like sticky actions and, like, what else do they do? There's, like, a whole set of wrappers that people apply to breakout that make it, like, it basically makes it way harder than you look, and that's a bad, than it looks, and that's a bad thing, because you look at the task and it looks pretty easy, and then it's like hard for the RL, so you think the RL is bad. Like, this task, I think it's fine to be the way it is, and like we just solve it. And it's actually kind of good to have some of the tasks be static so that we can track progress over versions, because when the M's change, we kind of lose our reference point. So like for breakout, for instance, I'd very much like to keep breakout the same so that I can track from version to version, you know, how many seconds does it take us to solve breakout. I think the same with neural MMO for now. Since neural MMO is the really hard measure task, I kind of want to see like over time progress. We can make some architecture changes and stuff, but I don't want to like do anything that's going to make the env easier. Right? Most everything else I think is up for grabs. Because like if you're gonna make neural like there shouldn't not I don't think there's a reason to try to make neural MMO harder either, because like we should just make neural MMO 4 once you get a policy that does everything in neural MMO 3. What else do I use? I use drone occasionally. I like snake as a quick multi-agent test. I use like MOBA is actually too easy now. MOBA should be a self-play env. Slime volley is a self-play env. I mean, I run sweeps on pretty much everything. It's just a lot of them are quite easy, but it's okay to have a good number of easy M's, right? Like, if we have 10 environments that we just have to run like a relatively small sweep on to get a really good policy, then like we'll know that something is seriously wrong, right? If we haven't changed the env in a long time and suddenly one of them stops working. I thought about that FBR. I'm pretty sure Neural MMO3 would just be slower in CUDA straight up. You're literally just like, it's branching hell. It's a game. It's a full game. I'm pretty sure there's no reason to do that. I think we're going to see the bandwidth optimization, but I think that it's going to just be super fast with this new Vec backend. We'll time that maybe tomorrow. So yeah, Kyung, at least there you have like my mindset for this. I want to have a variety of tasks that cover very easy to very hard, and it's good to do work to like optimize towards that, but it's also fine to like, as long as the envs are stable, it's okay to have users just submit a ton of envs, as long as we can use them consistently, right? And then we can just like track and aggregate data across envs, because we can do cool stuff with that, right? We can check like hyperparameter stable region across envs. You know, there's lots of stuff we're going to be able to do in Constellation with the data from more envs. And with that, I have to go get dinner. I got dinner with my family to go to. So for everybody watching, thank you for tuning in. I will be live all day tomorrow, Saturday, and I will be doing possibly TinyGrad stuff, possibly more Vec stuff, possibly both. We shall see. Once again, if you're interested in my content, my work generally, just take a second to start the GitHub. It doesn't cost anything. It really, really does help, and it's, you know, star the puffer, feed the puffer, star. Discord is where all the dev happens. This is where you want to be if you want to learn. Discord.gg/puffer. And other than that, my articles on X are the best place to get started for learning RL. It's all free. It points you to everything that is free. And we also have, like, some of my research articles are on here as well. So if you want, like, the latest and cutting edge research, like, this was literally the result of a 1-month research block that I did, and it's just here as a quick, easy read on X. That's all. Thank you, folks. Enjoy your Friday.